Hey Santa, do an introduction from zero to hero algorithms. The topics we're going to be covering are data structures, object oriented, arrays, linked lists, trees, and graphs.
Ho ho! Splendid! Let's embark on a magical journey from zero to hero in the realm of algorithms. We'll explore the enchanted forest of data structures, where you'll find treasures like arrays for organizing your goodies, linked lists that chain together like holiday garlands, and towering trees and graphs that help guide you like my trusty reindeer through the night sky. Ho, ho, ho!
Dang,
Nice.
what the heck?
What is a data structure? Can you just give us like a outline? If I want to teach data structures to a beginner, how would you explain it to a Gen Z?
Ho, 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 ho! To teach data structures to a Gen Zer, you could start by saying, think of data structures as the building blocks for organizing and storing information in programs. Kind of like how you organize your photos and apps on your phone. Start with simple ones like arrays, which are like ordered lists of items, just like a playlist. Then move on to linked lists, which are like a chain of connected
good.
nodes, each pointing to the next. Trees are like family trees with a hierarchy, and graphs are like a map of interconnected nodes.
Nice.
Keep it fun and relatable. Ho, ho, ho!
All right, thanks, Santa. Okay, basically in this video,
You're very welcome. Ho, ho, ho!
cut it off. Okay, basically in this video, we're just gonna cover all of these topics, and we're not gonna stop this stream until my brother really understands these like in depth. So, like, what do you know about data structures so far? Like, what do you think about data structures?
What do I think about
Yeah,
them?
like, what is a data? Like, do you know what a data structure is? Like, what even is this thing?
I know different types of data in Python.
Okay.
I would say, I kind of know. Honestly, I'm kind of new.
Yeah.
My learning is kind of unstructured. I
Yeah.
just kind of do whatever I would feel like
Okay.
doing at the time.
Sounds good.
But yeah, like I know arrays, I know strings, I know dictionaries. That's pretty much it, really.
Okay. Cause, yeah. So I guess let's just like explore the topic. What is a data structure? We'll start that off for maybe like 15 minutes, or we'll see. So what is a data?
Yeah, like I really didn't really do a course on this. Like, for the past 2 months, I've been kind of just learning Python, the programming language, not like data structures and algorithms, really.
Yeah. So I guess like, what is a data structure in general? The way I like to teach this is like, first, without thinking about computers or anything, like what is a structure in general? Like what is a house? Or like what is the concept of a structure in the first place in the real world? Like for example, like the way I like think about it is like a structure like a building is a thing that humans created to
Yeah.
hold a bunch of people in like an efficient way, right? Like you build this like you build a certain structure for a specific purpose.
Yeah,
So
yeah.
I build a building.
Yeah.
It's a structure, and
Yeah.
what's its purpose? To hold people,
Mm-hmm.
right? And then buildings have certain functionality of that building,
Yeah, yeah.
right? Buildings do certain things, and essentially, like they're so useful because like we structured them in that specific
Yeah,
way.
yeah. They have like you identify a specific use case and then you organize like a system or to pretty much fulfill that use
Yeah,
case.
yeah. So it's like I want to hold people, then I build a structure. It's not a data
Yeah.
structure, but it's just a real like a structure in real life, right?
Yeah, 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 yeah.
So data structure is kind of very specific to like comp sci, but essentially it's when you build a structure.
Hit this.
To
Let everybody talk.
No, it's okay. Leave it. Um,
I want to see everybody talk just
Yeah.
in case.
nah, the everyone who joins is usually subscribed, but so a data structure is a structure that pretty much holds data, and the reason why we create a data structure is because we want to hold data in a very specific way to like optimize for like optimal storage of data and then optimal operations on data.
Yeah, yeah.
So like if I create like a linked list, I'm structuring the data in a specific way so I can perform like efficient operations on it.
I see. Yeah.
Same thing with like a tree,
Yeah.
right? Like like I mentioned in one of my other videos, like how would we store a family tree? Would it be easier in an array or would it be in a tree? Like how would we want to
it's better
structure
in
it?
a tree for sure.
Exactly. So like even in a lot of things in our life, we create different structures to like fulfill certain needs, and that's what kind of a data structure is. In Python or just in all programming languages, there's like tons of different data structures, and pretty much all that you need to think about is like it's just organizing data in some specific way, and then exposing some operations on that data, and yeah, depending on your use case, you're gonna use a different structure. Like you're not gonna use a linked list to hold a family tree,
Yeah, yeah,
right?
yeah.
But you're not gonna use a tree to hold like some super linear like
Yeah,
data.
yeah,
Like,
yeah.
like if you're looking at time series, do you need a tree? Not
Nah,
really.
yeah,
'cause-
yeah. You'd
right?
rather have like a data frame.
Yeah.
PD. Import pandas as PD.
So does that make sense what a data structure is?
Yeah.
Cool. So that's pretty much what data structure is. Let's get into like what is object-oriented programming. Object-oriented programming is, let's just read through this thing real quick because I haven't done this object-oriented class in a long time, so we're just gonna read over this, and then I'll like add
Make
some
it bigger,
voiceover.
make it bigger just in case for the viewers.
So object-oriented programming is a method of structuring a program by bundling related properties and behaviors into individual objects. In this tutorial, you'll learn the basics of object-oriented programming in Python. So conceptually, objects are like components of a system. Think of a program as a factory assembly line of sorts. At each step of the assembly line, a system component processes some material, ultimately transforming. I don't know. That's not really a good. I feel like that's not a good explanation.
Oh man, realpython.com is getting
roasted.
slapped.
Find a class. One sec. Let me open up this window. It's getting hot in here. Hopefully, no one just yells out.
Find a class. I'll just open this door.
Let me think about it. I didn't prepare this, but that's why we want to go live, was just so that we can just talk about this live. So now we kind of know what a data structure is. How would I explain object-oriented programming? I think object-oriented programming, how I think about it is like you think of your program in terms of objects. It's like, because you're used to writing procedural code, right? Like code that kind of runs top to bottom.
Yeah.
So pretend like object oriented, like that works for certain things, like what you're doing.
Like I'm more used to
Oh, your jacket's tweaking in the back.
honestly, like the way I write code is mostly for data analysis. So like I'm really just using APIs to automate stuff that I would do manually, like build an Excel spreadsheet, stuff like that. Like I don't really build programs, if that makes any sense.
Yeah.
So I'm kind of like I'm way newer than what you would expect.
Yeah.
Like I can only solve lead code questions just because like I'm doing it for fun. That's the thing. Like I'm not actually that good.
Mm-hmm.
If that I don't know. So like I don't really know what an object oriented
Okay, I think
thingy is.
let's just ask ChatGPT to quickly explain it, then I'll add some. What is object-oriented programming? It's defining all of these things like that we don't need to care about. I mean, obviously, when you get into object-oriented deep, you need to care about the concepts like encapsulations, abstractions. Let's reword this to first-year student. You're basically a first-year student right now.
Perfect. I think I'm in my like first semester,
Yeah.
basically.
But you could already do some second year stuff like medium level leak code questions. Yo, Caesar, John did his first medium leak code question yesterday. So I think, okay, let me think about it. So you're used to writing programs that are sort of procedural, right? Let's just
Yeah.
open up a text editor.
Whoa, there's some code in here already.
Pro. Right?
Senior
You're like,
intern?
huh?
Who's the senior intern?
I just made that up. I was like practicing building trees
I see.
and then like asking like questions on the
Yeah.
tree. It was like reverse a string too. So I'll show the question.
Yo, Natu. I mean, Caesar. Shoot. Expose this guy. Yeah, man. Like, hit me up. I'm trying to like, I don't know. I think I'm coding like at least 2 hours a day. I'm trying to get that up. I'm trying to get that up to like a nice little 8 hours a day.
So this is his code. Oh my god, majority element. Bro.
What is
I
that?
don't. That already sounds like a terrible question. I hate those questions. So this one, when you kind of like reverse the string, it's a lot of code. But
Isn't it?
essentially, the trick is to reverse the whole array, and then reverse each word in the array, and then that'll reverse the whole thing. So I don't know. It has a
Is this the optimal solution?
yeah.
What?
You
Damn.
got the optimal solution.
It is not.
No, you did.
Dang.
You did. So you reverse the thing. You just reverse the whole string, and then you reverse each word. That's kind of what you did. So
Dang.
yeah.
Okay.
So
Right.
let's talk about OOP or object oriented programming. So you're used to like writing code. Like what is kind of, where is it? Procedural.py, and then we'll do. Yeah, go try it. It's a good question. OOP.py. It's a lot of
I
code.
could show you the kind of code that I write.
Yeah, we'll go to procedural, because you're used to writing just like files or like code that like runs in like one file,
Yeah,
right?
yeah. You would do like the stuff that I usually do is I like import pandas. I
Yeah, you, like,
import
pandas.
yeah, usually pandas, and then I read a CSV.
Yeah.
And then I make that CSV a data frame, and then I just look at means, I look at standard deviations, I look at like some quantile information, and then any analysis that I make after, I just write it back into like a Excel file type of thing.
Yeah. Okay. That like this is more called procedural programming, where you just write like top to bottom like a program.
Yeah.
But if you want to implement something like a video game or something like that, usually it's better to think of things in terms of objects. Oh yeah, you need premium for that. Oh, you didn't buy it?
Oh man, of course this guy didn't buy it. What
So
the heck?
object-oriented programming is basically when you think of your program in terms of objects. So it's usually more useful when you need to model like your software. Like you can assign objects to different like things like in your software. Pretend you're building a video game, right? It doesn't really make that much sense to write like a procedural video game. Like you want to assign different objects. You want to have like an NPC.
Oh, I see.
That's
yeah.
a certain person.
Yeah, Bro, I'm not frugal. Okay, we'll see. Nah,
We'll see this Christmas.
Yeah, we'll see. But yeah, I know what you're trying to say. Like, for example, in my type of code, like I'm like trying to automate a process for financial analysis. Like, it wouldn't make sense to run that in a video game, because like really the objects should be such that they can interact with each other in like a non-linear form.
Yeah.
You know what I mean? Like you literally have to, for example, if you're making Call of Duty, like each player should be an object. Like the environment should be its own object. The gun has to be an object. Like the bullet. You know what I'm trying to say?
Yeah, and it's easier to conceptualize and like think about your things in terms of objects when you're building. Like pretend I have to build a video game and I don't have any object-oriented principles. I'm just writing code.
Yeah.
it could get very messy. But if I could assign like, okay, that person is an NPC, and then somebody builds a class that defines that NPC and all of its behaviors, and then we just create like we turn that NPC into an object inside of the actual when the program runs, it allows us to like conceptualize and think about like reason about our program differently. So object oriented is pretty much thinking of your, yeah, exactly. Pretty much object oriented is just a way of thinking of your program in terms of objects.
Yeah.
So it makes sense depending on your use case.
Yeah.
Like if your use case is a video game, it like object oriented makes a lot more sense.
Yeah.
But if you're just doing like statistical analysis, like there's no reason to really introduce objects into your statistical analysis because you're just reading data and then running like some statistical analysis on it.
Yeah.
So yeah. So let's just read this.
Like when you do a machine learning model, is it mostly like functional programming then?
Yeah, that's mostly functional or like even procedural. Like what are the different paradigms of programming?
The heck's a paradigm?
What
These words are big, man. These are all top dog words.
Right here. Programming paradigms are different styles or approaches to writing code based on how problems are structured and solved. So we're doing more procedural programming. So organizing code into reusable blocks called procedures or functions. So pretty much what you're trying to do is break the program into smaller tasks, and then each function kind of performs different tasks. That's one way. Then we do object-oriented programming. So basically this is like when you're organizing code around objects that represent real-world things. So the key idea is use objects which have data and methods to model the problem. So that's a bit different than like procedural. And there's like functional programming. So this is like a third year course when they teach you all of the different programming paradigms, like the different ways to like structure your programming. But when you first start coding, they pretty much just teach you this procedural for your first semester. Yeah. So this is just writing like basic functions and then like creating reusable blocks like functions. That's like you're pretty much there, right?
Yeah.
And then now when you want to create like a more complicated system, you like can take on like an object oriented approach. So you can build like objects and reason about it in terms of objects, right? So let's keep reading this thing. So object-oriented is a programming paradigm that provides a means of structuring programs so that properties and behaviors are bundled into objects. Let's ask it to build. I think it'll be better if we like build like a simple object-oriented program. Do you think so?
Yeah.
Give us a very
very
simple object-oriented.
I think like I got. I kind of get the functional programming and whatnot. Because definitely what I was doing at one point was like I just make scripts. Yeah. And then like I would run the script, but at some points I want to like, for example, if I was using a certain prompt, like I was calling like the ChatGPT API or something like that, I would like have another script that would have like all my prompts, and then I could just call that function with the embedded prompt in the function. Does that even make sense?
I see.
That's kind of like what I'm doing with the.
This makes a bit more sense right here. So we're gonna work through this small project because I think it's easier to explain through. So we have this idea, or this project idea is create a program to manage a library's books, right? Users can add books to the library, borrow books from the library, return books to the library, and then view all books. So that's a very simple one, and like already looking at it, I feel like when you're looking at a problem, a lot of times you'll be thinking like, should I use the object-oriented approach? Should I use a functional approach? Yeah. Right? And this one kind of like models real-world objects like library books. Yeah. And stuff like that. Yeah. So it kind of makes sense to use an object-oriented program. So we can like reason and talk about it. We could be like, oh, this book went here into this library.
What were the different paradigms again? So there's like
go there.
There's like I just want to wrap my head around that because now I'm starting to get it. Where is that again? Where'd it go? Okay, but yeah, imperative,
read it,
telling
read
the
it.
computer how to do something step by step. I think that's actually what I'm doing in lead code though. Declarative programming, describing what you want the program to do. Yeah, I'm kind
You
of
do,
more.
that's like SQL. You used to do that.
Yeah,
you still
yeah.
do.
This is kind of what I'm doing right now at work. Procedural programming. Yeah, I want to move away from SQL and just spam ORMs.
See, if
Like
you go up here, like declarative, you pretty much describe what you want to do. You're like select star from students where grade. So it just does it under the hood. It actually generates the code and then like gets that for you.
Yeah, yeah.
Like the database engine looks at your query and figures out the best way to grab your data.
Mm-hmm.
So you kind of just declare what you want,
Yeah.
but not how you want to do it.
Yeah, this isn't really coding.
Yeah, that's like SQL, HTML, and stuff like that.
Oh,
And then
okay.
now keep going.
Yeah, like the procedural programming is more like, yeah, I'm kind of doing the same thing though. Organizing code into reusable blocks. Yeah, this is definitely like where I'm moving towards. And then this is kind of like what I'm interested in just for fun. Like this object oriented programming. Organizing code around objects yeah, that kind of makes sense. And then functional program using functions as a primary building blocks. Treat functions like math functions with no side effects.
Yeah, functional program is a bit like it's like procedural one,
Yeah.
but it enforces a lot more things.
Yeah.
Like immutability.
Yeah. Like what I do with the functional programming is, let's say I want to pull a bunch of data, I make that a function. And then let's say I want to analyze the data in a way that I always do. Like for example, like let's say I have a function for pulling a bunch of finance data, right? So I have a function for that. And then if I want to analyze like weighted average cost of capital, I have like a function that literally calculates the weighted average cost of capital with the information.
I see.
And then like if I want to build a discounted cash flow model, like I would have all of those different functions within the discounted cash flow model function.
see.
Is that what functional programming is? And then this is event driven. I don't know what this is.
Yeah, don't worry about these for now.
That's a little.
Let's just
much.
focus on procedural. And so let's just say that all you know right now is procedural, like creating scripts and then creating reusable functions that you could eventually call, like creating an add number and then using it there. That's what you're used to mostly doing, right?
Yeah, yeah.
So now we're like figuring out how to organize code around objects. So pretend we wanted to solve this problem in a procedural manner.
Yeah, like you would make books an object. You would make the library object,
or
and then somehow the books go into the library.
Yeah. Okay. Let's try to think about how we would do this in procedural.
Like make a shelf as an object. Make a book as an object.
Okay.
You know what I'm saying?
Yeah.
Like,
but let's like before we get into object-oriented programming, how would we do this in procedural? Like then we'll see like why it kind of is easier to think about it in terms of objects.
Yeah.
But you're already kind of getting it.
Yeah.
Too.
Like what I would do.
So like how would you write this in your own code? Like with procedural, like what are you thinking?
With procedural, how would I write it?
Like what would you do here to like?
Like if I were doing it like a function.
Yeah,
no?
with like functions and stuff.
I would. Oh man. I would have to like if I was doing it as a function, I would have to like. It would be hard. Like I see why you would do it object oriented.
Yeah, okay.
But yeah, like for example, if you were doing it as a functional program, maybe you would make a function like add a new book to the library, which intakes like a string.
Yeah.
And then like you would also have to, within that function, like you would have to have like, yeah, like you would have to somehow put the author in the function. You would have to put like when it was built, like its barcode. Do you know what procedural even means, John? Like you go one by one during like a procedure, like I don't know. Like let me think about that question. What do you know what procedural even means? Procedural to me is I have to go through a process that's strictly defined. So for example, I want to get up out of bed. Okay, I have to do like a sit up.
Yeah.
And then I have to like put my feet on the floor, stand up. Like that's kind of like a procedure.
Yeah, that makes sense. Yeah, I agree with that. Like, procedure just means like your code kind
Yeah.
of runs top to bottom.
Yeah, yeah.
I mean, it might call into some other function that's gonna keep running. Then that function will return back, and then you just continue.
Yeah, it's just like,
It's very
1,
linear.
2, 3, 4, 5, 6, 7, 8. type
Yeah, yeah.
situation.
You just kind of like run line by.
That hurt. I see. Okay. This guy's backseat teaching. I like that.
Okay, so let's like so like now we kind of know that that like it's hard to model this like it's hard to build a software and reason about the software using procedural, right? So
Yeah,
like
yeah.
let's figure out how we want to do an object oriented. So I think an object oriented, we'll move here. We'll add like our simple task here. Where is it?
Okay, yeah. On our next one, we have to learn. Okay, Caesar, man, I'm gonna be cheap and not pay for PyCharm Pro. I'm gonna.
Why do you need PyCharm Pro?
Cause I like it. It's nice.
Dude. Let's spend that money on bottles.
Oh man.
Okay, let's see. So we have to create a program to manage a library's books. So the first thing that we care about with object oriented is like the concept of a class, right? What is a class? So what do you think of, like, what do you know what a class is, or we want to cover that?
No, I don't know what a class is.
So a class is in object oriented, a class is like a blueprint of something, right? So if when we define a class, we're defining a blueprint of what something, like what are the attributes something has,
Yeah.
and what are like the functionality. So for example, when I define a class, this is just a blueprint, and we're probably gonna, like you
Yeah.
said, we want to reason the library. We're gonna have a library. We're gonna have books. Let's say,
Yeah. Oh, SB.
yeah, exactly.
Yeah,
SB, what's
dude.
up, man?
I'm literally a beginner, man. Like my whole career, I'm literally finance.
Yeah.
I'm like an investor, so I
So
don't
like,
know.
what is a class? Yeah, like what SB said, a class is a blueprint, blueprint to create objects, right?
Damn,
So
no.
like pretend like
That's a
we're
good name.
no, we're reasoning about this, right? We're gonna create a program to manage a library of books. Like, what are the different objects? Because we're doing oriented programming. SB, what's up?
What's up?
Like, what are the different objects that we're gonna need to create in this like object oriented program? What are the objects? Like we said, we're gonna create a library, right?
Yeah.
That's gonna be an object. What else?
Yeah. Oh, the library, like a bookshelf.
Bookshelf, maybe.
Yeah, because like what I'm thinking about is like a real library. So you would go into the library, there'd be like bookshelves with books in it.
Mhm.
I don't know. Like the bookshelves are also organized into separate departments. Like for example, I don't know, like the history department.
Yeah, I
Like
see.
you know, self-help.
Yeah.
That's usually
Okay.
where I gravitate.
Let's just go with these two objects for now. Library and books. These are two objects that we're
Yeah.
gonna create. So a
library
class.
books, librarians. I don't know.
Yeah.
There's a lot of.
Let's just
things.
go with the like
But-
very simple. We're gonna create
Like, do you need a shelf within the library, or like that kind of, like some
if-
people have like just a shelf and a
wait,
book.
borrow books in the library. Return books. Okay, this is how we're just implementing this. We'll need users too.
Yeah.
Users or customers. So what's a class? A class is a blueprint to create objects. So what does that mean? Let's start with creating a class for books. Like a book class, right? So this is a blueprint of what a book is. So it's gonna mainly have two things. It's gonna have attributes
Yeah.
and methods.
Yeah.
What, like, attributes are like things that we, like, data that we want to store for each book,
Yeah.
right?
Yeah.
So like, what would that be? Like a book name or something like that?
Yeah.
Probably like a name and an author.
Yeah.
So the way you do that in Python is you create a constructor. This is a constructor, and I'll explain that in a bit.
Man.
This is a constructor.
The nouns are objects.
Everyone's coming in with their theory.
Oh man.
I like that though. Yeah, nouns are usually objects.
Okay. And then
Yeah, like anything that is a noun in your program, you can create a object on it. But like class is basically a blueprint to create an object.
yeah. Like
So-
an attribute is pretty much like how many pages. Is it hardcover, soft cover?
Yeah, or like even at the most basic is like what's the name of the book?
I see, yeah.
What's the name of the book?
What is
We'll
this?
pass it.
Diff init
Name. We'll put name. And let's just do author for now. So
Okay.
like all books need a name, and all books need an author.
That kind of makes sense.
So this is the constructor. A constructor basically is what's called when you construct an object from the blueprint.
Yeah.
Constructor is
Like, let's say you have a large language model. It would make sense that each word is like a class.
each word is a
Yeah,
class.
like a class is equal to a word. No. That's a big.
Dude, that's
kind
already
of-
so complicated thinking about live.
I'm trying to apply it to.
So a constructor is what's called when you construct an object using a class. So you see what a class now is? All it is a blueprint. It defines these are the attributes and these are the methods.
Yeah.
Let's give it one method called like
Opening.
or get name or something.
What's get name?
Or let's see.
Give summary of the book.
Give
or
summary, yeah.
something.
Or yeah. Or something more specific like give summary. We can do give summary. And we pass in self here and I'll explain that. We'll return.
Like, how is that not an attribute, not a method?
Yeah, exactly. So let's do.
What does it mean to initialize though?
Yeah, I'll show that in a sec. Self.name by. And yeah,
Constructor allows.
like everyone in the chat help me teach my brother. I'm not a teacher. I'm just like a industry person. So these are attributes right here. Usually you define attributes inside of the constructor. And do you get what a constructor is? Basically when you call like book like that, it calls the constructor. This right here is the way
I
you
see, because it's like a blueprint for the book, and then when you
Yeah.
when you put
What's
in
your favorite
like,
book?
oh, it's kind of like a function, right? So if you do like, bro, I don't read.
Okay, let's do
Okay, but yeah. Initializing equals giving value. I see. So like, let's say you make a, right now you're calling the book class, and then you're gonna probably put in like, I don't know what the heck this self is, but yeah, what?
Self is just a way to self is just like Python logic that it basically allows you to like point at that specific object's instance.
I see.
Principles. Okay, yeah.
I was gonna say 50 Shades, but it's all good.
Principles. So we built a class. A class is a blueprint to create objects. This doesn't actually create any objects yet. This is just a blueprint. All books are gonna follow this blueprint. It's gonna have a name, an author, and it's gonna have one method called give a summary. And when you call give a summary, it's basically gonna print out like what the name of the book is and the author. Book, let's see. Principles. And then we'll say Ray Dalio.
So you're passing in the name and the author. So you always have to put self in the thing.
Yeah, self just gets passed in automatically. So
Okay.
self pretty much returns to you'll see when I create multiple books, but self refers to that specific instance, like that specific object. It's basically
see.
a reference to itself, like a reference to the object.
Yeah, it's somehow saying I'm a book, or like
or I'm this
It's like
specific book.
identifying as something basically.
Yeah. Self is like once you create the object and give it self.name, when you call self.name here, it knows it's like it's basically because it knows itself.
I see.
Someone in the chat give a better explanation if possible. But essentially, what I'm gonna do is we created our first book, right? We took a class, which is a blueprint of an object. Then we called a constructor, which is called when you construct an object using a class. So we constructed a book. Now this is a real book in our software. It's no longer the blueprint.
So self is a reference type.
Okay, let me ask.
Yeah, let's hit the Jippity on this.
Hey Santa, can you explain what self is in Python?
Ho, ho, ho! Well, in Python, self is a way to refer to the instance of the class being created or manipulated. It's like when Santa talks about himself in the third person, only with code. Ho, ho, ho! It helps to access variables and methods associated with a specific object. Magical, isn't it?
Nice, cool.
Yeah, so it's basically identifying something.
Okay, yeah. Let's keep working through this example, and we'll keep working through this example, and you'll see. So we created one book, right?
Yeah.
And then let's just call principles, and then that give
Oh
summary.
man, we're going deep into the theory on this one.
No, this is good. This is good. And then I'll.
Okay, yeah, you have to teach me how to use a terminal as well. Okay, like VS Code, I need to master VS Code.
So you see, like,
do I use Vim?
you see
Any
when
Vim heads?
we created a book called Principles by Ray Dalio, and then we give a summary of principles, and it says Principles by Ray Dalio. It prints out the. Oh, this book is called. Let's see. Right. Oh wait, what happened? Oh wait. I'll put here. Just print it out at the same time. So when we print this, we give a summary of principles, we get that, right? So now let's create another book. Anybody in the chat have a different book? You see how it allows us to reuse code pretty much. Let's do cracking the coding interview.
Yeah. So like you can call upon principles as a book now?
Yeah, now it's a real object that we can like play around with. So, cracking the coding. Dude, I'm gonna butcher her name. Gailak McDowell. Okay, this is my favorite.
Yeah, there's a
Author.
couple copies rolling around in the house that's somewhere.
Is that a weird favorite author? Let's see.
You don't use autocomplete in anywhere, eh? You're just like raw coding? You don't have like IntelliSense or anything?
I don't want it. Jay, what's up, man? Dude, we're studying object-oriented programming.
Man, you guys, bruh, I missed the flight last night. Oh my god.
Okay,
This is why it's happening. This is why this video's happening, bro.
cracking.
Yeah, I haven't been on the stream for a couple days.
Cracking coding.
But now I'm stuck here.
So now we basically we have a book, right? Now we create two books. Now these two books are two different like
Yeah.
objects.
Yeah.
So essentially, I mean, let's like
Oh,
write
I
this.
see.
Do you
It's
see what
like
I mean?
it's like for example in pandas you could have a data frame or you have a series. You know what I'm saying? Is that even making sense? But yeah, no, I kind of get what you're saying. Holy, 3 a.m. Savage.
Let's get it, man.
Yeah, get that.
Keep getting that
Get
word.
that money up. Don't sleep, man. Actually, sleep a little bit. That's bad advice. Eat, sleep, work, repeat. That's all you gotta do in life.
So right now we have this class, right? This class is just
Respect.
a blueprint. The moment we call our constructor like principles, like the moment pretend we have book, we say 1 by Redalio.
Yeah.
What
So
it's gonna
if you don't declare it as a variable, you'll never be able to call it again, eh?
Pardon? Could you explain that?
Because like, go to object-oriented programming, or go back to your coder text editor. So here, if you don't see how you put principles equals book,
Yeah.
if you don't declare it a variable, you can never call it ever again, right?
Yeah, exactly. You kind of lose it. It'll get garbage collected, honestly, if you just,
Yeah.
because
Okay,
there's
yeah,
nobody
yeah.
referencing it.
Oh man, the garbage collection thing. It's crazy how when you talk about RAM, like I'm starting to get how RAM works.
Yeah.
You know what I'm saying?
Yeah.
Like, I kind of get the difference between a CPU and a GPU now a little bit.
Okay.
But like CPU is sick at like procedural stuff, whereas GPU is sick at like concurrent
Yeah.
things. If that makes sense.
That
Like
makes sense.
GPU is sicker for like object oriented. I don't know. Maybe I'm just making stuff up now.
Okay. So let's like think of this
Try
is
to
our
act smart.
this is our memory, right? Like I said, like books are just classes or are just like blueprints. These aren't real things yet. When we call book 1, it'll create book 1. It'll create book 1 in our memory. Like a real object called book 1,
Yeah.
right? That'll create it somewhere in our memory.
Yeah.
And then like when we say when we're storing it in a variable, when we do like var1, when we construct it, it creates that area in the memory, and then we just have a pointer basically to that area of the memory where the book is.
Oh,
So that's where we're storing. The moment we cut off this variable, the Python's gonna know that no one's referencing it. It's gonna garbage collect that and free it up for somebody else at some point. But that's how we create book 1, and then pretend right here we have this code.
Is deep though.
We have
Dang.
this code called cracking the coding interview. What it's essentially gonna do is it's gonna take this constructor, right? It's gonna look at book, passing, cracking the coding interview. What it's gonna do is it's gonna grab another area of memory, and it's gonna like create this book 2. And now when we do cracking the coding interview here, this variable is now pointing to that specific book right here in memory, right?
Yeah.
So when we access cracking the coding dot print summary, it's gonna be printing what's in this thing, the name and author from here.
So it takes place in some part.
Yeah, you can't choose where it's gonna be. I mean, in lower level programming language, you can be like, I'm gonna put this in this specific register or something like that. But with Python, everything's like dynamic, or memory is dynamically allocated, so you can't really choose.
What?
So
like, let's say like in a programming language like C++ or like a lower level, you could be like, okay, this is like your physical RAM, let's say, like this box. You could literally be like, hey, you're using.
yeah,
Dang.
essentially, yeah.
And then I guess like
even RAM, even at the lowest level, there's like things called registers where you store data in. But that's when you're working with like the lowest level
programming
languages. And you pretty much like assigning it to different blocks of memory.
Dang.
But essentially, if you have your memory here, when you create,
like you kind of sometimes when you talk about coding, you're like, hey, or an array, like somehow when you make an array, like it's in a contiguous like
space.
within space within the memory.
Yeah.
Somehow.
So do you see what's happening here? We're creating two different objects, and objects are real things, like real objects in our program that are like living somewhere in our memory.
Yeah.
Okay. So now
and then you use a variable to ensure that it doesn't get garbage collected.
Yeah, exactly. And like you need in general, like if I want to like pretend I didn't store this, how am I gonna get the summary? I don't have a pointer to it. So essentially what this is doing, principles stores a pointer essentially to the book one, and then when I do principles.give summary, it pretty much looks in that memory, and then it prints the summary based on what's stored there. So what's the name and what's the book author in that specific location. That's why when I say principles.give summary versus cracking the coding print summary, I get a totally different result.
Yeah.
Right.
What's the difference between an attribute? Okay, no, I asked this before. But like the way the attribute works is it's just like I'm 5'7". I'm like 155. That's basically what it does. But can't you make a method that says that? Oh no, you kind of do that. So like in the initial or in the first type of code, the init function, that's kind of like you saying the attributes, and then you can use the methods to describe itself.
Yeah. I would say like attributes are just like things about that object that we need to care about.
Yeah.
Like when it comes to a book, what are the things we need to care about? Like the name, the author, maybe the genre, maybe
those are
right?
attributes.
Those are attributes. And then like what are like specific and then the methods are like specific actions you want to take on the book. Like do you want to check it in? Do you want to check it out?
Yeah, like the adjective. Like what is that?
Kind of like the adjectives, right?
Yeah.
The different things,
like,
or
was,
maybe not.
That
adjectives.
dude was saying it's a noun. Like it's like an action word, like a verb.
Right. If you're thinking about let's like think about a person quick. Like pretend we're defining a person class, right? What are the different things? Like how would we define a person class? What are the attributes that we want in a person?
I don't know, attractive. I'm just kidding. But yeah, no. Like I kind of Okay,
It'd
so
be
you're
like-
initializing self, then you're putting like the person's name,
Name.
gender, height, weight,
Yeah, exactly.
like
So-
whatever you put on your license, right?
Yeah. These are the attributes of that specific person. And usually when you're writing like an object-oriented program, you want to store attributes that you care about. Like if you're writing like a software where you need to know the name or you need to know the gender, you pretty much add that because you want you want to be able to use it for like some reason later. And then what are methods? Let's see, methods. So what are the different methods or like actions that a person should be able to take?
Walk,
Exactly,
talk.
like speak,
Yeah.
right?
Why do they call it methods? It's like a method of doing something, I guess.
No, what do they call it? Methods. ChatGPT. Why do they call it methods?
Ways or procedures by which it can interact with data or perform. It's like something that it can do.
Okay, what are?
Oh, I see.
Okay.
Look up what why do they call it attribute?
Yeah.
Okay.
Hey Santa, could you explain attributes and methods in object-oriented programming?
Ho, ho, ho. I'd be delighted to explain. In object-oriented programming, attributes are like the characteristics or properties of an object, like how Santa's attributes could include his red suit and jolly laugh. Methods, on the other hand, are like the actions or behaviors that an object can perform, like how Santa's methods might include delivering presents or reading letters from children. Ho, ho. They work together to help make programming magical and organized. Ho, 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 ho.
Does that make sense?
Yeah, that makes sense.
See, Santa, thank you.
Oh, oh, absolutely. Understanding attributes and methods is a great foundation for object-oriented programming. If you have any more questions, or if there's anything else you'd like to know...
Yeah.
Oh man, cut off Santa.
So exactly. So let's continue building our thing. So could you explain to me what a class is again?
So a class is, I just read it, a blueprint for creating an object.
Okay. So this is
It's like a type of object, essentially.
yeah. So this is, or it's not really like it's just a straight blueprint. It does never like when we define a class, we're not like it's not like a real instance of any object yet. like we have to use the only reason why we create classes is so we can create the blueprint of what an object should be when we create it, and then when we when we create the object into our system, we use a constructor to create an object using like a specific class. So it takes the blueprint. Pretend I have a blueprint for a book. It's not a real book yet. It's just a
It's just like a. It's just kind of like a framework for what a book is supposed to be.
yeah, exactly. It's like a framework or a
It's just,
blueprint
it's
or
just
like a concept of what a book should be.
exactly. Yeah. Yeah.
Right?
Yeah.
But now, like, what's line 38 doing? It's actually creating a real book in our program.
Yeah, with the name and the author.
Yeah. So this is a real book that we can interact with, right? We can actually call methods on this thing. We can't call methods on just the class. The class is not a real thing. It's just it's just a blueprint.
So like, pretend you only have attributes. You can't actually find out what the name and the author is without the method.
Yeah, exactly. You can't really.
Yeah,
do that.
yeah. So like, yeah, because it wouldn't be able to describe itself. You don't give it like a method
Yeah.
for it to communicate what
You
it
don't
is.
give. You don't have
Like
any
it doesn't have
behaviors.
it doesn't have a method to talk. Like
Yeah.
let's say you have a baby with certain attributes, but it doesn't have a method of communicating. Like it doesn't know how to speak. It's basically like that.
Yeah.
That I don't know if that even makes sense, but I'm starting to get what the method is.
Okay. So like with the book here, right? We have attributes, which is the name and the author, and we have one simple method, give a summary. So when we call principles here, we actually create a real book. Like I showed here, it creates a book in memory. And then now we call a cracking coding interview,
Yeah.
and that creates a different book in memory. And then we store a variable that points to those specific objects.
Yeah.
So now we have variables that point to those specific objects. Now, those objects, we can perform behaviors on those objects. We can say principles, give summary. So it pretty much accesses this object and performs the method,
Yeah.
which is give the summary.
Yeah.
And it gives a summary based on what's stored in that area of memory. That's what self is essentially doing. It's like giving you access to like this specific thing. You don't want to call self.name and get this one, right? If you're saying give summary of var1.
Yeah. You're
Right.
basically telling the computer what to refer to.
Yeah, exactly. You're giving it's basically a reference to to a specific area in memory.
I see.
So when we say var1 print summary, self.name here is going to be principles and not cracking the coding interview.
Yeah. Yeah.
Does that make sense? Or
Yeah.
not really?
Yeah. Let's see a lead code question.
What
With
do you- okay.
let's see a lead code question and how it works. So like for example here, it just has a method.
It just has one method, yeah.
Like
But,
why do they do it this way? Like why is it a class, not a function?
I don't know. They probably do something like this: solution.create the solution. Right. This creates the object of that solution,
Yeah.
and then they'll do solution, and then they'll call that specific attribute,
Reverse word. Yeah.
and they'll just put in a word.
I see. But it doesn't need an attribute somehow. Like how does it not need a constructor?
Yeah. If you don't define the constructor is still running, but it just doesn't do anything. It's basically just like a blank constructor. It's basically like this. This is a constructor. Do you remember what a constructor is?
Yeah. It's
What is
just it's basically like a blueprint for it's just like constructing what a solution ought to look like.
Yeah, and like initializing it as well with like the base variables.
Okay, so so like the constructor is basically these registers will have this specific thing, and then you're starting to put the attributes there.
Well, you usually in the constructor you want to, like for example, when we create a book, there's two different ways we can create. Like when we create a book, we want to create it with some base data, and the base data is like a name and an author. Like you can create a book and then assign stuff to it after, but usually in the constructor you want to define like attribute, like you want to like initialize the attributes.
Yeah.
Like if you just define a book with no name and author, it doesn't really make sense. So you want
Oh
to
man, this is getting deep. But yeah, like I'm just trying to figure out because I always kind of get confused about that. Like on lead code, I was initially, how do I say? Like I was kind of like I didn't do lead code for a while because I didn't know like how the function works within a class.
is it starting to make sense?
Yeah.
Or like what? Okay, what's confusing
Yeah.
you here? Like, do you understand everything happening here?
Yeah, I get this part. I just don't understand like how you can have a method without an attribute, like in lead code.
Like a method? Well, like pretend we just wanted to have like a person.
Like why wouldn't they just make it a function? But now I kind of get it. Like now I kind of get it. Let's open up the lead code again.
Yeah. You want to stare at it for a second?
Yeah, I just want to stare at it for a second. But yeah, like here, so you don't even need this, right?
You don't really need it. Like for this, well, when we think about it, okay, solution is like
You're
the
basically
class.
yeah, it's just like an object that they're gonna put into.
The thing is, the
Like you're making an object.
thinking of looking at the lead code one, it doesn't really make sense because
Yeah, it like should be a function.
yeah, it should be, but just this is just how they decided to implement it.
I see.
Because if you think about it, like we were talking about earlier, wait, let's see
Yeah,
here.
that one's a.
Like if you use like a functional programming, like look, that's just a function. It
Yeah.
depends. Like it depends on. So you're just defining a function here on these functional programming languages.
Yeah. What's Rust? I know that's what Primogen likes to use.
He likes to use Rust.
I think he's
Yeah, my brother's into Primogen now, which is pretty funny. So you can see these are like functional programming languages. Might say here,
bracket.
but like
Yeah, am I getting too deep into this? A
Yeah.
method is a function, yeah.
essentially, but like there's a method is usually a part part of a object.
Yeah, I literally
Or
am
part of a class.
spamming, like I'm literally doing lead code
Yeah.
questions without knowing how the actual class works. You know what I'm saying?
Yeah. Okay, let's continue with this example. What is a class? A class is a blueprint to create objects. We created two objects, right? Two objects are used, like we created these objects using this class. So they have this specific behavior.
Yeah.
But you see how it allows us to reuse a lot of code. Now we don't have to do print. We defined this one give summary, and now each one kind of just has that.
Yeah.
And you can just get like instead of like writing that logic in.
Yeah.
Or
Yeah.
if I wrote this procedurally, I'd have to like
yeah.
I'd have to do something like this.
Yeah.
Principles equals then I'd create a dictionary, and then I'd put like name. You know what I mean?
Yeah.
This is how like you might have done it if you just only knew procedural, read or name.
Yeah, that's
principles.
basically how I would do it.
And then you'll do like
And
principles.
then you would make like a function that
print.
adds like a new thing. So for example, yeah, how would you even do it in a functional program? Like you would literally have to, like it wouldn't even make sense to do it as a function.
It will, but it will get messy. I'll show you how to do this procedurally.
Yeah, do one as like a function. Do it as a.
I'll show you how to do this
Object.
procedurally. So
Man, you're
Pretend-
too comfortable with this coding, eh? Like you could just jump around different scripts. Frick.
do your DDL. Okay, let's show how we can do this procedurally, and then we'll show how it gets simplified. So if I were to do this procedurally, I'll need to create books, and we'll just say books is we'll store books in a dictionary. So we'll say principles. The name is like this name, and what did we want to store? Author. So what we can do there is author, Ray Dalio, principles. So what is this doing? It's still doing the exact same thing that
Dang.
we were talking about before. We're creating like pretend this is our memory, and I don't know if is it useful to think in terms of memory or no.
Yeah.
Okay.
Yeah, because I need to understand like how. Like if I only know like one level of abstraction, I can't. Like, it's hard for me to visualize.
Yeah, I see.
You know what I mean? Like having memory and stuff like that
Okay.
helps me like visualize it physically.
So let's like write this code in principles, and we'll talk about how it does in memory. We're gonna do it procedural, then we're gonna convert it to object oriented. So pretend we're gonna want to create. We're gonna want to store books, and then print a summary of each book. Right. So we're gonna create principles, and we're gonna do cracking coding. Cracked coder. And then this name is going to be cracking the coding interview.
Oh, okay. Like you can't even I see.
So now we created two
can't
books.
actually you can't actually have structure. You have to do it manually every time.
Yeah, every time you need to, like, if I want to create another book, how am I going to create another book?
Yeah, you make a variable and then
third book. Book C, right? So I'd have to do that every time, and then pretend I want to introduce another thing. Pretend all of a sudden I'm like, I want to know the number of pages, another attribute, right?
Yeah.
Then I literally need to go to each one and kind of like make sure that it handles it, right?
Mm-hmm.
And then pretend I want to print a summary of principles. How would I do that? Then I'll go like something like this. Print F. I'll say this book is. Then I'll do. I'll take principles. Then I'll grab the name. By. I'll do principles by the author. See? And then that's how I print like principles, right?
Yeah.
What if I want to print the third book? How would I do that?
I see what you're saying. You do the same thing.
Yeah, like
But you can make it a function though.
Yeah, you can make it a function, but then how do you
like you would make a function called describe book.
Yeah.
Then you can pass it like let me write that.
Write that.
So like for example, if I was doing bro, why is this backwards? So like let's say if I was doing functional programming, I'd be like define what? Why is it going the wrong way? But yeah, so I'd be like describe book. Then you would have to be like name, and then you would have to have author. Then you would put this in, and then it would just be like return F string like this. No, just Command C, right?
Yeah.
Man, I'm a Windows user. Okay, chat. Tell me whether or not I should buy a Windows phone or a Windows or what's it called? Describe book. Oh, there's autocomplete on this thing. Then I would say like how I wouldn't even be able to call it.
But
like really this would have to be like now at this point I'm just every single time I'd just be like book C John. Right? Or I'd be like book C. What is it called? Book C. And then John. Command enter. Is that the shift F10? Let's run it.
But like here, principles is referring to one up here, so you're gonna have to switch this and just do name.
Oh no, I see.
But what you can do different here is like just pass in the book. So this is a reference to a book. Do that. And then you could pass in describe book like principles.
What? How?
I'll explain that in a second. Let's do
Mac? Get a Mac?
so.
I heard like you can't use PyTorch on the Mac though.
So now you're calling describe book and you're passing in a specific book. That's a reference to a specific book now. We're passing in the reference to principles. So book is also pointing to principles now. and then so when you call
How?
book name,
How'd you do that? Is it because you called the variable? You called the like you already made it an object?
yeah, this turns into an object. So let's look at how this works in memory. So
Oh, I know what you're doing. But like, wouldn't it break because like, how is it calling book? Like, wouldn't you have to say third book?
here, well,
Oh no, you do that. Oh, I see. Because basically, you made a dictionary of the attributes of the book. Then you're using like this notation where you call the dictionary, and then now it's the dictionary plus this convention.
yeah,
But you could also be like book 0, and then that'll return. But that's not how a dictionary works. But I see what you're doing here.
I can show it in memory how it's gonna work.
I see how it works.
So let's
now.
do principles, right?
Oh man, are we ever gonna get to algorithms? Change the title. Change the
No,
title.
we'll get to it. This is gonna be an 8-hour stream.
Oh, God. Full shift, man. Full shift.
Okay, pretend
I
line
have to do
30.
laundry in a sec though.
Line 30. Line 30 creates like an object in memory, right?
Yeah.
There's gonna be principles. It's gonna be like principles.
Holy, my brain's getting fried. I need liquid cooling, man. I need liquid cooling.
Okay, we create principles, which is going to be like a when we define principles, or let's just do this. It's easier like this. So we'll think about things in memory because it's my brother finds it helpful. We'll do. So when we create principles here, principles, right, equals. When we create the object, we basically create an area in memory where we're gonna store this. Where we're gonna store this dictionary.
Yeah.
And principles actually is just a pointer to that area in memory.
Mm-hmm.
Right. Then we go and we do cracked coder here. That creates like another object in memory, like another dictionary. Dictionaries are just objects at the end of the day,
Yeah.
right? So that's creating another one in memory, like another dictionary in memory, and that points to here.
Yeah.
So that's now I create.
Let me do my laundry quick and then think about this for a sec. I'll be back in like 2 minutes.
Okay. Yeah.
Yeah.
He's gonna-
let
he's
me
gonna
take a
quickly-
break for a second.
Yeah. He just needs a break.
Yeah.
So, is everything making sense so far? Chat, keep me entertained while he goes take a break. Or like help me explain it to him. Give me a sec. Move this. Give me like 30 seconds. Dude, teaching object-oriented programming is hard, honestly. I don't know how teachers do this. How would everyone else teach it? Am I sort of teaching it properly or nah? Let me think about this. Let me talk to Santa. You loaded it?
Yeah. Bro, I didn't even start the dryer. Idiot. Okay.
So where are we? So you're seeing this is how you could do. You can write this program in procedure, but you're already seeing how it's way more complicated than just defining like a class for a book.
Yeah.
And each book kind of has a name and author, and to just create a book, you do this instead of like knowing to define a dictionary with the right keys and values.
Yeah.
Right. This kind of like allows it to be more reusable.
Explain the concept.
Dude, it's hard, man. It's hard.
Yeah.
Okay, I'll try to make it as simple as possible. You're right. So, let me think.
It's so funny how it's actually hard to teach, eh?
Well, the thing is, we're just jumping straight into object-oriented programming. Usually, they'll like do a whole course on like.
They do a whole course? Nah, I'm not trying to do it like that. I'm trying to do what's fun for me.
Yeah. So
Otherwise, like if I do this academic, oh, actually, it. How do I say it? Like the most important thing is like I'm excited to do it. I'm not trying to do like a full course where I don't write any code.
Yeah. So let's continue on with our example here, and you'll get to know like now we're creating different books. So principles, we're creating different books, and we can give summaries of those specific books. So now let's define. Create a program to manage a library's books. Let's define a library so that in the library we can start like storing books in the library.
Yeah.
Okay. So I think let's just keep with these very simple concepts of constructors, attributes, and methods, and then how you actually create objects, real objects using the blueprint. So
The constructor, like the attributes are just within the constructor though.
yeah, but when you create it, it becomes part of that object. Like when you say self.name,
Yeah.
it becomes part of that object.
wait.
Sorry, let me
Wait,
close
nah,
the-
don't mean. Yeah. We're in Canada right now. People are shoveling their snow outside. People are shoveling their snow so you could hear them scraping the floor. I think I think it's Caesar's dad or something, is it?
I don't know.
Oh man. Okay.
Yeah, my brain is getting cooked trying to teach this because I'm not. But it is good. This is how you learn as well. Like trying to teach.
Yeah,
someone
nah, I'll never forget this. I'll never forget the class and then the initialize, the attributes and the methods.
Yeah.
I'll never forget that now.
So
Like at the bare minimum, I'm remembering the syntax by staring at it for
okay,
this
let's
long.
do now that we remember it. Let's do a simple one where we just want to create a simple person. Let's do John.
Damn, how do you already have like 10 scripts? Yeah, you will learn as well. Yeah.
Okay, John. Your task is create a class for a person. This class should, or wait. I'll give you a simple project right now, so you can learn as we do it. Create a class for a person. This class should define the blueprint of a person who can say their name
I see.
and weight. And
Height. Yeah, that's good.
let's just say weight, because that's what we're focused on this year is getting to a certain weight. So create a class for a person. The class should define a blueprint of a person who can say their name.
Yo, SB has a crazy jawline in that pic though.
Yeah.
Yeah, he's kind of attractive.
So create two
no cap, just kidding.
create two people, and make these two people say their names.
Create two people, make these two people say their names.
So this is your task, and I'm gonna look over your code.
All right.
Okay, I'll be right back.
Oh man, how many hours I swear I work like 60 hours a week. I work 60 hours this week. Learned coding on the side. I have like my own YouTube channel. Now I have to learn another 8 hours. God, man. Okay, so I'm gonna define class. Nah, you're good, bro. Yeah, you gotta. Yeah, you're good, man. Don't worry. When did you start learning OOP? Literally, how long has this stream been? 1 hour, 15 minutes, bro. Class, person, define, init, self. Yeah, I literally started. So I've been in finance for like 10 years in a couple different roles. Right now, I'm like an asset manager for like pretty much like $1 billion fund. Like right now, we're managing about 6 billion. But like at work, I use mostly Excel, and then like I help buy properties basically. But yeah, like I made a YouTube channel and I was trying to use Excel. Like I was trying to make a little Excel thing, but you have to use like Power Query. You have to do a bunch of different things in Excel to actually make it work. And then I wrote like I did like my first ever code, which was just like doing a quick web scrape using ChatGPT. I generated some code and I was like, whoa, it took me like 5 minutes to do something I was struggling with in Excel for like 2 hours. And I'm not kidding you. I'm literally the top Excel guy on my entire floor. like, oh man. Yeah, I mainly use Excel, but really I'm gonna try to cut that out completely. I don't know if I can because like, yeah. Yeah, I mean, I definitely mainly use Excel. Like on a day to day, I don't know if you're in finance, but like what I do most of the time is like building um financial models. So like I would have an income statement, like a balance sheet. Like you're basically doing discounted cash flows if that makes sense. You're like trying to use Excel as a tool to like predict future cash flows and then you kind of bring that back to today's value to see like whether or not the future cash flows of a property are worth more than what you're paying for. So like let's say you're going to a property and it's like worth like someone's saying, okay, somebody comes to me and or like somebody comes to me and says, hey John, I want you to buy this property for $1 million off me or like this business for $1 million off me. My job is basically saying like these are like the incomes that I expect. These are the incomes that I expect. Or like these are the cash flows I expect, and then based off of my analysis I'd be like, hey, based on let's say if this asset has a 10-year useful life and it generates X amount of dollars, I would be willing to pay 1.2 million for it. So like my profit would be 20%. Like that's kind of how I use Excel. I don't know if that even makes sense. Now it's hard for me to explain, like simplify my job. But at the end of the day, like I'm trying to like I have a price and then I kind of do calculations to see like how much it's worth. Okay, create a class for a person. So now I have to put like self, and then I need to put their name and their weight. Why is it linting? What the heck? Self, name, init. Is it because of this? Self dot name. Nah, I forgot the thing now. Self dot name equals name. Is that? Nah. Oh man, I forgot how to do this thing. Self dot name equals name. Why is that not working? Oh, here. What? Why is it auto completing? You get commission after? Yeah. Yeah, basically. Now, we're not really a commission business. Like the way that we work is we raise funds. It's kind of like private equity. So like let's say exactly. Yeah, exactly. So for example, let's say you have a stock trading at $10, right? What you would try to do is you would try to identify its future income. Basically you're trying to identify its future income, and and you have to say like, hey, does that income match the price? Like, are you really getting the value for the price? So you have a price and then validate the price makes sense with the data in Excel. Like I'll show you what I actually do. So for example, in Yahoo Finance, right? Like if you pull Yahoo Finance, right? So you'd be like Nvidia. I don't know. We're kind of talking. This is such a tangent. But like you would be like, okay, this stock is trading at 134.25, right? Based on its future growth prospects and things like that. How do you command plus, right? So right now the stock is trading at 134. Does it make sense to buy it at 134? You'd have to like do a full analysis of its income statement, its balance sheet and its cash flows, and then like a lot of analysts right now are saying that okay, this stock is trading at $134. The target price based off of like analysis is 171, so your profit after a year should be like 30 something dollars, right? That's kind of basically what I do on a day to day. But like the difference between me and these guys that like just make target estimates is like I have to
Move up
actually
yourself
buy.
a bit. Like you're just. You
Oh,
can move
my
up the
bad,
chair.
my bad. That's like what's it called? What's his name? Do you know that one dude that used to stream a lot on Fortnite? But yeah,
What
like
were you saying?
no,
Yeah, continue,
they're kind of
continue.
asking what my job is.
Yeah, yeah, I
Like
saw.
my job is basically like okay, I have an asset that's like priced at 133. People are asking for this much to buy their share. I have to identify whether or not that price makes sense. And usually like you do that by discounted cash flow. So like you would do a bunch of analysis in Excel and be like, okay, based on what I know about the company and like the news articles and stuff like that, I'd be like, hey, since right now it's 133, just a CS major.
Nice.
Nice. Don't ever say just, man. That's ridiculous. Yeah, I'm just saying.
You're,
Like-
you're
like-
a legend for
yeah,
taking that degree.
Yeah, don't ever say just. Like but yeah, so I would say okay, in this asset, I'd be like, okay, it's worth right now somebody's willing to sell it for 133, but my assumption is in like a year it would be worth 170 and then I would buy it. Right? That's basically my job, is to identify trades like that. But
So
like
you're
for
basically
real estate,
evaluating companies.
yeah, I'm basically valuating.
Doing
And then,
valuations.
and like the other thing that I do is like once we buy the company or like buy the asset, we try to like optimize the crap out of it. Like okay, the previous owner, they were pricing it at 133 because like they don't know how to like increase rents or decrease like operational expenses. Like my other skill set would be like I would go into it and I'd be like, hey, these couple of individuals don't actually do any work or like provide value to the residents, cut them, and then like put in these persons instead, and then we can increase rent. I don't know. There's a couple. It's kind of complicated. Let me get back to what I was doing.
Yeah, define this class. Don't
What?
accidentally open up my stuff.
Okay.
Okay.
But yeah, why is this linting?
Scroll over it. Scroll over it.
Name is not defined. Pylons?
Okay, for now, just compare it. Like, what are you trying to do? You're trying to just
Nah,
define
I'm
the
trying to
constructor?
give it attributes.
Okay.
Am I even doing it right? In it? Oh, okay.
And it is also a method.
So I have to have self, name, weight. How does that work? Oh. How come up here? AA to university track. Company
Nice.
junior IG.
Sick.
Person, weight. So here, like, how come you don't have to have like different variables?
What do you mean different variables? Where?
Like, how are you passing it? This stuff.
So the first line.
I'm just getting confused with the syntax.
Yeah.
maybe.
So the first line, line 10, you just define, you pretty much just define the name of the class,
Yeah.
right? And then the constructor is essentially what you want to create a constructor, and this is a very special method. Every class has a constructor, which allows you to actually take a class and construct an object, right? So usually in the constructor is when you define like initialization variables. Like what do we want to initialize this object with? You could initialize it with nothing,
Yeah.
but if you want to initialize a person, usually you'll want to like when you want to like create that person, you're gonna want to give them some baseline things like a name and a weight, right?
Yeah. Okay, name, weight. Do I have to say like how come I don't have to do this like string?
Well, it depends on what you pass.
And then I like this should be like a float. I don't know if
Yeah, you
this
can do
is-
that.
Then I could be like, wait, like why don't I have like that kind of makes sense to have to do, right? And then you would call define this blueprint state name.
Or
Wait.
say name or something.
Yeah, yeah. Name, wait. What? Why is it linting?
You're not defining it as a function properly, or like you're not using the proper
Oh.
syntax for a method.
I see. Yeah, I never really wrote any code in VS Code. Just return a f string. I'm syntax again for this. I'm. Is that the syntax
Yeah.
for that? Okay. I'm. Put a name. Nope. Now you can see that I can't code, eh? Golly. Name. I weigh. Wait. Started working web dev job first, so it's kind of confusing to explain.
Nice. That's a good start.
Let me see if this even works. So initialize
I mean, there's some reds. Okay, yeah. Keep going.
equals person. Name any, weight any, person. What is that?
That's like the type. It wants you to return a name, and name could be any
Okay.
type, and weight could be any.
How does
type.
it know? Like, could I just put in this, or do I have to put it in string format? Is
Well,
it
that's
smart
what
enough
any
to
is
do that?
saying. Any is saying you can give in any data type.
Oh man, that's sick.
But what's John?
That's a name. Oh, you have to do this. Name equals John.
No, but the thing is, John is a variable that doesn't exist yet.
John is a variable that doesn't exist yet.
Yeah. So just like create the person right now and just pass in like.
Oh, I see. Like you have what? Isn't that what I'm doing though? Like I'd be like person dot.
So now you're constructing that person.
Yeah. John. And then say 153.5. Gotta be accurate. Then can I say
Now your goal is like say your name and height.
print John dot say name and weight? What's a shortcut for this? You just
Don't do
run it,
shortcuts.
right?
Don't do shortcuts. Wait, you're printing the. Are you actually calling a function right now or on line 20? Yeah, just do down here. I didn't set up my VS Code properly yet.
What?
Do John. It's breaking. It's not doing anything.
It's not doing anything? Why?
Okay, let's debug this. Like, what is name pointing to in line 16? Like, how does it know what the name is? Like, which specific name?
It actually doesn't. So you have to be self dot name, eh? Is that it?
Yeah. Then how does it know what self is?
Because you constructed it. What?
Not running.
How'd you do that?
Let's go like this. Save. Command
Save.
S. We're here. You're just
See,
gonna have
this
to
is
manually-
why. This is why I slap.
I'm drawing that way. See, now it's working. Now you created a person.
I see.
Now create like two more people, like me and Jose.
I see. Oh no, I could just drop it in.
So no copy and pasting.
Person. Interesting. person.
Put James.
Why is it blocking the thing though? James. What's your weight right now? Like
Let's do 174.
174.3.
0.3.
0.3. All right. Oh,
I'm a little up right now. Actually, I need to
bro,
get
you
under
just ate a
70.
bunch of chips,
Yeah,
man.
my bad.
God dang. I'm more used to Java with OOP. Oh man, I'm only sticking to Python for a while.
Yeah, I'm used to it too. That one,
What?
like Java as well. But
Like, what do you write at work?
At work, I use a lot of Python object oriented. It's pretty much the same, but there's a bit more features with Java, like abstract classes and things like that. Are you sure he's 165.2?
That's what
Cedric told you.
I think that's what he was last time. Yeah, I just have to write a bunch of code like this for a while. C sharp.
Yeah, C sharp is nice. I like C sharp as well. I had to write code in all those ones.
How do you write?
Save, Command S.
Command S.
Yeah, and then now I pretty much click down here.
Oh, we click.
I use the terminal, or I do up here. And
You do up here. Interesting. Okay, it worked.
nice.
That's my first ever class.
That's his first. So now, like, walk me through the code and kind of like, okay, now let's do another thing. Let's like, what if I wanted to add age? How would I do that?
You'd have to make an attribute. Then you'd put self.age. I guess that would be an int. People don't really. I'm like, people don't say like I'm 22.457. You know
Yeah.
what I'm saying? Then I guess you could call that right now. Like, it has no method to say its age, right?
Yeah.
So you could basically call that.
Okay. So now,
Yeah, you would just
say
do
age. Yeah. So now you're creating. See,
And then
he's
you would
getting to
always-
know. I like this.
You'd
It's all
always-
about practice. Like, I could explain it all day, but now you're practicing it,
Yeah.
and then
Yeah, what is this thing? Okay. This is another thing that I have to figure out. Sometimes I have no, I just use whatever. Like, for example, here I'm kind of using like single quotes. But now I just realized that if you use double quotes on the outside, you can use single quotes on the inside.
see
Dang,
you're just
that's
learning
sick.
from experience. It's good.
If I'm, what do you call it? What's my age? Is it running? Good.
Yeah.
I'm self.name.
See, like, you see why here you're not actually saying specific names or specific weights. It's because it's just a blueprint. The blueprint, like, it doesn't actually have a name, weight, and age yet until we create an object that actually has those things.
Yeah.
Like, you're not saying I'm John, I'm
yeah.
James. Like,
Yeah,
you're just saying I'm gonna
Yeah.
say my name.
What happens if you don't have like the full thing though? Like, say for example, I don't put an age in. Will it break?
Let's run it. Let's see.
Dang, this keyboard is worse than my keyboard, I think. And wait. Whoa. Why does it lint though?
Look at it closely.
It's not
Nice.
referring to itself. But yeah, so let's say if I run this code, so I control.
But you're just. I thought you wanted to do age.
Is it worth to learn Python for lead code? Of
Yeah,
course, bro.
100%. I've never seen someone pass one of my interviews using Java. Honestly, like, there's way too, like, it gets way too.
It's too verbose.
Way too verbose, and you don't want
I'm
to deal
just
with
kidding.
types.
I only kind of know C++, bruh.
I think.
I feel like if you try to use C++ or whatnot, like, you're gonna be spending a lot of your time coding.
Yeah, you, like, a lot of the times you just have so little time to do the question that you want to not worry about
Command
typing.
S, right?
You don't want to worry about syntax too much. So Python is like the best interviewing language that I know, honestly.
And you have to learn AI at some point, man. We're all getting automated. You need to be automating or get automated. To be honest, that's how I feel, man. I really feel a threat. Like even my current job, it's like I'm not kidding you. I've built like DCF models at a ridiculous scale. Um, like let's see if I. Yeah, automate
Yeah,
or get
honestly,
automated.
I would study Python for interviewing. Trust me, it's easy. Way easier to do it in Python.
Missing one required positional argument. So you actually have to have it, eh? Interesting. Interesting, yeah. I see. No, no.
Those aren't real, by the way.
Those aren't real?
Command
Weights?
S,
Command S.
and then now run down here.
Ah, now it works. Say name. Yo, how old are you guys? Oh man, that's what you're not supposed to ask, eh? Oh
No,
man.
you could ask that.
But yeah, I'm like 29, I guess. Yeah, I've been in finance like 10 years almost. And I survived finance with only Excel and SQL. That's ridiculous, bro. 21?
Nice.
Hey, good. Yeah, you can, bro. Honestly, I think the future is going to be dominated by people that know how to code, but also can bridge like tech with a certain domain. Like I don't know if you had like your first like full-time job yet, but you'll notice that like
They said that they're
Yeah.
still in school. So
yeah. Like if you haven't had your first job yet, you'll notice like some people they know a lot about a certain domain, like for example finance. They know like all the finance concepts, but they can't apply it because they lack the technology. Like they don't have the tools. Like they know how to build a house, but they don't know like how to use a hammer. It's kind of funny. Like you'll notice that a lot. John, and then what's my thing? Sage. Yo, the ADD is bad in me, man. Trust. Bad ADD. Command S.
So now John's gonna say his age.
What? Did it work? Command S. Command S. Oh. Up on that. Enter.
Look at your say age function. What is it doing? It's running that same code.
It's running that same code.
Like it's running say age, but your say age.
Oh my. Oh man. And way. And. And age is. I don't know. Who cares? It's not good grammar. Self.age. But yeah, you guys are in the right profession. Honestly, if I could go back, what I would do is I would do like a comp sci major and then do like a CFA. That's how I would do it.
Run your code down there again.
Cause yeah, like everything you can scale a lot with oh now it worked.
Okay. So now you're learning how to create or classes, which are blueprints. You're taking these blueprints. You see how it's a blueprint, but then when you do person John, it creates an actual person John with a certain weight and age.
Yeah.
And you create 3 people like that.
What is CFA? It's like a chartered financial analyst
Yeah, show them what that is.
designation.
Show
Yeah,
them
I'll
what
show
that
you what
CFA
that
is. Everyone follow my brother John too. He has his own YouTube.
Wait, how do you do this? What is a CFA? CFA designation. But yeah, this is my YouTube channel. I also have a YouTube channel. I kind of got James into it.
Yeah.
But like this is basically like the type of code that I run. So
Does
like,
anyone-
whoa. Is that always like that? It just bro, pay for premium at one point at some
You
point.
pay for it?
Yeah,
That's
CFA
crazy.
charter holder. But like what's your bro's YT?
It's right there. It's in the chat.
It's
It's pinned. It's pinned.
Yeah, but like it's like a designation where you like, do you know what a CPA is? Like a chartered professional accountant. Basically, like the chartered financial analyst is like something that most finance people have to do, but like literally nobody could pass. Like I don't know why the pass rate's so low. But like the pass rate, the CFA exams are notoriously difficult with low pass rates during the 2010 to 2021. Pass rates for level 1 through 3 range from 22% to 56%. And then like bruh, like literally 60% of people failed the level 1, then 60% of people failed the level 2, and then 60% of people failed the level 3. And literally, so you'd be like 60% of the 60% of the like you'd be like 40% of the 40% of the 40%.
Yeah.
Basically. But you're basically doing finance concepts. Like you're learning how to manage money essentially. I'll put the YouTube channel in here.
Yeah. Drop that in the chat.
But yeah, you can check it out after though. But yeah, that's how I would do it. Like I would like I think the base for everything, you need to know comp sci, and then once you know comp sci, niche into like, I don't know, my niche is finance. I just love investing. I just love making money basically. I don't know, like I've always been an investor since like 12.
Nice.
Right? Like
Yeah.
when was the first,
Well, nice. It went up 2 subs.
like I like like I literally the first, like when I turned 18, the first thing I did was open an investment account. Like the next day, man. It's freaking funny though. And I didn't even have like a job. But yeah, like you would just learn, like I think the main thing is you guys are learning like the how to scale, but then once you know how to scale, also identify like what you're passionate about. What are you bullish on? The globe, bro. I'm literally bullish on the entire planet right now. Like I would say humanity is like the best thing to invest in. You like
Which
you're not
humanity though? S&P.
humans.
Yeah.
Humans, like
which country though? S&P
like
500 or just the global index?
the global index. Like I would invest in everything. Like I would say equities right now are like way up. Yeah. Like dude, okay, here's the way that I would think about it. Like if you're investing, I would say like who there's certain times in history where like for example in 1970s to 1980s, Japan was 60% of the global market cap. So like the value of Japan's economy was 60% of the globe.
When was that?
70s to the 80s.
They were that good?
They were that good,
I did not
bro.
know that.
They were that good. But then like shortly after, they were down bad. Like they became like right now I think they're like 5%, and US right now is like 65%. But like if you in that same time period, if you were only invested in Japan, you would lose like a significant portion of your net worth. But then if you were invested in the entire globe, you would still be up in that time period, because like as Japan declined, US, Canada, like all the other countries outpaced Japan. So at the end of the day, like you would still be up. Like year after year after year, the value of the human race increases. Like we are just able to pass on knowledge and build on knowledge generation after generation. Do y'all invest? Yeah. Yeah. That, like, I would say since you guys are 22 or 21, invest, like start investing right now.
Early.
Like invest early and just buy like a broad market ETF. Like let's say, I don't know what country you're in, but like if I were you, I would just buy like an all country world index. I'm bullish.
Say your motto: invest early, invest.
Yeah.
often.
My motto is invest early. So like when you're young, start investing. Invest as often as possible. So some people like, I know it's a tax, but like it should be part of your hygiene routine. Like you're brushing your teeth, you're looking at the stock market. I don't know. That's kind of how I am. Like, I even e-transfer myself to my investment account like every day. To be honest, like, I don't know.
Invest early,
Invest often, and then stay invested. Like, you have to invest. You have to be able to invest long term. Like, if you start day trading and stuff like that, bro, you're just gonna lose money. But like, MSCI All Country World Index. But this is basically like how I would invest. This is what I'm bullish on. Let me see. How do you expand this? So right now, this is like this is like what I like to buy. So MSCI All Country World Index captures large and mid cap companies, 23 developed markets and 24 emerging markets, which is basically like the entire globe, right? And you could see here, only a little, all long term, 5 to 10 years.
Nice. I like that. Long term investor.
Yeah, be a long term investor. Because, dude, like, if you're not in finance, you're gonna get cooked. Like, you're gonna get cooked. Like, finance is super competitive. Like, if you, only buy. Like, try to buy stuff and never sell. Like, that's how you know you're making a good investment, not a trade.
Okay, what are you showing here? The all world index?
Yeah, so what I'm showing here is basically an index that shows the value of stocks globally. So this represents 85% of the global investable equity opportunity set. So there's like two types of assets that you can buy. So the first asset is like equities. So you're buying like equities is basically like you're buying stake in the company. Fixed income is basically you're lending the company money, right? So this specific asset class is allowing you, like, this specific index is buying a bunch of companies, right? And essentially you're buying like 2,650 different equities, right? You're buying like Apple, Nvidia, Microsoft, Amazon, Meta Platforms, Tesla, Alphabet. Like, you guys are students. So if you're really like a student, you should be focused on like learning. Don't focus on investing, right? Because think about it. Like, let's say your human capital when you're young is worth way more than your financial capital. Does that even make sense? Like, your human capital is what the value that you're able to give to society. Like, if you learn enough about comp sci, you can bring that into the workforce and make a lot of money, right? But like, let's say you're just you're investing. Maybe you have $1,000. Like, it's just not as much as your human capital, so you should be focused on that. And that's why like, imagine you're investing. Let's say you're investing in 2,650 different stocks. Like, bruh, that doesn't even make sense. Like that doesn't even make sense. Like, you should be spending your time on making yourself like a better human, and then like as you're able to make yourself a better human, the economy will value you more, and you can take that money and then invest. And then at that point, really, like, if you invest in the global market cap, you're basically betting on the human race to do well. And literally, we've never taken an L for a prolonged period. Like, I like, nowhere in history, like, we survived world wars, we survived pandemics, we survived like what do you call it, like plagues, you know what I'm saying? But like, certain countries, like, for example, Rome, I don't know, Japan even took a L. Like, Europe took a L. Europe been taking L's. Like, they're like literally underperforming. But like, really certain countries within the human race could take losses, but usually those losses are offset by the winners of the human race. So you could bet on both sides if you invest in the globe. These are very like high level concepts. But for example, like, what am I bullish on? That's all I could say. Like, I'm bullish on the human race, and I'm buying equities, or like buying assets that are able to invest like the entire human race. So for example, here you're invested 67% in the United States. You're invested 5% in India. You're invested UK 3, Canada 3, China 2.6, and other 20, right? So really, like, your money is gonna be safe. And like when the globe is not doing well, bro, you're not gonna be focused on money. You're gonna be focused on survival. Like, I'm not capping, bro.
Okay.
Okay, yeah. Let's get back to coding though. But that's a long-winded answer to what I'm bullish on. Like, I'm bullish on. Okay, let me not do that.
Go here. Okay, I think you're like, yeah, we can talk about like philosophy for days. We do it at the dinner table all the time. We go for hours. If you want to see something like that, just drop it in the chat. But I pretty much agree with what my brother's saying.
Yeah. Like, literally focus on making money, and then just put a little bit of the other thing that you have to. This is just another tangent. The other thing that you have to think about too is like, okay, I'm investing for what? Like you have to think, okay, I'm making, you guys are in tech, so let's say you're making like like tech people make like 200K a year out of school, right? Like, I feel like that's the base, right? Like 200K out of school. Let's say taxes are 40%, so you're taking an L. Like, you're making like that AC, it's growing larger and faster every year. Yeah,
dude, take a look at it.
Dude, think about it, right? Every single human being, there's no like there's certain asset classes where like, think about it like this. Like, what human doesn't want the equity market to go up? Like, it doesn't make sense. And like, humans are just able to generate more value every single year. That's all I'm saying.
Yeah, because some people always come up to us too and ask like, okay, I have $1,000, I have $10,000. Like, what stock should I invest in? To make that $10,000 into $1 million is gonna be like a crazy effort. But if you take that $10,000 and you invest in yourself, you learn some skills, you go to school, that increases your human capital, and you could trade that human capital in for real capital.
Yeah.
That's literally just a strategy.
Yeah.
So you need to think about like, how much am I worth in this market and society? How can I increase that? And then trade that in for real, like, for actual just money.
Yeah.
And then from that, like, if you have $1 million, it's easy to take $1 million and turn it into $2 million.
Yeah.
But it's harder to take 10,000, make $1 million out of it.
Let me show you this human capital versus financial capital over time graph. W's. But yeah, this is what I'm trying to explain here. So, Morningstar.ca. How can I make this big? Control plus, Command plus on this?
Yeah.
But yeah, this image sucks though.
No, it makes a lot of sense. Honestly, I never even heard of this until right now.
Yeah. This is basically like the financial theory, right? So let's say, I know it's kind of like dehumanizing, but every single life is worth a certain price. Like, to be honest with you, like, some people are worth less and some people are worth more just at birth. Like, let's say like, me personally, I'm probably worth a little bit less. I'm just gonna average like, so let's say like at age 25, based on like where you're born and like what your education status is, you have like a certain human capital. Some people have more, some people have less. And like, over time, what you want to try to be doing is like, as you get older, and it's just a fact of life. Like, as you get older, you kind of like become less and less worth, just because like you don't have as much energy, you don't have as much time, you're not able to learn as well, right? So over time, like, your human capital and the value that you're able to give to society decreases over time. But what you want to be doing with your human capital is like converting that into financial capital. So let's say you're making like 100,000 a year, you could like take a portion of that 100,000 and invest it in the financial markets, for example, like in the all country world index. And then over time, that all country world index will grow, and that will offset like your decline in human capital. And then over time, like as you get from age 25 to age 65, your total wealth will increase, and then you can do less and less work.
Yeah, you
Right?
can be
That's
pretty
kind
much
of like
lazy on a beach.
that's kind of like the theory. That's kind of like the theory, right? So, I don't know. Like me personally, like I'm never gonna stop. Like I'm gonna try to maintain. I'm gonna try to not have this like drop off in my human capital.
Yeah, yeah.
Right.
But you can't stop. Like if you get sick or something.
Yeah, yeah. You kind of
get
just have to
lazy.
do that. But that's kind of like the theory behind it. It's kind of like very high level and abstraction. But like at the end of the day, that you're kind of like that's how you evaluate like a human being is like based on their financial capital as well as their human capital. Yeah. Oh man, that's hot. That's really tough.
That
Eh?
might be a hot take, but
Yeah, that's kind of like a hot take.
okay.
But yeah,
Alright,
I'm not trying to
that's-
be ageist or anything, but it's like a phenomenon that it just occurs.
Yeah, and people these days can using it to create more value through investing, for example.
Yeah, you can do that too. Yeah, you could do that too. But like
You're using your own value to capture
Yeah.
financial value.
yeah, like the craziest phenomenon is imagine this like this total wealth thing is like in my profession, there's people like me who kind of came from the ground up, like me and James is like we didn't come up rich, right? Some people come up rich and like no matter what they do, their human capital is worth less than the financial capital that their parents give them. So like they kind of they're kind of like they kind of feel like a certain way. Like imagine you're a celebrity, your parent is a celebrity, and they give you like $1 billion. Like no matter what you do, like your human capital, like your total wealth is still is like dominated by the financial capital that you didn't earn, and then you have like no sense of self worth. Like
That's deep.
like that. I don't know, there's like a couple different things, like I don't know, using your own value to create more value through investing, for example. Yeah, you could do that. Like me, I generate like my most of my human capital is being able to help others manage their own financial capital, right? So they can focus on their own human capital, right? Like so for example, you guys, like if I was if I like your human capital is focused on comp sci, it doesn't make sense to use most of your bandwidth to invest. Like you should be investing passively and just having somebody else invest, right? Like you should be focused on like your human capital. But yeah, like we went on a big tangent on this one. Big tangent on this one. But yeah, man, we're all just dollar signs. Like I don't know. That's kind of a little messed up. Yo, what did I do here?
Here. Okay.
But yeah, let's get back to.
Okay, let's switch for a sec. I think you understand classes and you're able to expand on classes.
Doesn't your human capital go up with experience? Yeah, it does. It does. Your human capital definitely does go up, but think about it like this, right? Like when you're at school, your sole focus is improving your human capital. Like you spend 8 hours a day at university learning, and then after university, like after your 8 hours at university, you go home and do homework. You're literally what's it called? You're also improving your human capital. I've got 0 new subs.
What's up, man? Thanks for
Damn,
subbing.
yeah, I'll sub to you.
We'll sub.
Yeah, we'll sub to you too. Yeah, your human capital definitely goes up with experience, but you're like, on average, maybe you, Caesar, your human capital will just go up with experience because I know you're kind of smart and you like apply yourself every day. Like some people, how do I say it? Like they use a significant amount of their time and energy to give value, but they don't use that experience to upskill, if that makes sense. Because like, Yeah, I don't know if I'm answering that question. I'm not sure if I'm answering that question right.
Yeah, I guess like yeah, your
Like
human capital.
you could be um business. Man, I'm kind of dehumanizing humans, but like
It's fine.
business um uh what's
Thanks,
it
Null.
called?
Thanks, Null.
Business,
Supporting Wormy.
business
Wormy Decoder.
life cycle. But yeah, like everybody, like it's just a fact of life, man. You could definitely try to outperform this curve, but really like time is kind of time's gonna cook you in the end. But like I would say
This guy has all the graphs possible known to man. He literally pulled out all the theories. This is what they teach you in business school?
Yeah, this is what they teach you in business school.
This is
But
what they
like,
teach you in business
but like
school.
I literally apply it to life, right? Like
This is what happens when you take no options. I've never seen these
Yeah.
graphs before.
but yeah, like let's say you're instead of sales and time, let's say it's your human capital over time. Like as you're born, like from age 0 to 18, you're really able to learn a lot. Like obviously like a kid that's less than age 10 can learn a language way quicker than somebody who's like age 20. That's just like a fact of life. Like your brain's just developed a certain way. So like in your early stages, like which is basically where you're at, you could have like this high growth curve. This high growth curve, right? Like as you mature, when you're like between 30 and 55, you're really generating a lot of you're just generating a lot of value for your company, and you're not really focused on growing yourself at that point. And when you get to that point where you're not focused on growing yourself, you kind of go into decline. Oh man.
So what's this life cycle extension? Like if you actually focus on growing yourself, you can kind of
Yeah. Let me put stages of financial life cycle. Grower, accumulator. Man, there's so like I know so many graphs. But like for example, right now, you're like in early accumulation phase. Like you should just be investing. Um and then like later in your late accumulation, what do y'all think about talent versus hard work?
interesting.
Yeah, um yeah, like in your early age, you're just accumulating resource, and then as you went from 20 to 39, your income should be growing. From 40 to 54, that's your peak years, and you can save a ton. After you retire, that's kind of when you should be starting to like spend your money theoretically. But
Why?
like
You're so old at that point.
yeah, like you have to balance the future with today. What do y'all think about talent? Is Liam Hayes in the chat, or is he?
Nah, probably not.
Yeah, Liam Hayes is not in the chat. Yeah, man, like this chat is literally full of comp sci kids, bro. Comp sci kids making like $250,000, bro.
Well, these people are also
Yeah, your money will expire, lol. Yeah, man.
a lot of people are still students. You have any questions like that you want to know, like because you're a student or anything? Like someone's messaging me.
Yeah. Everything is a trade-off. Yeah, dude. Everything is a trade-off, but really like there's things that how do I say it? Like to be honest, I'll tell you like you have three main resources in your life, right? You have your time, your energy, and your money, right? Sometimes you have to sacrifice your time to make money. Sometimes you have to sacrifice your money to buy time. Sometimes you have to spend time and money to get energy. You know what I'm saying? Like all you have to think about is those three things, and really learn how to allocate your time, energy, and money to maximize your health, wealth, and your happiness, right? Like if you spend all your time, energy, and money to maximize your wealth, what about being healthy? What about being happy? right? I know one of you folks is up at 3 a.m., right? You're basically like sacrificing um, your energy for the next day and your time for the next day to maximize your wealth, right? Like it's all definitely a trade-off. Like it's all a trade-off, and you're really balancing time, energy, and money, right? And it, like when you're at age 65, like you don't really have energy and money anymore, or like you don't have energy and time anymore, so you mostly have money. Like that's the messed up thing, you know what I'm saying?
Yeah.
Yeah, and that's how
I mean, it
like
shows the total wealth right there.
yeah, like that's kind of how it is though.
Yeah, most people's total wealth actually increases over time like that.
Yeah, but some people's like time and energy are worth way more than other people's just because of supply and demand, right? Like for example, in finance, you're just worth way less because there's way more people that are in finance. You know what I'm saying? Or like if you're an accountant, like there's like 50 accountants per job. Obviously, they're gonna get paid less than like a comp sci kid. Like there's like the job market's thirsty for comp sci kids, are they not?
They're pretty thirsty.
Yeah, they're pretty thirsty.
But
like
they slowed down the hiring a little bit.
did they? Okay.
Yeah.
Yeah. Like in finance, it's ridiculous. Like at our work, there'd be so many people trying to apply for the same job. It's like, bruh. But a lot of them are kind of whack.
There's a lot of kids applying for comp sci jobs, but there's just so many jobs. Like even working in the industry so long,
Yeah.
like there's gonna be more and more
Yeah.
jobs.
Yeah.
There's
But as you age though, like everything is a trade-off, but as you age you'll identify certain activities that isn't a trade-off. If that makes sense. So for example, like if you're really, this is that corny ass saying where if you find a job that you love, you'll never work a day in your life. That's actually true. Like there's gonna be like certain activities where you want to spend time on it. It gives you energy and it makes you money. Like there's going to be look for that in your life where you don't have to make trade-offs. But really at the start of of life, like I would say like 40 or less. I don't know. People live till like age 85. So like you need to identify what gives you energy and what gives you money and what gives you time, and like hopefully you find something like that. Like for me, I realized it was finance and coding. Like I do not need sleep if I'm trading. Like I could trade for like I've done like 30-hour shifts, no sleep. Like even poker. I don't know if you guys are poker players, but I can literally sit at a poker table for like 20 hours straight.
That's crazy.
No sleep. But there's gonna be like, I know it sounds like everything is a trade-off, but you're gonna identify something that you know, like isn't a trade-off, and that's something is like what you should be pursuing, right? Like some people, they only do activities that give them energy, and they don't care about money and stuff like that. I don't know about that, because like you should be able to provide for your family and whatnot.
I could tell that Afzal is in comp sci though, because everyone says that in the industry. Like everything is a trade-off, which is true. That's why you kind of need to know what you're optimizing for.
Yeah. When you do something you enjoy, time doesn't even exist. That's literally a trade-off though.
I don't know.
Yeah, it's literally a trade-off. I think I know what SB is talking about. Yeah, it is a trade-off. It is a trade-off for sure, but like you're minimizing your trade-off and you're maximizing you're kind of maximizing like the output. Yeah, when you do something you enjoy, time doesn't exist. Yeah, that's called flow state, bro. Yeah, like man, I can literally pull out all the graphs.
Like this guy got all the
But
articles.
yeah, like I know what you're talking about. Like when you do something you enjoy, time doesn't exist. But yeah, you're right, dude. Like if you identify something that like matches your skill level as well as your challenge level. Like I know for sure at my work, like definitely uh, like as my skill level grows, I literally ask for more work because like otherwise, when I live in the apathetic or the boredom, bro, like I literally don't feel good as a human being, man. To be honest, like the best way to challenge to like get into that um
Flow
like
state.
to do so, like for me personally, my thing is like to try to make time not exist. I try to like challenge myself to grow, and that kind of makes time not exist, to be honest with you. But yeah, this is basically what you're talking about, like matching your skill level with your challenge, and
I
then
actually agree a lot with this
yeah,
graph.
like you could definitely get into flow state if that makes any sense. But yeah, like a lot of the people like Michelangelo and whatnot, like I don't know if you ever played sports, but that's kind of what I chase when I'm like playing basketball. Like when you're playing a good match, like man, I remember when I would play like a kid. Like when I was playing as a kid, I'd be like playing 3 versus 3 versus like some randoms, and I'd be like, man, this is such a lame game. I'm like 11-0 against this kid.
Yeah.
And then like there's other games where it's like so close that it's so fun.
Yeah.
You know what I'm saying? And then that's kind of like at that point you could literally, I think we played basketball till like 2 a.m. at some points, right?
Yeah.
Yeah. But yeah, no, I know what you're saying. When you do something you enjoy, time doesn't even exist. Yeah.
Flow
Chase
state.
that,
Flow
chase
state.
that, chase that. Like crave that. That stuff is so addictive, bro. Okay, should we actually do work now?
Unless y'all want to talk about something else, we can talk about it.
Yeah. We could talk about it.
Here, switch for a second. I need that better chair. My back.
Wait, let me use washroom quick.
Flow state is amazing. No, are you cracked already? What does that term even mean? My brother's using the washroom. But literally, all you need to do with this guy is literally talk about a random subject, and this guy could go on for forever. Trust me. Follow his stuff. He has like 2 hour long videos. But how to be a cracked engineer? I don't know. There's no real shortcuts to being a good software engineer. It's a lot of practice. It's literally just a lot of practice. And I agree with a lot with what my brother said related to that flow state graph. I'm asking you how to get cracked. I mean, being cracked is I feel like being cracked is relative. You know what I mean? Like, what does it mean to actually be cracked? It depends. Like, if you're in the Bay Area and you're with a bunch of people who are in Ivy League schools, who came from Ivy League schools, like, not everyone is cracked. Some people, like, it's pretty relative. So you're trying to get cracked at lead code specifically. Let's see. Yeah. If you want to get cracked at lead code, I have tons of videos on that too, but I would just say make sure you study all your algorithm or study your data structures. Be able to implement every.
Yeah,
Here, I'll show you. I can show one graph. I can show you one graph that I like. My brother has all the other graphs, but pretty much if you want to do well in any interview, learn how to do all of these things from scratch. Know these specific data structures and be able to implement them from scratch. Linked lists, trees, tries, graphs, stacks, queues, heaps, vectors, array lists, hash tables. Know how to implement all of these from scratch. And once you're able to implement these from scratch, those are like the basic data structures. And a lot of these data structures you use in these algorithms. Like when you're performing a breadth first search or a depth first search, you're performing that. You're performing that on or like to do a breadth first search or depth first search, you're performing that on a tree. And usually for depth first search, you're using stack or using the queue. So I would say learn these data structures from scratch. And then once you figure out these data structures, also know the operations, like the different runtimes of all these different operations. So if you're studying arrays, know the different runtimes of things, like how long is adding to an array. I think I'm on the algorithms part of this. Yeah. Okay. Nice. Like if you want to know all the algorithms, there's this grokking the coding interview. This is my favorite resource for actually learning all the patterns and algorithms. You can see it gets into two pointer, fast and slow, sliding window.
Yeah.
How
Drop
you
it in the
merge
chat.
intervals.
Command C, Command V.
Dude, I don't even I don't even get money off advertising this, but
Yeah, weird.
in place manipulation of linked lists using two heaps, k-way merge, top k elements, modifying binary search, subsets, greedy techniques. Like these are all the different algorithms. And I literally went cyclic sort, topological sort, right? So after you kind of learn all of the data structures, you can start implementing like all of these different algorithms. And this is just a small list. Honestly, like just learning this small list won't get you cracked in an interview for interviews. Yeah, and then learn like other concepts like memory, recursion, dynamic programming. I mean, Big O, you should start learning that right away.
Yeah. How many people have you interviewed in your life?
Probably like, I would say over 100.
Holy.
Like dude, I've been interviewing people like 2 to 3 times in a week these days.
Dang.
Yeah.
Why?
I don't know. We're just hiring like crazy.
For what roles? Just
Everything, software, senior software, whatever.
Yeah. Maybe tell them about yourself, like what you do.
Dude, yeah, they already follow me. They know.
Yeah. Just go over it a little bit.
Okay, yeah. So pretty much, I'm a senior software engineer out in the Bay Area. I pretty much got to that role within like 3 years. So I pretty much like moved up fast, and I could talk a lot about all the different ways that I moved up. I didn't really do anything specific to move up. I spent a lot of time on my own, like studying concepts and like learning the tech stack like inside and out in order to make me more productive at my job and make me more like when I go into conversations. I just know you for DS. Yeah. Okay. Yeah. So outside of doing data structures and algorithms, I work a normal job. I work at a like a unicorn company essentially in the Bay Area. So
do they know what the Bay Area is? San Francisco.
Yeah,
Say San Francisco.
I live in San Francisco. I work for a unicorn company that's like hopefully is gonna IPO soon. So it moves quite fast, and a lot of the stuff I work on is like with Python. We do a lot of Python object oriented stuff like that. A little bit of infra, like just random regular software job right there. I pretty much just started doing this YouTube stuff because I did a lot of, like I interview a lot of people, and I also wait, let me increase this. I interview a lot of people, and I've done a lot of interviews. So I want to like kind of share some of the stuff that I've done. So why algorithms for solving range are not. Why algorithms for solving range query? What do you mean by range query?
Oh no, you retracted.
Retracted.
Yeah.
Yeah. So yeah, pretty much I just work in the Bay Area. I'm a software engineer there. In all my interviews, I pretty much ask lead code questions. So I'm just exposed to these lead codes pretty much like all the time. Yeah, that's pretty much about me. And right now I'm a lot focused on data structures and algorithms, but I'm gonna start dropping content on system design too, because system design is pretty much what you need in order to get like a senior role or something. If you're good at data structures and algorithms, you can get like a intermediate role. But so I work for a unicorn company
like
in the Bay Area.
What's your company's market cap, like 13 bill?
The company I work for is worth like $15 billion.
15 billion? What was their last equity raise? Like 300 mil? That's what I read last time.
Yeah, this is all like public stuff, I'm pretty sure, but yeah. I mean,
Okay, I shouldn't talk about that.
Yeah, I think it says the valuations and you look it up. But,
oh man, my bad.
Honestly, yeah, I don't know what I can and can't say. I'm now learning Python for leak code, so you basically teaching Python in your last few videos. Nice. Yeah, hope you're learning a lot about Python. I would suggest using Python for your like coding interviews, because candidates, whenever they're using something like Java, they just spend so much time with the syntax, with the typing, with some weird errors. And most of the time when we're doing algorithm questions, I just want to see how you think about problems. And a lot of times you actually need to be able to solve the problem, have running code. So Python just reduces like the barrier to getting running code up and running, and it like removes away all of the different things that will like bog us down and just allow us to talk about raw algorithms and data
Yeah,
structures
it's
and
almost like
stuff that.
pseudocode.
Exactly, yeah, it's almost like pseudocode. We don't need to, like, I'm pretty if so, I'm pretty confident people will learn how to type their stuff in their code. There's like linters and all that stuff that will stop you from like pushing out code that's badly typed. I've never had like a candidate like who's really good at data structures and algorithms not be able to like work in the real world just because they don't know how to type. So being able to show that you can type in an interview
Yeah.
using C++ and Java doesn't add too much value
Like, what are the best programming languages to learn?
to learn.
Yeah. Like Python.
Python for sure.
Python. Like for me, I know Python, and that's it.
I mean, the whole internet runs on JavaScript. JavaScript is very important to learn as well. Like all these
Okay, I
websites and
see.
stuff are ran on JavaScript, and then TypeScript is like a more strict version of JavaScript, so that's also important. Um, I would say like knowing Python is good, but also knowing Java is like a more object oriented programming. It's yeah.
Yo, Caesar, what do you write in? What do you write in?
This chat is a bit slow. It gets weird.
Yeah, it
Let me
kinda
fix
lags a
let me
little
fix
bit.
this a bit. Let's do like ultra analysis.
No, I don't think you could change it. Can
Yeah.
you? Python, JS, Java, C Sharp, C++.
I would say okay, learning OOP is good. Yeah, I would say if you're in your very first semester, most degrees will first teach you. Most degrees will first teach you just procedural coding. So that's just like creating basic Python scripts and stuff like that. And you only really need object oriented when you're building large scale systems, and it's easier to reason about your program in terms of objects.
Yeah, we always talk about space and time complexity.
Honestly, you can get away with not knowing space optimizations. I don't really care about that. But I would say time complexity is very very important in an interview. Let's see. I would say time complexity is very important because most of the time they're gonna want you to get to an optimal solution, which is like optimal in time. But then also, one thing that I see candidates get really wrong in interviews a lot is when they don't know how to they don't know how to
Simplify.
analyze time complexity properly. Like one of the like the
Let's do a
biggest
lead code question so you can explain line by line, like big O notation and whatnot. Let's
Like-
do a quick one.
yeah, sure.
Yeah, let's chill with the OOP for a bit.
Sure. So the biggest errors I would say like
Or with my learning.
this is a big thing that I've just been seeing recently is when people don't know how to like take the largest term or drop the constants or like if they limit the n that it or like basically you can convert O of n algorithm to like a constant operation if you if you limit the input essentially. But honestly, these are the two biggest term errors that I see people do in interviews, and I'll explain this one first. Like, why does taking the largest term, like, when people don't? What happens when people don't take the largest term? Wait one sec. Yeah.
The technician was
One sec.
Yeah,
There's
yeah.
a technician who's trying to
Yeah,
reboot
yeah,
our Wi-Fi.
yeah, yeah.
So
Do it later.
wait,
though.
why
Do
is he
it
trying to
later.
reboot our Wi-Fi?
because there is something wrong with the optic.
Oh, is he
Nah,
here?
dude.
He's here at the house?
No, I'm
On the
online.
when?
I waited for half an hour for the.
Let's do it later. Let's do it tomorrow.
Baka pwedeng like.
We can't
remote.
hotspot.
No,
this
we
hotspot.
can't. We can't. We're streaming to
We're
like.
streaming, and we have a
Oh,
bunch of
no.
people watching. They're asking some
Oh
questions.
man. Yeah. Oh
Wow,
man.
we almost got our Wi-Fi rebooted.
Yeah, we. Okay, we'll on,
Tell-
on, our,
tell
on, our,
him-
on our next one, we'll do it tomorrow at my house.
Yeah, tell him quickly. Like we'll be done in probably like an hour.
Nah, what? We're gonna do like an 8-hour stream. Nah, don't. Nah.
Okay, so basically, one of the biggest errors I see is people don't take the largest term. No, we're good. People don't take the largest term. So pretend I have code, right? And I have like a operation here that runs like O of n time. And then after, I have code that runs like log of n time, right? So that will give me a final runtime of O n plus n log n, right? So everyone familiar about this?
East Coast and West Coast. He's talking about New York versus SF.
Yeah. So yeah, maybe. Yeah, probably. So this is the final runtime, but if you study big O at all at school, what they say is take the largest term. So this algorithm you could actually simplify from n plus n, or from n plus n log n to just n log n. You can simplify. This is the actual runtime of. This is like the actual big O complexity of this algorithm, right? So this is the real, and this is like theoretically like this is still correct, but if you like take any course, they say don't take or take the largest term. So yeah, and I'll show you what that means in dropping the constants too. But essentially, I've had candidates who are like, oh, I don't want to do this n plus n log n algorithm because it's slower. And then they're trying to find a way that's n log n, but truly their algorithm is actually n log n when you simplify it. And then they'll be like adamant that they don't want to do an extra step, like they don't want to pre-process the array or something like that and then sort it because that's going to slow down their algorithm. But in real life, like their algorithm is still n log n. And I've had that happen so many times of people like not wanting to do an extra step, like pre-process an array just because they thought that this would slow down their algorithm. Does that make sense in the chat? It's a little slowed down. But yeah, I'll just move on to the next part and drop the constants. Yeah, if you have like a, let me move over here. If you have like a O 3, yeah, people literally always, like I had a candidate like that. And it was pretty frustrating. I was just like, are you sure your algorithm? I mean, like, I was just like, just pre-process the array, please, because it's gonna make you able to solve it in n log n. Because sometimes you need to pre-process the input in order to get the algorithm to what you need to, or in order to run the algorithm you want to do. So, and then for example, dropping the constant means like this, right?
What's Malky?
Your use. Exactly. And it makes it more readable, and it doesn't affect the runtime when it comes to big O complexity in general, because you usually have to take the biggest term, which is n log n. So this is just n log n in general right here. And then like 3n, I think this kind of goes to the same thing. Like if I have an algorithm, right? And I have an algorithm that like does an O of n operation, then it does an O of n operation, then it does another O of n operation, right? Theoretically, it's 3n, yeah. In practice, it's 3n. Or I say, yeah, I guess in practice, it's 3n, practice, right? But in big O notation, this thing, you could just simplify to on, right? So there's people who like don't want to, like think that their algorithm is running slow, even though the big O is still on. But they're in their head, they're like, oh, it's 3n, it's going to be slow. And it's important to know that there is like in practice it's 3n, but when we're talking about in the interview, we just care about like actual time complexity, theoretic time complexity, which is on, because you drop the constant of 3. Does it make sense?
Mm-hmm.
So if you do this like 5 times, But five, but so this becomes 4n, right? That's still an O of n operation. Yeah, those are the two biggest issues. Anyone have a leak code question they want me to solve, and I can walk through like how I think about it and how I
let's run a lead
yeah,
code
like
question
how
in real
how I would
time.
solve it. I'll do a leak code question live for y'all. Like
And
ask
then-
me a good leak code question, I'll do it live, and I'll show you how I do it in an interview. Code question. Yeah. I definitely agree with all that stuff. Don't make these mistakes. Drop constants and take the largest term. That's like the big old complexity time. Also, there's people. Also, another thing to take into account is
Just gonna do laundry.
like one error that people make is you need to take into account all the variables. So, for example, let me write like a quick piece of code. Let's see. Yo, anyone have a leak code question they want me to solve live? Test.py. Analytics. Yeah, my brother wants to take a break, so I'm gonna do a leak code question live. I'll just find one and I'll show y'all how I think through it. 2054. Two best non-overlapping events. Okay, interesting. Have I done this before? Okay, I haven't done this before, so let's like look. So what I would do is first look at the left side and try to understand what the question is asking. Me and my brother were solving leak code questions last night. So let me drink this. Who's Melky? You're excited to like Melky. So we're given a 0 index. Wait, let me switch the appearance here. Appearance. Dynamic layout. Dude, I don't like this dark mode for this. Advanced shortcuts. Okay, one sec. Let me figure out how to get this appearance. Okay, light. Nice. So two best non-overlapping events. You are given a 0 index 2D integer array of events where events I is equal to start and end time and a value. The I event starts at time I and ends at time, so it ends at the start time and end time. And if you attend this event, you will receive a value. Yo, John, they gave me a leak code question to solve live.
Dang.
So you're given a 0 index 2D integer array of events where events has a start and end time. The I event starts at start time I and ends at so you're given a list of this. This starts at time 1 and ends at time 3, and you capture a value of 2. If you attend this event, you'll receive a value of I right there. You can choose at most 2 non-overlapping events to attend such that the sum of their values is maximized. Return this maximum sum. Note that the start and end time is inclusive. That is, you cannot attend 2 events where one of them starts and the other ends at the same time. Wait. Note that the start time and end time is inclusive. Okay. Need to write that down. Inclusive. You cannot attend 2 events where one of them starts and the other starts at the same time. More specifically, if you attend an event with an end time of time t, the next event must start at or after t plus 1. Okay. Wait, does that make sense? Okay. I get what the question is asking. It's a good question. So you're just trying to find let me see. So you're trying to find two events. So you're trying to find two events where if you choose the two events, it will be maximal value, right? So what I'm thinking, your integer starts with, and if you receive value, you can choose at most two non-overlapping events and attend such. So pretend we're given, or let's look at this input quick. Let's look at the different test cases to just make sure I see what they're talking about. So we go with example 1. I have something in my head already, but like even if you think you know what to do, you should just walk through an example, because you might actually not know what to do. You know what I mean? So we're given two events, right? Or we're given 3 events, right? One event is goes from time 1 to 3 inclusive, right? And then that's event 0. Event 1 goes from 4 to 5 inclusive. So this includes the 4th hour and the 5th hour, right? Or 5th minute. And then we have 2 and 4. What is this? Yeah, 2 and 4. So those are the 2 events. So we just need to choose 2 events that will maximize the sum, right? And there's only a few options here, right? If I go to time event 0, I'll get 2. Let's say the value is the money you get. So if I attend event 0, I'll get $2. But then that stops me from doing time. That stops me from doing time 2 right here, or event 2, right? But then it doesn't stop me from doing time 1, or event 1, right? So that allows me to get 4, right? What if I attend time 2? If I attend event 2, it stops me from doing event 0 and event 1. So the most I can get there is 3. What if I do event 1? Well, if I do event 1, it doesn't really like if I skip event 0 and skip event 2 and just do event 1, I only get capture 2. But I guess even if I take event 1, I can also take event 0, or I can also do event 0 because that doesn't block it off. So kind of like the most I can do there is 4. And if you take a max of that, the best you can do is 4, and you just have to return that. Like you don't have to say which exact events, you could just return that. That makes sense. So let's look at this one. So this is a good edge case. So this one, you get the best result if you actually only go to one event. So instead of going to event 1 or event 0 and event 1, I could just go to one event, event 2, and maximize the event there. So I'm thinking 2 things. I'm thinking like let me think. The 2 best non-overlapping intervals. I mean, the brute force would literally be just like select one event, and then after you select one event, filter out the events that you cannot do after you select that event, and then just see what other events are available and go to the one that's the maximum, and then capture that like value, and then do that for every single event, and then just take a max on all of that. So it'd kind of be like if I have event 0, or yeah, the brute force would be like, okay, I'll take event 0, and then I'll see what's the max I get if I take event 0, right? Then I'll take event 1. What is the max I can get if I do event 1, and then remove all the overlapping intervals of event 1. And then I'll go event 2. What is the maximum I could get if I take event 2? So that'd be a brute force O of n squared solution. That makes sense. but maybe we can get it lower than that. Um, and maybe the fact that we only need to select at most two non-overlapping events will like make our algorithm more faster, essentially.
Is this like a 2-pointer solution or a 1?
Let me think.
Because like I'm almost thinking you would have to do, yeah.
So one thing that
Could you use sort and then use 2-pointers?
Yeah, I think the problem with this like I'm either thinking of using some sort of dynamic programming or either just a greedy solution. So there's three different solutions that I'm thinking through my head. Possible solutions. Like we do some, like obviously the brute force is what I just mentioned before, but then how can we, and then that's like a O of n squared brute force, and I mentioned how that would work, which is like you take one event and you cancel out all the other events that like became invalid because you took that event, and then you try to look for another, like the biggest event that's not invalid.
I see.
Right?
Yeah.
And then I have to look at every possible option in order to see what's the best two events that I can take.
Yeah.
That's the most brute force way. I kind of want to implement that just to see if it's going to crash the code. And then after that, I can figure a way to either do like a greedy algorithm. I think we can get our algorithm to like O of n time. Or we can do like some, you can even just using a dynamic programming to O of n. And the thing that's like coming to my head is that whenever you're working with a problem where making one decision will affect the decisions you can make later, you can run into you can like run into more issues. So for example, if I make a decision to take event 0, that affects the decisions I can make in the future, because that kind of affects what events that I can take before. So I'm exploring a way that maybe I can capture, let's see. What I'm thinking is like maybe we sort all of the events. We sort all of the events by their start time. Then essentially what I'll do, maybe I can keep like a cache of like the largest elements past a specific start time, essentially. Let me see. Yeah, that's what I'm kind of thinking that approach. Like what I want to do is like pretend we're giving event 1 and we're given event 0, given event 1 and given event 2. I want to basically subtract, or I want to be able to filter out all of the other events that I'm overlapping with really fast. And then I want to know with who I'm left with, what is the most optimal, or like pretend I take an event and it ends at time 3. I want to be able to ask the question, what is the most value I can capture after time 3, right? That means pretty much all I need to do is look at each event and then figure out like when does that event end, and if I could figure out what's the most value I can capture after the time my event ends, I can speed up the algorithm a lot. I don't have to search for that specific event. Does that make sense, Null? What I'm thinking here? I just need to really think of how to do that. I think that would be the optimal algorithm. Is Null still in here, or he asked the question and dipped? Because remember, John, what I was saying of like how usually you come up with a brute force and then you just try to like optimize it like a gradient descent.
Yeah.
So my initial approach was like very brute force, where I just grab an event and then I just start comparing it with every other event to see. It's pretty much like a double for loop. The first outside.
So like a map to store it.
Let's see. I would say I would I'm kind of thinking of like pre-computing for every time, something like for every time. I'm thinking of pre-computing backwards, like, okay, if I'm at time 5, if I'm at time, or let's see. Yeah, because you need to be able to find the maximum of. Yeah, this is a good question. Let me think about it a little bit, because there's two ways that I'm thinking of it in two. Like my algorithm is gonna be in two ways, right? I'll just write the pseudocode. So first, pick an event, right? 1. Then after we pick an event, we need to filter out all of the events that are overlapping, right? Afterwards, we have to pick the maximum from events that are left. Pick the maximum. So first, pick an event. That's pretty easy. You just like literally pick an event. But how do you like filter out all the events that are overlapping fast? I mean, we can do like after we sort, we can kind of do a binary search to kind of remove all of the events, or like to figure out which events to look at. We can do like a binary search on this specific array. So for example, if I know that I'm end at 3, I just start looking at the start times for all of these and see if any start times is like less than 3 or overlapping with 3. And because first we'll sort this, right? So we'll sort it by start times. So now when I pick 1, I can binary search for the first task. I can binary search for the first task whose end time is greater than 3. And since it's kind of sorted here, but it's sorted by start time. Okay, wait, let me think. Because if it's sorted by start time, how do we... Okay, we get... So we get anybody who's... Oh, I think we're good, yeah. We'll basically look for... We'll binary search for the first start time. So we'll sort by start time. Sort by start time. And then we'll binary search for the first start time that's greater than my end time. Right? And then once we're given that, once we binary search for the first start time that's greater than my end time, we could essentially, we'll be able to do this faster, filter out the elements that are non-overlapping. We can turn this into like a log n. And then if we're able to pick out the maximum from the events that are left in like O of 1, that are left. If we can do this in O of 1, we're good. So I think what we can do is we can work backwards from an array and build like some sort of prefix sum, which is going to store pretty much... Dude, this is using a lot of different concepts. We can store one sort of prefix sum, which is basically going to be like... We're basically going to capture... So like if I only have binary search on a multi-dimensional array, well, we're gonna be binary searching on, well, we're only gonna be looking at these very first elements, right? After we first we'll sort. This is my algorithm right here, and I actually think this is gonna work optimally. Sort the events by start time. So that's gonna store all these events by start time. Then I'll pick out an element.
Show them like every single line. What's it called?
Yeah, we're gonna do binary search on the very first, because we're gonna sort by start time. Sorting by start time allows us to do binary search. Dude, the solution, this doesn't even have a, oh, it does, sorry. I didn't look. I just lapped it. It looked like it didn't have a solution. So sorting by the event start time allows us to do binary search, right? Then we can kind of pick an element, and we can filter out all the elements that are overlapping that element in like log n time, because it's now sorted by start time. So we can do binary search based on the start time, and then we'll binary search for the first time that's greater than the end time of like the candidate element, right? And then from there we can like pick the maximum from the events that are left. And how we can do that is we can just like create this prefix sum that creates a maximum of all the events that are to the right of it. And maybe we could even simplify this later. But what we can do is like pretend we only have this event left, right? What's the max I can capture? 2, right? Pretend we only have these 2 events and I can only pick one. What's the optimal I can capture? 3, right? Pretend we have these events, right? These 3 events left. What's the most that I could capture? 2 or 3, right? If I'm looking from this beyond, the most I can capture is 3. So pretty much that will allow us to like pick the maximum from the events that are left in O of 1 time. So if we combine all of these things, we can come up with an n log n algorithm. Instead of n squared. Does that make sense? That's like the solution I'm thinking. And could we get that even faster? The thing is, when we pick an element, we need to remove elements that are overlapping with that element. So it's hard to do that fast. Like, how do we know we can remove like we can't just look to the right. Like after we pick this element, pretend there's more overlapping ones. We need to be able to remove those elements from our candidate set faster.
Hey, Noel, did you do this question already?
Wait, start.
Dang, you're giving me a full tutorial, eh?
No, is my solution sounds right? Or what? Let me know if I'm like moving the wrong direction.
Yeah, have you solved this?
Did how I break it down kind of make sense? Should we look at the answer?
No, don't code it up.
Woo! Dude, this is
Code it up. You have to code it up.
Dude, this is like involves like modified binary search, which is not bad. Yeah, you showed me. I'm just missing some concepts.
Nah, you code it up. Code it up because you were gonna teach me binary search today.
Yeah, I'm gonna teach my brother binary search at the same time. But this. Yo, SB, I'm showing how to solve like this leak code question from scratch, and I think I introduced the concepts. We're gonna be doing multiple different things. We're gonna be doing prefix sum, and we're gonna be doing. To solve this, we're gonna use prefix sum. And then we're also going to be using not just prefix sum, we're going to be using modified binary search. Are y'all familiar with binary search?
Binary search is basically like you sort it, meet halfway, you see whether or not you want to do left or right of that halfway.
Yeah. Dude, but what if we go down this path and does...
Then you get...
I bet we could just hard code this too. Or
you
we
get
could...
the job, bro.
We can just do the most... We can also do a manual approach.
Nah.
Wait, so we take advanced 0. I
Forgot
forget
it. Okay, you're gonna learn it.
Okay,
You're gonna run it back.
we're gonna do binary search then. There's a leak code question called binary search.
Can I do it?
And there's like similar questions, binary search. Because I think there's two different types of binary, or there's 3 variations of binary search that you really need to care about. Right? There's regular binary search. There's binary search. Binary search. Smallest element that's larger, which is what we're gonna be doing in ours. Binary search to get the smallest element that's larger than target. And then there's a... Yeah, exactly. And then there's another modification called binary search. Binary search largest element that's smaller than target. We're going to be doing this one. We'll need this version for our algorithm. Binary search for the smallest element that's larger than target. Because pretend we have some end time. We need to find the first element that's greater, whose start time is greater than this value. And it needs to be the smallest one in that list. And I'll like explain why that makes sense. Monotonic by smallest element that's larger, different. Yeah, I guess. So let's just work. So binary search, you can only do binary search on a sorted array. That's the first thing.
That's right.
Yeah.
Yeah.
That's the first concept. Only do binary search on a sorted array. So if your array is not sorted, you're gonna have to use up n log n time in order to sort it, and sometimes that defeats the purpose. Like you could just do that kind of defeats the purpose sometimes, having to sort it. So you have to think that sometimes your input is not sorted, so you need to sort it in order to get that. So you need to take that into consideration. But pretend our array was already sorted.
Is it or no?
No, we have to sort it.
Are you gonna use like the sort function, or are you gonna write a...
Okay, let's do 14. So there's 2 ways to search through an array, right? The first way is like a linear search. So pretend the target is 14. Or let's pretend the target is 27. So the first way to search a array is a linear search, which means you start from the left side and you move all the way to the right side. So is this element the target? No. Right? Is this element the target? No. Is this element the target? No. And you pretty much linearly search. I mean, you could like search like all types of ways, but this is the most simple way of just like moving from left to right, looking for the target. And finally, we reach number 27. So that's a linear search is a O of n time complexity, right?
Yeah.
Because as the array size increases, we have to scan more elements. So that leads the time it takes to find the element grows proportionately to the size of the array. So that's linear search. But since our array is sorted, we can do a much faster algorithm using binary search. So pretend I'm looking for the target of 27. Right? To find the target of 27, what if I just look at the middle first? Since we know it's sorted, the middle right here how did you learn this stuff? Just leak coding, practicing and stuff. But essentially, this is the worst case of doing a linear search. But what if we had to do a binary search? Appreciate it, man. Thanks for watching. So now, pretend we're looking for a target of 27, right? And we know this array is sorted. If we look at the middle element, if like the middle element is 10, right? That means that since the middle element is 10, could 27 be in any of these values?
No.
No, because we know that since this is sorted, all the values are less than the other ones. It kind of goes like that. So we know if the middle is 10, everything to the left of 10 is going to be less than 10. So if I'm looking for 27, it makes no sense to look anywhere to the left. So I could kind of like not even look at that at all. Right? And essentially all I need to do now is that's how I cut the search space in half. And now I do here. Now I'm looking for 27. 27 is greater than my middle element. So I know 27 is not going to either be my middle element or anything to the left of it. Right?
Yeah.
So I can cut that search space in half. And then I just finally get to 27. And you could see that I found 27 in just like two like runs of the algorithm.
Yeah.
Instead of n.
So this would be like n log n.
Yeah, exactly. Because like the
Draw
fact
out the graph so they
essentially
draw out the graph.
an O of n operation is kind of like it grows proportionally with the input. Say this is the input. Or
Input size,
input's
size.
down here. Input's down here. And this is the runtime. So basically as the input size increases in the x-axis, the runtime increases on the y-axis proportionally. That's an O of n algorithm. But this algorithm we're running is more of a n log n algorithm. So as input running, it like goes like this. It's way slower. And if you ever like studied logarithmic algorithms, they grow really, really slow. It's like really almost like constant because it's at some point it's just growing really slow. So this is a log n, and then log n is usually log 2 of the n, right? Like when you say log n, it means the base is 2, and the base is 2 because at every portion we're halving the input size, so we're dividing the input size by 2. So that's why the base is 2. If we were able to remove like 3, the algorithm would be like if we're able to remove like a third or 2/3 of the search space, then the algorithm would be log 3 of n actually. But log 2 of n because we're just halving the input size at every iteration. So it leads us to this algorithm which is much faster. Like as the input gets really big, it's gonna make a big difference in our like the delta here is huge. Yeah. I was gonna say the alpha, but
Dang. SB.
no, is
Are
that
you
making
learning a
sense? SB, is that making sense?
That was like a full tutorial.
Did that make sense of how? So now let's actually implement this thing.
Yeah, like I think yesterday we were practicing a lead code question and you told me straight up like, yo, the first mistake you did was start coding right away.
Yeah. Okay, cool. So pretend we're doing a very simple thing called we're creating a very simple array right here. So this is binary search is very, I think the things that you need to worry about people think binary search is easy, but you can run into a lot of bugs in your binary search. I think the most like common mistakes I see is people like not able to like shrink is like being able to picking the right middle. Because picking the right middle doesn't really affect you when you're doing this first binary search, regular binary search. But picking the middle essentially means like if you have 0, 1, 2, right? Picking the middle here is easy. It's just like you know the middle, right? But pretend I have an even number of digits.
Oh, you'd have to like round down or round.
Yeah,
up
like
somehow.
which middle do I have to choose? And choosing the right middle here, like, can affect your algorithm. Like, you can't solve, like, choosing the right middle here is the key to doing like these variations, and then also shrinking the array properly is the key to doing the variations. So those are the two things that I would look out for, is like which middle am I picking if I'm even, and then how am I going to shrink the array, like how am I going to shrink the array essentially. Watch out for picking the right middle.
You're gonna teach this first and then code up the.
So left plus right divided by 2. That's more like, that's also a mistake people do, and that's just for mostly integer overflow. So pretend, and I'll show that later. Picking the right middle, but that's not exactly what I mean, null, and I'll explain it in a bit. But let's just do like a very basic binary search where we're given an array. We're given 1, 3, 6, and it needs to be sorted, right? 6, 10, 14, 18, 27. So we have this sorted array, and pretend I'm looking for a target of 27. Let's just like define a binary search algorithm here. Binary search. And you're given an array, and you're given a target. So the first part is capturing the middle. How do we get the middle element? Usually we define a left and right pointer. So let me grab this. So usually what you do for binary search is you define a left and right pointer, and the left and right pointer defines like the bounds, like the current search space. So when the left is at the first element and the right is at the very end element, that means the search space is like this whole array so far, right? So I'll initialize with left and right equals 1 is at 0, and 1 is equal to the length of the array minus 1. So basically what I'm saying here is my search, I put my left and right here, and what I'm saying is my search space is between these two values, right? And now what I'm going to do is like while left is less than equal to right.
Why do you use less than or equal to, not just less than right?
I mean,
because yeah, that might be a bug if you do a less than instead of a less than or equal to. You know what I'm saying?
And it all depends. You kind of need to like modify the algorithm sometimes, because I like to use while left is less than right for the modified binary searches, because essentially while left is less than right, this allows us to like shrink our search space all the way to the end. But if you do while left is less than right, you will never shrink the search space to less than 0, essentially, because you'll always, the worst case is you'll be like this, and you'll always run until while left is less than right. I mean, you'll get here, but the search space is still just that one element. Versus if you do while less than and equal, or less than equal to left is less than equal to right, it will run one more time, and either this will go there, and then this will go there, and this would go there.
Yeah, so you never ever miss the last element.
Yeah, but even if you do like less than left and right, you could always just capture the last element at the end
with the manual.
like capture last element, and that's a lot of times that's actually can be useful.
Yeah,
capture the last element.
Yeah, let's see just the less than or equal to though.
Okay, we'll do less than equal to. So basically what I'm saying is like there's still elements in the search space. So while the left is less than equal right, that means there's still places to search, because what I said is left and right define the boundaries of the search space, right? So so the first thing we need to do is capture a middle. So what is the middle? 1, 2, 3, 4. So how you take the middle is usually you take, you want to take where the left pointer is, and then you want to add half the array to the left pointer. You want to take half the size of the array and add it to the left pointer. So to take half the size of the array, usually it's something like this. You take the middle is equal to the left, because that's like the left bound, plus um, right minus left. Right minus left gives us the length of the array. So pretend this is at 0 and this is 8. Or 0, 1, 0, 1, 2, 3, 4, 5, 6. Sorry, this is 6. Right? Right minus left. So 6 minus 0 gives us a length of 6. That's how big our array is. Right? So if we take right minus left, that gives us the length of the array, and if we divide it by 2, that gives us how big half the array is.
Yeah.
And if
And
we
then
have,
you're doing the double divide to round down.
yeah, it'll round down. So basically, what's 6, right? 6 divided by 2 equals 3. 0 plus 3 is equal to 3. So we get this element,
I see.
right? Pretend that our search space was a bit smaller. Pretend our search space was actually like here, right? So now what's the length of the array? It's pretty much 0, 1, 2, 3, or 0, 1, 2, 3, 4. 4 right here. So what's right minus left? 4 divided by 2 equals 2. So if we take 0 plus 2, we get this. See that?
Yeah.
Sorry. So that's literally how we capture the middle pointer. So mid, left, plus right. So now that we have the middle pointer, what we say is like if the middle of the array is equal to the target, I mean, I'll just return that index. Like pretend binary search is return index. Returns the index of target, right? So if the array is equal to the target, then we return that index, right? The other case is like elif the array mid is less than target. If the array at the middle is less than the target, like it is in our case, then what I want to do is I want to move my pointer. So let's move back to here.
So basically, you're gonna be so when L is equal to M and equal to R, that's when you found the target.
Well, we find our target if the middle is actually equal to the target. Like if we actually find that index.
Yeah.
So
But you only get there when L and R are equal to the mid.
no, you can get there quicker. Like pretend I was looking for 10, right? Pretend like we're basically like I remember in one of your videos you're talking about the process of elimination, right? So essentially that's what we're just doing. We're just doing the process of elimination. If our target was 10, right? And we did 6 minus 0. 6 minus 0 is 6 divided by 2 equals 3. And then we land on the mid is this element right away. Then we could just return 3. We'll return mid, right? And left and right never even moved.
I see, yeah.
Pretend we wanted to find 14, right? Pretend target is target equals 14. Now let's just walk through this. What's the middle? 10, right? Is 10 greater than, like if 10 is less than, so if the array mid is less than the target, I can officially say I can move my left pointer to mid plus 1, right?
I see what you're saying now. Just acknowledging.
Okay, yeah, null's making sense. So what we're doing is like if the array mid is less than target, we can move our left pointer equals to mid plus 1, right? Why is that? Why can we move it there? Because we know 10 is less than what we're looking for. So we know we don't even have to look at anything to the left of 10, and we don't even need to look at 10. So we could move our left pointer past this index,
I see. Yeah.
right? That's why I'm moving.
Yeah. So you could actually just skip. Like you're making it more efficient a little bit.
Yeah, yeah. And I'm reducing the search space. So like I'm reducing the search space. So now we have we don't have to look at these, and now we calculate a new middle, 18.
Yeah. If it's not the element, it and find a new middle because the target is past that point. Yeah.
Okay,
That's basically what you. Yeah. I see.
now we're at 18. Is 18 less than 14? No, it's greater than. That means since 18 is greater than 14, then we don't need to look at anybody on like this side, right? Because we know 18 is greater than 14, so anybody to the right of 18 will also be greater than 14. So I can move my right pointer like down past the middle. So else case is when we move the right equals mid minus 1. Right? And at the end, if I can't return anything, I'll just say return -1, which means I couldn't find it. That makes sense so far? Or no? Just reason about it a bit. Does it make sense, John? Or no?
Yeah. I think I just got lost at the capture the last element piece.
Well, like pretend basically this loop runs until we can find the target, but if the target is not there, we're going to reduce our search space all the way till there's no search space, and then we'll exit this while loop with no result. So returning -1 just means that we couldn't find it,
I see.
right? Otherwise, we'd return an actual index.
Why wouldn't you just return false?
Well, it depends on what your binary, like, yeah, you could return false here. It depends. But
Oh,
we
no,
want to
no,
return the index of the target.
Like we know that the target is in there.
Well, we don't know. So this
Yeah,
is the edge.
what's the return -1 though?
It's just like, it just means like you can return whatever you mean. You can be like return like false too if you want.
Okay, yeah.
But return -1 means that yeah, it's out of the range of the array. Because right here we want to return the index of the target. So -1 is just like some random value that means like we couldn't find it there.
Okay, I might have to take that away then.
Right? So that's a simple binary search. Let's run that on the leak code question. Right? See, look, write a function to search target in nums. If target exists, then return its index. Otherwise, return -1.
Oh, okay.
That's kind of why I'm doing it.
Do you want me to run this? Oh no, you just wrote the code.
Yeah, because I wanted to show them I want to show them how to modify it and make it work. Nums.
I see.
Quick little binary search. Yeah, exactly. Now let's move into modified binary search. How long has this stream been? It's gonna be our longest stream ever.
Word.
Let's go into modified binary
You
search.
cooked that up quick times.
Yeah, that's like a quick.
You didn't even read the question though. You just ran the.
So.
Did you eat the chips already?
Yeah, we'll get more.
Yeah, later.
So how do you get the binary? Noel, are you familiar with how to get the binary search smallest element? And I'll let my brother reason about this code quickly while I just grab some water. Give me a second.
Okay, could you grab me some too in this cup?
Yeah.
Or you could just fill up yours and then I'll just fill up mine with yours. Holy. Oh man. I definitely got lost after a certain point here. Like this return -1. I get what you're trying to say with the thing, but like I don't know why not return false. Oh man. Okay, hurry up. My brain's cooked, bro. Run. Don't leave me with these guys
Look
for
at the
too
binary
long.
search and try to reason about how that works. But you see, like, it's the process of elimination.
Yeah. So you guys make me want to study really hard. Dang, I'll show you. I'll show you some motivation to study really hard. Do you know this website called Levels FYI? This will make you study really hard. Name a company, and let's look at the salary band. Like Amazon. How much is a SDE one making? Bruh. That should make you study really hard, bro. SDE 270. Yeah, this is Levels FYI. So Levels FYI basically shows you like the compensation at like every company. So like at Facebook, this is how much they're making at like the lowest level. Coinbase, that's like a crypto. But Levels FYI is like something different. But basically, like what you would look at is you would look up like San Francisco, Bay Area, right? What's the software engineer in Calgary, Bay Area? What are they making? So like the lowest 25th percentile is making 195K. Like the top 75% or better is making 350. The top 1%, the top 10% is making like 460K. I don't know if this is like, why is it tweaking like that? It doesn't even, why is the chart bimodal? But yeah, that should motivate you, man. Get motivated by the money, bro. Nah, that's kind of messed up. I don't know. That's just me though. Like, that's like life-changing amounts of money, to be honest. But yeah, you could use that. Okay. I'm trying to learn this binary search though. Like I kind of get it, but I don't get this return -1. I might just use a GPT to explain. But yeah, isn't that crazy? Like, bruh. And I don't think those guys work like 100 hours a week, or like, I don't know, in finance to make that kind of money, you're working like, bruh, you're working like 70 hours a week plus. I don't know if that's what it's like over there now. Left, right. Explain this code. ChatGPT, yeah. You need to do it a couple times on return problems to understand. What is
What off in here?
-1? But yeah. This code is a binary search. I heard IBs, investment bankers, work 100 hours a week. Yeah, but you're kind of like, I don't know. I don't like investment banking because like at the start, you're kind of just like a pitch book monkey. I don't know if you know what that is. Yeah, it's not for everybody. Like, for some people, they just love buying companies, man. Love buying companies. Like, it depends on like what type of IB. There's like mergers and acquisitions, which is pretty fun. There's like equity raises, which is pretty fun. There's debt capital markets. There's a couple of different there's a couple of different like investment banking divisions, but like for me, find smallest letter greater than target. Bruh, this guy didn't even solve your two best non-overlapping. Let him. James gotta fix that first too. This code is a binary search algorithm which is used to efficiently find the position of a target. But yeah, nah. That one kind of shows you why you use -1. Oh, okay. I might have to do that by myself.
Well, I need to reduce the volume. Did you put that into ChatGPT?
ChatGPT, yeah. Like I'm just trying to learn. Is the target the root? Bro, let's just go through the code line by line. The code is a binary search algorithm which is used to efficiently find the position of a target value in a sorted array. Here's a detailed explanation of each part. So, okay, I get this part, left and right pointer, and then you just run a while loop. The loop runs as long as the left pointer is less than or equal to the right pointer. This ensures the search. Yeah, I'm not sure what a root is, man. You're talking to a donkey, bro. Like literally. You're literally talking. Oh no, we're running it on an array. Maybe James, when he pulls up, he'll understand.
What?
Okay, go through this this Jippity quick. I'll be back.
Yo, we're running binary search on an array, it's not a binary search tree. Or like, it's not a binary search tree. I know what you're thinking. So, let's move into like one small thing called let's move into the other variation called binary search the smallest element that's larger than target. So this is regular binary search. So this is regular binary search. Let's like do the variation of binary search called. We're gonna do the regular. Let me copy and paste this. Smallest, largest search.
Is the -1 just a normal thing that you do?
Well, we're basically just saying -1 means that it's not in the array.
Okay.
We could say false. We could throw error.
Yeah,
we could do whatever. -1 just means that's what they wanted to do.
Okay.
Like, if it's found within this while loop, like during this while loop is when we're actually searching. But once this while loop ends, we're done searching.
Yeah.
So we just return like some default value, like an error or like -1. That makes sense?
Yeah. It's just part of the question.
Yeah. Let's do this. Let's do the variation that's a bit harder called smallest largest element. Right? What does smallest?
Want me to code it up so I can learn?
You want to code up the binary search?
No. I could code up to find the smallest letter greater than target. Is that hard?
It's a bit harder. 744.
But you could. I just want to write the code up so I could get some.
Is it a medium? Why is it easy still?
Why is it hard?
Let's see.
Is this mine? Yeah.
Return the smallest. Okay. Yeah. Also, have I solved this? I haven't solved this. Find the smallest letter greater than target. So, how are we gonna do that? Pretend.
Wait. Is this a letter? Find the smallest letter.
Rename the negative. If it's easy, just rename the negative one. Yeah. Okay. So what we're gonna do is we're gonna look for the. Using my eye.
That's good now.
Yeah.
Damn, Macs are so nice looking. How much was that?
Tweaking out.
What? Now you're good.
My background.
Your hat.
It's good. Take damage. Oh wait, let me. I know what's tweaking.
This guy's
Blanket. I need the background working perfectly. I need to buy a green screen.
It's good now.
Okay. So we're gonna do a quick variation called smallest largest. So let's say smallest largest. So what if we want to find the smallest, largest, smallest, larger? So pretend the target is 10, right? We just want to find the smallest element that's larger than 10. What would that be here? What's the smallest element larger than 10? John, what are you thinking? What's the smallest, larger, greater than 10?
Smallest larger element than 10, 14.
Yeah, exactly. What about if we're looking for 18 here?
27.
Yeah. So we have to
Let
modify.
me code this up.
Okay.
Let me code this up.
We have to modify our binary search just a little bit,
Setting up the hat.
just because it's tweaking it out.
That's so jokes.
So we need to modify our binary search just a little bit. Let's see.
The craziest thing is people here never played RuneScape ever, eh?
Really?
I guess
Yeah, they're
not.
young.
Yeah,
They're
they're
younger.
kind of young.
Let me switch this. Does it work? Nice. Dude, this thing is tweaking out in the background. Okay. So how do we do smallest larger element? So how do we do smallest larger element? What we're going to do is smallest larger. We're gonna get the smallest larger element. So we're gonna do a modified. We're basically gonna do a modified binary search. We're gonna be calculating the middle as well, but actually picking the middle here is important. The right middle is important for this binary search, and also I like to do it when the left is less than the right always, right? And then I'll just capture the last case, capture the last element. This is just how I like to do it, and I'll explain why. So pretend the target is equal to 10. We'll do print binary search, and then we'll pass in the array, and we'll look for 10. That's our target, right? This should return 14, essentially. What does this question say? Does it say return the first character in letters? Interesting. Okay.
But it's already what's it called? Why would this be a binary search question? Why wouldn't you just do like a for loop? No, I see.
Well,
why.
because they want us to do it faster than log n.
Oh, that's a.
Yeah.
I see.
Okay.
Yeah, why would you want to do the slowest?
Yeah. You can do a binary search because it's going to be faster.
Yeah.
But essentially what I'm going to do is I'm going to pick a middle, and let's just shrink this array. Let's just make this array kind of smaller. Let's do 1, 10, 14, and 18. Right? So I basically want to capture the first element that's greater than 10. So maybe the bigger example might work better here. But let's start with a left and right pointer. That left and right pointer captures the search space, right?
Search space?
Like left and right defines the boundaries of our search space.
Makes sense.
Then we capture the middle. 0, 1, 2, 3, 4, 5, 6. So this is 0, 0, 1, 2, 3. This is 3. This is 6. So essentially what we're going to try to do is find the element that's less than or equal to left divided by right. Or we're going to take right minus left to get the length of the array, and we're going to capture the middle. Is this element greater than 10? Or our target here? Our target is 10, so we want to look for the first element that's greater than 10. Right? So this element is actually equal to 10. So I know all of these answers right here to the left won't be my answer because they're all less than 10.
Mm-hmm.
But I also know 10. It's not I know 10 is not going to be my answer either because I'm looking for the first element that's greater than 10.
Mm-hmm.
Right? So I can move my left pointer all the way over here.
So you would find the index of 10 and then you would take that index and add a +1 when you return.
Well, we already captured the middle here, right? So where are we? let's just define it. Let's just do this here. We start with left, right, equals 0, and then the length of letters. So we're defining the bounds of our search space. And we'll say while left is less than right. We're going to capture the middle. So we're finding the middle index because that's where we're going to be doing our comparisons, and that's how we're going to reduce the search space. So we look at middle is equal to left plus, we'll take right minus left. That captures the length of the array.
Yeah.
Length of the search space divided by 2.
Yeah.
So if we add that to a left pointer, that gets us our mid. So if the letters at mid are, if the letter at mid is less than or equal to the target, what I'm going to do is I'm going to do left equals mid plus 1. Because I don't want to look at those, I don't want to look at those in the search space. Right? So left goes here. Now I need to capture, now I need to get the next middle. So there's going to be an else statement here, I'm pretty sure. So I get the next middle. Is 18 greater than or equal to, or is greater than 10? Yes, it's greater than 10. Where do I want to move the right? I want to move the right only up to this and not mid minus 1. The reason I want to only move it here is because 18 is a possible candidate for the result. So I don't want to remove that from my search space. So all I'll do is do right equals mid. Right? Do I use plus 1 to shift the array? Yeah, I use plus 1 to shift my pointer. So since I calculated the middle, essentially doing mid plus 1 takes our left pointer and moves up here. Right? So now I have my left and right pointers here. Now I'll capture the middle. Now I'll capture the middle again. Right equals mid. Then we'll just like if. We'll do capture last result. Yeah. We use the left, we use these pointers in order to shift our search space. So left and right defines where our search space is. So when I do left equals mid plus 1, that means I no longer want to look at the middle element and all the elements to the left of the middle element. Okay, now we're left with these two elements.
Yeah, because you're not, you want something greater than the target.
Yeah, so we don't even need to look at this target anymore. So that's why I did left equals mid plus 1 when the mid used to be there in that iteration.
I see.
Okay, now what's 5 over 4? 5 minus 4 is equal 1 divided by 2 equals 0. So the middle is actually this. Like we're an even number and the middle is this. So we're between 14 and 18, right? So since 14 is greater than 10, I know that I don't need to look at anyone to my right because I'm already greater than 10. So anybody to my right is going to be greater than me. So I'm like going to be closer to our target. So I could just move right here, but I don't want to exclude myself. And that's kind of how it ends here because now left is equal to right. So now we just need to look at the last thing. Return. Basically, if letters at the middle is greater than the target, we return letters at mid. Otherwise, we return letters. They just want us to return the first character in letters. I don't know. Does this work? CG. Okay, what broke here? Oh wait. Mid. So we always want to take the C, target C. Okay, now let's like debug like this specific example. Does lexica greater than C in letters? Is this sorted already? Okay, let's just walk through an example here and see why it didn't work for that case. So what did we return here? Target equals C. But let me look over my algorithm. While left is equal to right. If the mid is less than equal to target, we take our left and we move it up. Otherwise, we move right to where the mid is. And we take the smaller right. Or we take the smaller mid when we have an even. That makes sense. Yeah. And then if the letters mid is less greater than or equal. Wait. You see in letters is F. What did we return here? Output C. Why do we return C? If the letters mid is less than. Okay, we're gonna debug this right now, and our thing is returning F here, but we're gonna see why that's happening. So this is an actual example. Target C. So we come up with our left and right pointers. John, you're gonna get so good at arrays. So how do we calculate mid, right? We do mid equals 0 plus 2 minus 0 divided by 2. What is that?
1.
2 minus 0 divided by 2 equals 1. Is it?
Yeah, 2 divided by 2 is 1.
Oh wait, 0, 1, 2. Oh, so are we taking the wrong? 2. Right minus left. 2 minus 0 divided by 2 equals 1. Left. Okay. Let me see. That might be why my algorithm didn't work. We might have to do... So, because for here... Oh yeah, that makes sense. Right. So that equals 1. So that's our middle. Right? So what's our middle here? It's 1. Is F less than equal to C? Because we're looking for the first one that's greater. Or, yeah. Smallest letter greater than target. So is F greater than 3? Or is F greater than C? Yeah, A, B, C. Yeah, it's greater than C. So we just want to move our left and right pointer here. Right? So if the letters at the mid is less than the target. Okay, but F is actually greater than the target. So we move our right equal to mid. That works, right? Now in the next iteration, we do 1 minus 0. Because now our right is here and we're doing right minus left. 1 minus 0 divided by 2 equals 0. 0 plus 0. This is actually our mid, right? And then now we're saying if the letter at mid is less than and equal to the target, oh, sorry. This is why I messed it up. Should be at left here. Okay. Where does it end here? Print. Oh, sorry. I messed this up. Small little bug. Let's go. Yeah, that's how you solve it. I was doing mid here, but mid didn't exist. We should have used left. Like, the algorithm was correct.
What?
So we kind of need to use... Now we have, like, the next greatest element, right? Now we just need to use that in this function right here. So, because we're doing all this extra stuff. So now everyone kind of gets how to do binary search, right? Hopefully I explained it well. The two things you need to watch out for is watch out for which middle to pick when the array is even. And then also yeah, like how to shrinking your search space. And it's pretty much shrinking your search space is just like moving the left and right elements or moving the left and right boundaries.
Yeah.
And you're not going to get this all in one day. At least you saw how it's implemented though. Yeah, and then you kind of get, it's like we're eliminating the search space and shrinking it.
Yeah.
Cool. Let's just keep this code with us later. Now let's finally solve this question. We're giving it 2.
Yo, is Nell still in here? We're gonna solve this for him, lol. LOL.
Null, are you still in here? So my algorithm is gonna be like a... My algorithm, I'm thinking here is gonna be an n log n algorithm. Because for each element, we filter out all the other elements, and then we could figure out the maximum elements after.
This one's hard.
Niall, what's up?
168 people are trying to run the same one.
I feel like Null was here since the start. So, my final algorithm is an n log n solution. And then we'll see how it compares to other people's. Let's see. So, what we're going to do is, I said we're going to sort the events by start time, which will allow us to do binary search. We'll do events equals sorted events. And we're going to take the key equals lambda x. So that's going to allow us sorted iterable key.
You have to do events dot sorted.
Wait, event. Oh, sorry, events. Okay. That allows us to sort events by the start time. Right. That allows us to sort events by the start time. So if we print events here, it should take this. Let's just work with this for case 1. It should sort this. This should be first. This
Is
should
the
be
size
second.
good, by the way? Should we zoom in or not?
It's pretty zoomed.
Oh, it's zoomed already?
Yeah.
Oh,
I already looked at that before.
Okay.
See, now it's sorting it. See, it's sorting it by the first element.
yeah.
So that's how you modify what the sort is. The sort key is. If I want to sort it by the second element, I do that. If I want to do it by the third element.
What
I
is
do
the
that.
key equals lambda x?
That just means like you define like a function for figuring out what what we should sort on. So pretend we want to sort on like basically we're that means we're gonna sort by like pretend we're looping through events, but events was like a class or something like that, and we want to sort by their name. Then I write a function to extract the name using this lambda function. So basically this is the pseudocode for my n log n solution. So sort the elements by start time allows us to do binary search.
Hit tab on that. Oh no, never mind. It's fine. Just tweak.
Okay, wait, let me do this. And then what I said, I'm gonna develop a prefix sum, which is like I'm gonna go for I in range. I'll start at the length of events -1, and I'll go backwards on that array. I'll just say this is, we're gonna create a prefix sum, which is gonna be for I in the length of events. I'm just going to initialize an empty array like that. Local variable prefix. So I'll be like for I in range length of the events. I'm just because I'm basically gonna initialize this prefix sum array, which is gonna tell us like, given that if we are only given this element left, what is the max value we can get to, right? If we're given only these 2 elements left, what is the biggest value we can get? 3, right? If we're only given this element left, what's the max value we can get? Which is, it's gonna be 3, right? If we're given the option to choose any element from here and onwards, that's how we would do it. So basically, I want to calculate the prefix sum, doing that. I guess it's not really, sorry, that's not a prefix sum. It's more just like pre-calculating what the most optimal would be if I only had one choice. So the most optimal would be if I only had one choice and I was at this very last element would be, let's see. So if all I had was this last element, my optimal, so I'm going to fill out the prefix sum. I'm going to be like for I in range, length of events minus 1 minus, and then I'm going to go backwards through my events, and I'm going to say what I'm going to do here. If the prefix sum, if I is equal to the length of events, if I is equal to length of events minus 1, that's the one case. What I'm going to do is I'm going to say prefix sum at I is just equal to events at I second value, right? Otherwise, what I'm going to do is else I'm going to say prefix sum is equal to the max at I is the max of like my current index, and prefix sum I plus 1. So now let's print out the prefix sum. So see what it's doing there? It's calculating that correctly. So now what I'm going to do is I'm going to, for every single filter, for first pick an element and then filter out all of the events that are overlapping ov and log n. Yeah. So what I'm going to do is now I'm just going to do a simple for loop. Result.
Dang, are you cooked off this?
Nah, I could do this for hours, brother. Let's see. Holy. Let's see. Return result.
But yeah,
What am I
this
gonna
is a
do?
normal day in the life, eh? Like 4 hours. That's like a.
Yo,
this-
we covered a lot of ground. I think you started to understand object oriented a bit more.
Yeah,
but
yeah,
well,
yeah.
I need to figure out a better way to teach that. For I in range,
It's all good.
length of events, right?
Yeah.
We're gonna pick a candidate equals events. I can start, can end. We're gonna take a value. So if for every element, what we're gonna do is we're gonna grab, and we could do enumerate here. Yo, the
Let me
moment
look
you heard that-
again. Let me enumerate.
Enumerate. So we're enumerating through the events. So that gives us an index. A candidate event, right? So we take the candidate event and we extract out the start date, or the start, the end, and the value, right? And then we do, basically what we want to do is like binary search for next avail index is equal to, we're gonna copy and paste this like binary search smallest larger, smallest larger, and for smallest larger we're gonna be given a let me remove this. For smallest larger, we're gonna be given a number, or we're gonna be given a copy paste this over. So for smallest larger, we're gonna have an array of events. We're gonna have a target, and we're gonna have a left and right. So we don't have to initialize that right here. So we're gonna have a left and right. What are we gonna do? Events, target, left and right. So while the left is less than right, we're gonna be looking, and then we're gonna return the middle. So we're gonna be returning the index here. This regular binary search? Okay, yeah, because we want to return the index. Oh shoot, I don't want. I want my other binary search. The one that we just built. I want this guy. Smallest, larger. Sorry, let me delete this.
Hit this quick though.
Where?
Yeah.
Okay, let's do next greatest letter or smallest, larger. We're gonna take events. Getting hungry.
Should I order something?
Ah, good. We take events, the target, and the left and right. We do a left and right here, and here we're eventually gonna return if the left is greater than equal target. We return the left. Otherwise, here we return -1. Right. So while the target, yeah, that allows us to get the smallest, largest. And what we're gonna do is we're gonna do this. Self dot smallest largest, and we're gonna be passing our events. We're gonna pass our target is gonna be candidate end, right? And our left and right values, the left value is gonna be index +1, and then here is gonna be the length of events -1. So that's the next available. If next available equals -1, we do one thing. Else, if the next available, there's actually a next available, what we're going to do is we're going to say result equals the max of what the current result is, or the value of the element we chose plus prefix sum of next available index. Something like that. Otherwise here we just do result equals. And if we wrote all the other functions right, should get something. Name letters is not find. What is this? It's not just. Oh.
Oh, isn't that? Can't you just delete that code?
Which code?
That letters code. What is that even? You copy and pasted that from like the wrong binary search.
Events target. What is this? Oh, okay. Let's look. Smallest, largest. We pass in our events. Events is here. What's it complaining about? List events at mid. Oh, events mid. And I'm looking at start times. I'm doing that. Start times. Please work. Events. If. Okay, if. Left. If left is. Or let's do. If left is less than 0, if left, but it should stay within bounds. If the left is less than the length of events, and let's get it. I don't know if that's the most optimal algorithm.
What the heck even happened there?
Bro, I just ran that
Holy
thing.
copy and pasted code.
Yo. So that's my nlogn operation.
Caesar back in the cut.
Woo! So hungry right now.
Definitely Christmas.
Dude, we're going to do a crazy long stream when you're here. We're going to do the whole blind 75 list. I'm going to have all my friends tap in and do questions. But we can get to do the whole blind 75 list in one go. Promise.
Yeah, while tipsy. While tipsy, while a little bit intoxicated.
Alright, we just solved this one question.
What the heck
Caesar,
kind of tangent was that?
We literally covered binary search, multiple variations of binary search. We covered like using a prefix sum and then we calculated like we're able to do this. Yeah, we'll do a blind 75 marathon. My algorithm is n log n because we sort the events. That's n log n, and then this is
How
in
did
a
this
while.
question even come up though?
Null gave it to me.
Yeah, like what
In a for loop.
where did this come from? This is so random. How do we just randomly solve like 3 lead code questions?
Yeah.
That's so random.
See if it actually got my stats up. Yeah, we just ended up solving 3 lead codes questions. Nice.
Yeah, show them your stats on lead
Let me
code.
remove this. Sorry. Nice. We just solved a few questions and we're on a road to get to 1,000 lead code questions and we're like halfway there.
Yo, what happened there?
Okay, that's an n log n operation. Yo, no, did you learn anything from there? Let's
Yeah,
look at the answer.
what was the process? You literally
Dude.
solved like 3 questions though.
Well, my process was breaking it down. First, I came up with the brute force. Then I came up with like ways to speed it up, and I realized my best operation is n log. Like, my best code is n log n. And let's see. The heck is this? Yeah, this was kind of mine. Using an n log. So this was my solution. Is this very first one. So it looks like, did I get the most optimal? Let's see. Yeah. So I broke it down to a bunch of different things.
How long do you get to the point where you just could write code like that? Like you don't even think about what you're writing. You're kind of just thinking about the logic.
Bro, I don't even know. I wasn't even paying attention. So, but look, they got an n log n. It looks like they have, in the previous approach, they have multiple ways to do it. But I think n log n is the fastest. Greedy. How fast is this? Log n. So there's no faster way than n log n. Yo, everyone's saying this should have been hard. We just saw that live. That's crazy. Shoot, like who cares? What? Look, everyone's complaining about this question. We compute the max value. So yeah, this is what I did. For each event, we used, you check. Yeah, this guy had the same solution as me. Yeah, I think a lot of people had the same solution as me actually. So instead of a suffix max, I would yeah, all solutions are n log n. Honestly, I don't even like looking at these people's solutions sometimes. As long as mine matches, I'll be like, I'm fine. I don't need to. Like, what is even going on here? I need to study more solutions.
You don't read the solution?
Not really. If I can figure out the question, I usually don't read the solution. Unless it comes up with a faster thing than mine. Yeah, but I think mine is like other people are proposing mine as well. Create a sorted list. And it's still n log n. Yeah. How long does it take to get that much good at LeetCode? 532 questions worth. I think you're
500.
Dude,
oh man.
imagine it takes
Is
me
that
like
me?
an hour to do each of these questions. 532. It probably takes 2 hours on max. Or no, 1 hour. It depends how good on it. Divided by 24. 22 days of playing time.
That's light work.
I put up more numbers on
On
COD.
COD.
Yeah.
Fortnite.
Okay, let's see what everyone's saying. You got more questions?
We can go back to the what's it called? We can go back to the
Let's implement trees. Let's talk about trees.
what's it called?
How long have we been live for? 4 hours? Beautiful, beautiful. I think we've been around 10 concurrent views the whole time, which is great. People are watching us.
Yeah, let's
Like, what other concepts do you all want to see and care about? I can break those down
Oh
too.
man, we were on the oop though.
Oh, you want to learn trees. Trees. Okay. Let's get into trees. John, dude, we touched OOP for like 3 hours of the stream. No, we did 2 hours talking about OOP. Then you went on a 1 hour tangent talking about human capital. Okay.
Definitely getting exposed to the code and
Did you learn anything from me doing that?
yeah.
Yo, SB.
I just don't know if I could replicate it myself.
SB, did you learn anything from that approach or no? Like, did it make sense what I did there?
Oh man. I'm cooked after. I know how to initialize I know what a constructor is. I know what a method is at the bare minimum.
That's good. That's all you need to know.
Let's see. Let's revisit that OOP code for like 5 seconds,
SB,
and
nice.
then let's hit the trees. Let's go
Okay,
back.
he wants to look at the.
Yeah, I just want to look
No,
at.
I can explain OOP again. Like let's get into the node data structure and I'll explain it.
Yeah, could you make like a tree using nodes?
Yeah, exactly.
Hell yeah. Okay, yeah, run that.
Okay. Let's just do. Okay, is there any food? Don't order it. If there's something downstairs, like that.
No. I don't know if there's something downstairs. I'll
Hey,
check.
everyone, we're getting into trees. We're getting straight into trees.
Yeah. Let me code a little bit. I need to write up some code. Yo, James.
We're gonna hop into trees. My brother's looking for food, but we're gonna explain trees all the way in depth until you get sick of trees. Let me just set up my Excali draw.
Nah, bro, there's no food. Tragic. Holy, this area smells like coffee. Yo, let me code, man. This guy, man. I used to be able to beat this kid up and take the controller, but he's bigger than me now. Isn't that messed up?
So we're gonna think about the node data structure, and let's get into trees. Let's get it straight into trees. So
Yeah, this guy pays for Excalidraw. Yo, this guy pays for Excalidraw but doesn't want me to pay for PyCharm Pro.
bro, why do you need PyCharm Pro?
Oh man.
So let's just get into the theory of trees, right? So trees is a data structure.
Bro, acting like he's been hogging the controller. He
No,
is hogging.
I'm gonna get him to actually implement some of this stuff too. So let's just get straight into trees. Everyone joining, we just did a lot of leak code and random stuff, but we're gonna get into the trees, the theory, and we're gonna implement a simple tree, and we're gonna ask some very basic questions against the tree, right? The tree that we're gonna implement, it will be a organization structure. Let's get it. So trees, what are trees? So trees is the first data structure that we're going to talk about that is a non-linear data structure. When I talk about linear versus non-linear, a linear data structure is like an array, 0, 1, where you can kind of read data linearly, right? From left to right. Even a linked list is a linear data structure.
Oh, bro, I kind of get why you have to make this a class.
Why?
So you would make the class, and then the attributes would be like a connection to the nodes.
Yeah, exactly.
Oh, now I see why there's an attribute to it.
Okay.
But why would you have a method to decouple the nodes?
To just make it to just define what a node is essentially. So okay, these two in here.
Dang. I kind of got that. Like, when I thought about it, I was like, yeah, you actually need to... I was, like, trying to figure out why you need OOP for this.
Yeah, you're getting smart. So these are linear data structures. Dude, we'll be streaming so hard just Christmas break, and this guy's gonna be so smart by the...
Yeah, we'll do it in Vegas. We'll do it in
2025.
Vegas. Should we do some coding at the casino?
Yeah, I'm down. So these are linear data structures. Why they're linear is because you can search them from left to right. Like you just saw, we're searching from left to right, and there's like a clear successor and predecessor for each element.
Yeah.
So you can linearly search them. That's essentially why they're called linear data structures. Non-linear data structures is something like this. Is a tree. A tree is a non-linear data structure because let's see. A tree is a non-linear data structure
Damn,
because
this Excalidraw is sick though.
yeah, it is.
I think Excalidraw is free, but it would only live on your local machine. Like, it wouldn't be on cloud.
So look, this is a non-linear data structure because every node, like you can't. How do you search this? You can't really search it linearly. You're searching it like okay, like there's not a clear way to search it. The way you search non-linear data structures like a tree or a graph is using depth first search or breadth first search, which we'll get into recently more.
I seen
But it's
you
not the
do
same,
that.
yeah.
And the other day you did like a diagonal search.
Yeah, to an array. Yeah,
You can do.
I
more
do.
scenes if you pay.
I pay.
How much?
It's
Yo,
like-
this guy spent $130 in one night on GPT API calls. Could you
Yeah, that's
believe
crazy.
that?
I do a lot of AI stuff. Me and my brother both do a lot of AI stuff, and
This guy.
I think probably in a few years we'll start our AI company, bro. Like no matter what, we just gotta start something. All the subscribers could come join, can come be founding engineers. So what we're gonna do here is we do a tree is a data structure composed of nodes, similar to a linked list. It's a non-linear data structure. Arrays, linked lists, stacks, and queues are linear data structures. So what are the properties of a tree? So each tree is composed of nodes, right? It's composed of nodes. So pretend the CEO is one specific node. Oh wait, let me bring that back here so I don't lose it. So each tree is composed of nodes. I didn't write that here. Let's do... Each tree or trees are composed of nodes. Right? So trees are composed of nodes. Nodes are, you basically define nodes as a data structure like this. It's a data structure with two attributes. It has the value. Usually you pass in the value here. It has the value, and it has
So that would be like CTO, CEO.
yeah, exactly, and it has children, which could be in a list. So this is a very simple node data structure, and this is the blueprint for what a node is. So every element here follows that blueprint.
Yeah.
But when we instantiate an object using that blueprint, it becomes like an actual node with actual children. So this is an actual node of CEO with pointers to other nodes like CFA and CTO. Does that make sense so far?
Mm-hmm.
So this is a very simple node class, and we pass in a value because that's going to be like the title, and then the children will be whoever reports to them. So the CFA reports to CEO, and the CTO also reports to CEO.
Yeah, something like that.
Where the CFA will report to CFO, but we cut out the middleman. So
Node with no children is
so these are the different things we care about a tree. A root in a tree, there's a concept of a root node. So this is the very top of the tree. When it comes to trees, there's always going to be at most one root node, right? And here, the one root node, yeah, it's the topmost node. It's one with no parents. You can see all the other nodes have parents. Who's the parent of staff eng?
CTO.
Yeah. So you can see all of the nodes except for the root has a parent.
Yeah.
CO has no parent. There needs to be somebody at the very top of the chain. You could think of it like a food chain or something, whatever. So each node has 0 or more children, right? And you apply that recursively for every node. So this node has 0 or more children. This node has 0 or more children. This node has 0 or more children. This node actually has 0 children. This node has 1 children. This node has 2 children, right? So kind of each node has 0 or more children. That's kind of why we define the definition like this. So each node has 0. Everyone get that part where each node has 0 or more children? Does that make sense to you, John?
Yeah.
Let me move this over. So we're looking at this node class. So now we know root and we know what nodes are.
Dang.
So lastly, or not lastly, there's more to this. But a node with no children is a leaf node. That's just more terminology. So these are the leaves of the tree. This has no children, so this is kind of leaf. Like that's kind of what a leaf is in real life, like something that just ends.
Right.
So these are we have.
So
three
the
leaf
root,
nodes.
it starts. It's kind of like upside down.
Yeah, it's like an upside down tree, essentially. We look at it from the top down,
Yeah, yeah.
but it's more like a Christmas tree than a real tree. But the root comes from the top. Yeah, intern is a leaf. Somebody like it pretty much ends there,
Yeah.
right? So
Like, what would you call them interim though? Like, for example, the staff eng. What would you call that guy? Like
those are just nodes. They're just
Okay.
regular nodes. There's nothing really. Yeah, analysts as well. Yeah,
Yeah.
these are just nodes. We don't really assign them any like specific extra terminology. So what else?
So root is no parents. Leaf is no kids.
Yeah, exactly. Yeah,
Alright, that's
like a
basically
leaf.
it.
Think about a leaf in real life. It just ends there.
Yeah, yeah.
It's just the end. But the root, like a lot of things come from the root.
Yeah.
So, a node with no, yeah, we covered that. So except for the root, every node has a unique parent. That's just a property here.
Yeah. yeah.
Yeah. So basically every node has a unique parent. If we do this, this is no longer a valid tree when it comes to trees in programming. Right? Every node must have a unique parent. And there's a leak code question like this.
Yeah, that's
validate.
more like a lattice model.
There's this question. I actually got asked this once. It's pretty good. So it tells you to validate if something is a binary tree. So this would return false. This isn't a binary tree because this one has 2 parents. So this isn't a binary tree. So next, it has at most 1 root node. That means like if there's a node living out here by itself, let's say CPO. If there's a node living here by itself, like this thing is no longer a valid tree. It's 2 trees, but it's not 1 tree, right? Like a tree should be fully connected and have at most 1 root node. These are just terminologies, right? And the reason we need to structure a tree in this way is because that's just like how we want to structure the tree in order to like have a valid binary tree and in order to like do operations that we want. So like graph theory is a whole different thing on its own, and you'll get to learn about that from a different time.
Yeah.
But a tree is
Yeah,
like
I need to learn those graphs because I want to eventually use land graph. You know, there's like land chain and land graph.
Yeah.
Yeah, we got to get on that ASAP.
So essentially, okay, a tree is a type of graph. So a graph is like the more general terms. You can create like tree is a subset, like graph is like a subset of like all the things that are nodes with edges, but tree is a very specific type of graph that meets all of the constraints that we talked about here, such as like having one node, like having one parent and stuff like that. And another thing is a tree cannot contain cycles. So pretend the intern also pointed to CEO. That's no longer a valid tree. Because pretend we are trying to make a decision here. CTO want to make a decision, so he talks to CEO. CEO talks to intern, talks to staff, and like you create a loop here, and no one can get a decision done. So trees kind of need to like you can't have cycles in a tree, otherwise like your algorithms are gonna break.
Yeah.
Yeah, that's it. Everyone get the theory of trees so far, which is pretty much, yeah.
Well,
Does that make sense?
Give me like 2 minutes, 3 minutes.
Yeah. I'll talk. I'll ask the channel quick what they're thinking. Channel, chat. What are we thinking? Like, does that everything make sense here? Cool. If you want to really test your knowledge on trees, do this question. So if you want to actually test your knowledge on tree theory, try out that question, and it's a really good question, honestly. Let's just keep going, and then my brother will catch up. But a tree can have 0 or more children, right? We said each tree can have 0 or more children. The moment we put a constraint on how much children it has, it becomes like if we put a constraint that it can only have 2 children, it becomes a binary tree, right? So a tree can have 0 or more children. When you put a constraint, then it if you put a constraint of 2 children, then it becomes a binary tree, right? So if we say the constraint is each element can only have 0, 1, or 2 children, it becomes a binary tree because each element can at most branch off twice, right? That's why we call it a binary tree. If we put the constraint that it can have 0 to 3 children, 0 to 3 children, then it becomes like a ternary tree, right? That it becomes a ternary tree because you can have like 0 to 3 children, right? That's what a ternary tree is. If you make the constraint that you can have 0 to n children, then it just basically becomes an n-ary tree or just a regular tree. Put here dot 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 n. So that's what binary trees are. I mean that's what binary trees, ternary trees, and n-ary trees are. Other things that we have to care about are pretty much like the height of a tree. So we have to care about the height of the tree because keeping the height of a tree small helps with runtime complexities when you're working with things like binary search trees. So pretty much the height of a tree is, pretend we have a tree like this. Yeah, binary tree has at most 2 children. So it has 0, 1, or 2 children. And I'll just explain that concept again to my brother.
What?
So basically what I was saying is we defined the general concept of a tree here, right? But you probably heard the concept of like a binary tree all the time, right?
Yeah.
Like, do you know what that means?
Yeah, it only has 2 leaves.
2 leaves?
Or like 2 nodes. Or 2 kids, yeah, 2 children. 2 children each. Each root has 2 children max.
Yeah, okay. That's what I was saying here. So a regular tree can have 0 or more children, and then when you put a constraint on it, say we want to constrain it to 0, like 0 to 2 children, then it becomes a binary tree. That means like if every element can only have between 0 and 2 children, 0, 1, or 2 children, then it
Yeah.
becomes a binary tree. Because it just like limits the amount of like branches that we can create
Yeah.
from a specific one. But some of them could have 0, some of them could have 1, and some of
Yeah.
them can branch off 2.
Bro, do you know what XGBoost is and like all those algorithms?
Yeah, I've seen that.
Yeah. We'll get
Is
on
it-
that
yeah.
one time. But
So,
yeah, I've seen this before. It's kind of like a random forest.
yeah. So pretend we put a constraint of 3 children, then it becomes a ternary tree. If we put the constraint of 0 to 3 children, it becomes a ternary tree. Because what if I spin up here, right? That becomes a ternary tree. And then if you make the constraint of n, it just becomes a general n-ary tree. Okay, what do we have here? Height of a tree and depth of the tree. I would get into that, but it gets a bit more. Height of the tree and depth of the tree pretty much impacts the time complexity when you're doing traversals and searches. Merry Christmas, Buffer. What's up? I think I've seen you around before. We're yeah, we're literally getting into trees right now. Let's see. Sorry, I'm just gonna quickly check this. See, the subs went up.
Let me take a look at this. Holy, are you guys
Perfect.
learning a lot? Are you guys learning a lot? I feel like I'm actually starting. Why is this? What? Why is it scrolling the wrong way? Where am I going, bro? Where'd I go? Oh man, I deleted it.
Okay, let's get back into the theory. Scroll back to content. So we have n-ary trees. So why do we care about the height of a tree? We care about the height of a tree because essentially, if we have a binary search tree, the height of the tree pretty much defines like it directly impacts our time complexity. Because if you have a tree that's just a linked list like this, then to find a leaf node, you have to like pretty much search all the way down. It becomes a linked list, right? So you'll see a lot of different algorithms like AVL trees and things like that do self-balancing that will balance a tree into like one where the height is minimal. So it'll be like this. So if we want to search for a leaf, we don't have to like search all the way everything.
I see.
And that's essentially why we need why we care about the height of a tree. Depth of the tree kind of just lets you know like how deep you are in the tree. So pretend like this has a depth of 0, this has a depth of 1, this has a depth of 2, this has a depth of 3. So if you want to know, like some algorithms will be like, find me all of the people that are like at depth 3. So you could do like a level order traversal and find all the ones at depth 3. Yeah, exactly. AVL trees is like a self-balancing tree. And what it essentially does is it stops you from like regressing your tree into a... Literally, my brother's just learning is like learning algorithms and stuff. So I'm just teaching him so
I'm
he can get
learning
ramped up.
algorithms to just for fun.
Yeah,
It's kind of ridiculous.
And
I don't know.
also-
Yeah.
I'm studying algorithms so I can teach people on this channel all about algorithms because I'm trying to grow my channel. I'm trying to focus on things like algorithms and AI. So, yeah. Hope that answers your question. So let's just like implement this binary. Let's like implement this very basic. Let's implement this very basic tree here, and then like ask questions on it. So we're gonna implement a basic tree because now we already went through the theory of a tree. Let's. Thanks, man. Appreciate you. I'll always remember you for sure too. let's see, where are we at right now? Okay, what we're gonna do is we're gonna implement a very simple tree. We're gonna take a picture of this.
Damn, you could do that on Mac? That slaps.
So we're gonna implement a very simple tree. We'll call this like a company tree .py, right?
I'm getting sold on this VS Code, man. You just have to set up VS Code properly? What does that even mean?
So let's say we want to implement this very basic tree. So what we're gonna follow some object oriented principles, and then my brother's gonna learn all this stuff. But what we're gonna do is we're gonna implement a basic tree. Implement a tree for implement a company directory structure. Company directory structure. And then what we're gonna do is we're gonna ask questions on the tree. We're gonna be like, then we're gonna be asked questions on the tree. Now, once we get it in the data structure, we want to ask simple questions like, who are the direct reports of a person? Then we can be like, who
is that person?
who's under a specific, like recursively, like CEO, who's under it? Who's under that person? Everybody.
Right.
Who's under the CTO? I forget how do we say it? Who are
direct reports?
who
Subordinates?
yeah, who is under me? Wait,
Subordinates.
let me see.
Isn't
No,
that what it's
I
called?
wrote this. I've done this thing before. Let's see. Yeah, essentially binary search. We're gonna write two things. Like we're gonna write one function called who is under me, and that's for CEO. Everybody is under them, and then we'll also like who is my direct reports. Who is under. Who is a direct report of person, right? So we're gonna define this tree, and usually a lot of times. So let's just start making variables for all these different people that we're gonna care about. CEO, CFA.
It's called CFO. Oh my god.
No, I
Yeah,
put
it's
CFA
fine.
on purpose. Oh, you're blocking a little bit. Let me move it over.
Was my head on there?
I want to shrink this. Whatever. We'll just like switch back and forth. We'll switch back and forth with this. So we have our CEO, our CFA.
Could you can't make this screenshot smaller?
Let's see. Sure, we can make it like time.
Oh, you can't actually, eh?
Yeah, we can't.
So zoom out of your Excalibur. Zoom out a bit. Like hit the minus.
It's fine. It's fine. I'll just switch back and forth. So, okay, we have this tree right here, and this tree it has different characters or different people in it. CEO, CFA, analyst, CTO, and all I'm gonna do is create variables for these people.
Do you know about the sorted list in Python?
Yeah. So let's say these are different people: CFO, CFA, analyst. We have CTO. We have like Eng manager. We have staff, Eng. We have intern. So we have our CEO, our CFA, our analyst. We have our CTO, our Eng manager, our staff Eng, and our intern. Cool. So we're just defining variables for these people. And usually in most questions, you're gonna have to build the tree, and usually you're gonna give the edges. you're gonna be given the edges, or you're gonna be given like who works for who in a linear data structure, like an array. So we're gonna say, let's just say, because we're working with this right here, we're gonna say that like, let me shrink this a bit.
You could do it. No, that's good.
Dude, send me that leak code problem. I'll solve it right now.
The subordinates.
So pretend usually when we're given a tree, when in most questions when we're given like all of the edges, and edges means like who reports to who, kind of like these are the edges, these are the nodes, and these are the edges, right? You're tweaking on that. The ADD's hitting.
What?
You kept looking at my phone.
No, I'm just checking if it's good. Let me check mine. Okay. Yeah, I need to type a little bit. I gotta.
Okay, type.
No. When you start making the classes, I'll do that.
No, type the edges in.
What?
Type the edges in quick, and I'll
What do you mean
voiceover.
type the edges?
So type in CEO. I'll type in the first
Yeah,
one.
type in the edges.
So edges are what are these connections, and usually how you type it in is I'll be like CEO manages the CFA, right? And now type in the other ones. Be like CEO also manages the CTO.
What?
Do CEO?
Oh, okay. Like. Oh, I see.
So CEO manages the CTO. Okay. Now CFA manages the analyst. So my brother is finally getting his fix.
Oh, you made them all caps, eh? This guy's my dealer, man.
CTO
CTO
manages the
eng manager. Oh, there's tab autocomplete on this. CTO.
Manages staff eng. And then like
Staff eng manages the intern. Oh.
right. Okay, now we have our company structure. Like technically we can store our whole company structure in like a list like this. But then how do we ask questions like who works under who? We can search, right, and figure it out.
Yeah.
But then we could be like who is a direct, who is like who's the direct,
Oh,
who are
let me. I know how you would do it with a for statement, eh?
what?
Like who reports to the CEO?
Yeah.
Yeah, you could
Yeah.
just use a for loop on it.
But like how about like who is under a person? Like how do you recursively find who's under the CTO?
Oh man.
That's a bit harder. You'll find like, okay, who works for the CTO? Then you'll be like,
man.
okay, these people work for the CTO.
You'd have to append you'd have to do a nested for loop.
Yeah, then you'll be like, okay, pretend we want to find all the people who are under a CTO in our directory, right? We'll look for the CTO and we'll look for who works for them directly. Then we need to look for who works for those people, who works for those direct reports directly. So be like, okay, eng manager and staff eng work for the CTO. Okay, who works for the eng manager? No one. But an intern works for the staff eng. So now all those people work for the CTO.
Yeah.
So that's kind of like what a depth first search does actually, or a breadth first search. It recursively like just
it would be
these-
like a nested for loop. Like it would be like case. You would search for this one, and then anything with the CEO, you would like append the index one element to a list. Then within that for loop, you would append that to the list.
Yeah, it's kind of like that. So like what I mentioned earlier of like what a data structure is like it's just a structure that holds data in an efficient way. This is a data structure. An array is a data structure, and we're storing this directory structure in an array. But is that the most efficient data structure to hold this and reason about it?
No.
Yeah, not really, because like even looking at this, we can't really tell the relationships. But when we look at a tree, we can easily tell the relationships.
Yeah.
So that's why trees are a better data structure. So a lot of times when you're like dealing with, you want to store data, and it's like, pretend I wanted to store like a social network. Would it make sense to just have like all who's friends with who in a big list, and then just look through that list to see who's friends with who?
No.
It would probably make more sense to
Like
like
you would want it like a
you would want like more
like-
of a graph.
yeah, like a brainstorming type of chart.
Like you want like James, Benji, Natu. Say a link means that they're friends, right? So we could be friends like that, but I might not be friends with Natu.
I see.
But then like let's put like Isaac, right? So this is actually a better way to like look at a social network than a list. Like we could define like who's friends with who, but this is more intuitive. Then I could
Yeah.
ask questions like, how many degrees of separation am I away from Isaac? Oh, I'm like, I know Isaac through these people.
Yeah.
So I'm like 3 degrees of separation away from Isaac.
I see.
So this is technically a graph.
This is how they do it on LinkedIn, eh?
Yeah, this is technically a graph because we can have cycles and stuff like that. And it could be like this. Like we could all be friends. Cool. Let's like organize by some. Yeah. So now that we have the edges, now we need to actually build out our tree. So how we're gonna do that is, like I mentioned, yeah, I could do that. Do you want me to do that question? Oh, using recursion? Why do you want to use recursion though? Like, when you reverse a linked list, you want to do it O(n) time complex or O(n) space, and using recursion uses up. Dang. Yeah, that's tough, man. Dude, like I feel bad, man. Those questions are kind of like, those questions don't really test how good you are at coding, honestly. I would never ask that in an interview myself personally. Yeah. So sometimes it just happens. Where are you based, bro? I can show how to do all those linked list questions too if you want. But let me focus up on this quickly. Just make sure everything's working. Dude, this is a
The
good
emotes are working for sure.
Huh?
I said the emotes are working for sure. I just spammed hearts and like.
Nice, nice. I'm actually based in the Bay Area as well. Hit me up. Okay. Let's generate this tree. So we're given edges in a nonlinear data structure. We know for sure that we don't want to store this in an array. Let's store this data in a graph or in a tree and then ask questions like who's under a person and who are the direct reports, right? So the first thing we're going to do is create a node called class. We're going to create a class called node. Or we'll do it at the bottom.
Okay, yeah. Let me write this now.
Okay, write a class called node with 2 attributes. The title, class called node.
Would be title, and
Or no, you don't define the constructor. Remember how to define a constructor?
define init
Exactly, that's the constructor.
self.
Why do you pass self in again?
So you can you could like point to that memory.
Yeah, like you point to yourself essentially.
Yeah. Self, and then what did you want? You want the title, right?
Yeah, title. And I want to, and I don't need to define children yet, so, but that's
You don't have to put child 1, child 2.
No, not yet. What you can do is, yeah, I just want to take in the title in the constructor. And then what I want to initialize it with is the title. I want to create an attribute for my title.
What would you even put in here? Self dot title equals.
Equals the title, because we constructed. And then I want another attribute called children, and I just want to initialize it to an empty array. Cool. Nice. That's basically it. Now, let's just define like a.
What about self.parents though? Do you do that?
No, it depends. You can. It will help you do some questions, but usually you just define children. But having more data is always better than less, but we don't need that in our case. So what are we going to do here? What we're going to do is we're going to say self.children. So now we created the node data structure, and now we're going to create a tree data structure.
Is your laptop charging? Yeah.
Which one?
Okay. No, what
So
the
we're
heck?
gonna
I was
create-
like, how's this laptop running still?
We're going to create a tree data structure, and we're going to initialize it.
Itching.
And
to
this is
spend
gonna
money.
get more complicated, so I'm gonna take a
Wait, why is the class tree?
Because we're gonna define a tree data structure that's gonna maintain all the nodes here, and then we're gonna have a node data structure for all of the nodes within the tree. So tree kind of encapsulates the whole directory, right? Or the whole directory. We could even just call this like company directory.
Do you think reversing a linked list using recursion is a very easy? Like, what is recursion?
Dude, I have a video on that. That's like, I can show you that too, but how long have we been on this?
5.
Are we still streaming? Oh, okay.
Yeah. Mac battery life crazy.
Oh, yeah. Dude, this is going to be an 8-hour shift. So basically, I create a class called the company directory, or it could just be called the tree, which is just like how we encapsulate like all of the nodes in the tree, right? It's like the overarching data structure that holds the different nodes.
Yeah.
Yeah, exactly. Exactly. You're right. So what are we going to do? We're going to create a tree, and a tree is going to have like nodes in it. Nodes. Let's just say it's like a dictionary, or it's just a set of the unique nodes. And what we're going to do is we're going to have, yeah, it's essentially just going to be like a bunch of nodes, and then we're going to be able to ask questions against the tree, like get employees under. So we have the, we're going to be able to
see. So
we're
now
gonna-
you're doing a method.
yeah, we're creating a method that can get the employees under a specific person. And we don't usually, if you don't want to fill out the function first, you can just say pass. Or the function, we can just say pass, and then we can also get direct reports. So we're gonna do. So these are the two functionalities that we want to implement on our tree, which is getting the direct reports and then getting all the employees under. Right. Let's see. Now what we're gonna do is we're gonna initialize the company directory. Right? And then what we're gonna do is like we're gonna loop for person A and person B in the edges. Let's just print this for now. We're gonna say person A reports to person B. Let's make sure our code runs. So CEO reports CF or manages. Sorry. So we're saying CEO manages the CFA. So we're looping that correctly. So now all we need to do is we're gonna create a function on the tree called add edge. And we're gonna grab a parent and a child. And when we say add edge, we're basically gonna store in our tree this relationship, that this is the parent and this is the child. So how we're gonna do this is, what we're going to do is, for the nodes, we're gonna store nodes. We're gonna probably create a dictionary of like names like CEO and 2 instances of its node, right? CFA. So this is how I'm planning to store all the nodes. It's gonna be in a dictionary like that. So I'm gonna say this is a dictionary. So if the parent is not in self.nodes, if the parent is not in self.nodes, what I'll do is I'll do self.nodes. I'll initialize that parent equal to, I'll instantiate a node and I'll pass in like the parent's name. So that's what that's gonna do. I'll do the same thing for the child. If the child is not in self.nodes, I'll store in my nodes. Oh, this is self.nodes. I'll create an element in nodes for the child, and I'll create a node with like that child as the title. So pretend CEO and CFO, and if CEO and CFA were never in my tree, I need to create nodes for them, because I'm gonna have a node for each one of these elements, right? And then finally, what I'm gonna do is I'm gonna take self.nodes dot I'm gonna take the parent, and then for the children, I'm gonna say the children dot append. So for the children, I'm gonna dot append the child. So I'm basically saying, because I already have these created, I'll say grab the parent node and then access the children array there and append the child to the children of parent. Make sense so far, everyone? Woo! This is a crazy stream.
What the heck is going on here? Okay,
I'm basically adding
explain
edges.
this. Yeah, explain this code. Where is this if parent going to?
So basically, what's happening here is I have this tree right here. Nice. SB. That's good. That's good.
Holy moly!
These guys are comp sci degrees though, so they probably like were.
How are you
introduced
getting
this.
that?
So what we need to do is like pretend we don't have any tree at all, and we just have these edges. Right? We have CEO and CFA, right? Like pretend we have this directory. This is where we're gonna store our directory, and think this is what our tree is essentially. We create a tree, and it's an empty tree at first. Then we look at the first edge, CEO and CFA. Basically, if CEO and CFA don't exist, we want to create nodes. CEO.
I see.
So that's essentially like that's what this is the, like, if, like, because we're gonna store all our nodes in a dictionary. So if the parent, which is CFA here, because we're looping through person A and person B.
Mm-hmm.
If the parent isn't in our dictionary, we need to create that node. So we essentially create that node CEO, right? So that allows us to create a node with a title and children.
Yeah.
Then the next code run, is the child in self.nodes? Is it in this thing? No. So we create CFA.
Oh, I see.
So we're creating those nodes. And now that
But you're not connecting them yet.
that's what this is doing. Now that since they're created, now I can just grab the parent, grab the array of children, and I'll append that child as a children of like that parent. that essentially creates this link. Then I
okay.
move on to the next element. CEO. If CEO, I don't have, since CEO is already in the nodes, I don't have to create it. But CTO isn't. So I pretty much create this. And then I move on over here to adding, I grab the CEO, right? And I say, grab me my CEO, grab me the array of children from the CEO, and append myself to like the children array of the CEO. So it starts to, and then we do that for every element till we fully build out the graph. CFA analyst. CFA is already created, so we create an analyst. Right? And then we link it. Does that make sense now, my code there?
Yeah.
So now, pretty much we can just ask I think we can implement this first approach right now. Direct reports. So now, let's do company directory. And then we'll say add edge. Adding edge means we're going to add that edge. And we're going to say person A and person B. So we're going to loop through the edges and add all the edges to our tree. That's what starts building out the tree. Like I said, like per iteration, we're like slowly building out the tree. And then after this, like we should have our company directory should be valid here. Right? We can essentially ask it questions now. Let's implement who the direct reports are. Right? How would I implement who the direct reports are? If I pass in a person, right? And I'll let you code this. I'll let you code this. So I just want to get the direct reports of a specific person. I want to call this function. It should print who's the direct. We should say company directory dot get direct reports of the CEO. Right? Who should be the direct reports? The CFA and the CTO, right?
Yeah.
So how would I implement this function? To rest my voice a little bit.
What the heck is going on? Okay, so who are the direct reports? Dang. Parent not in self node, self dot node children. Is that how you do it? If child not in self dot nodes, self dot
What's child here? It's not referring to anything, right?
self dot what?
Like we just want to get the direct reports of a specific person. Here, it might not be intuitive, so I'll just show.
Yeah, no, I'm not getting it.
So pretend we're just given, we're just given, let's ask the question, who is the direct reports of the CEO? All we need to do is access the specific node by going self.nodes and grabbing the person. So that grabs us our CEO. Right?
Let's return.
This grabs us our CEO node, and all we need to do is do for a child in, or where we can do, oh yeah, we can do for child in node dot children. These are the people who are who I have direct links to. Be like, say, we could say direct reports of this person are, then we could do print f tab child dot title, right? So now we can ask, let's see if this works. Oh wait, person dot title, wait, child dot direct reports of, wait, what's going on here? So we're grabbing the CEO, and we're grabbing the person. Oh shoot, node. So wait, so we're grabbing the person. We're actually grabbing the node, and then we're grabbing node dot title, child, for child in direct reports of the CEO, built-in method title of string. Or should we have title here? Wait, I think this is like a keyword. This might be a title might be a reserved word. One sec. Yeah, because we're using a string, so we can't use title. Wait, nodes, child. Oh wait, what do we store here? Oh no, we want to store. Okay, I see. Self dot nodes dot child. Because we want to store like the actual reference. So these are node objects, and to extract the title, we do that. For node. Okay, finally, there. We got the direct reports of CEO, our CFA, and CTA. Or our CFA, and CTO. Direct reports. Right? Now, you want to ask another question, like who is the staff eng? Direct reports of staff eng. What should that be? Intern, right? See how it's working?
Damn, I'm confused. I'll get this at some point.
Let's do who's the direct reports of the CFA. See, so what it's basically doing is all it does is it grabs that node and it just loops through that children of that node, because the children of the node are the direct reports, right?
Yeah.
So if we know where all the nodes are and we have like a hash map that we can give in like a string CEO and it'll return us the node, all we need to do is loop through the children of that node and print out the children.
Ah, I see.
Yeah.
For child and node children.
Anyone have questions? Woo! This is crazy session. I already raised like 10 subs off this.
I'm cooked.
Yeah, we're literally gonna finish right after I.
Yeah, let's do one easy lead code question to end it off.
Yeah, I'll give this guy the palindrome question.
What was
Someone
the palindrome question?
get a easy question loaded up for this guy. So let's like get all the employees who are under. Yeah, don't worry.
Yeah, bro, I'm a way more beginner than you, bro. Trust me.
So let's get all of the array that are under. Yeah, send me one more lead code question.
Do an easy one so I can run it.
Yeah.
Do an array one. Do an array, an easy array. Then I'll go to sleep. Oh man.
Where are you? Like, what time is it, SB? Where are you from? What's the time? So John, in order to get the employees under a specific person, we'll grab the person,
Trying to follow along. Could you show the rest?
show the rest of which. Oh yeah. Let me zoom out. Dude, I wish I can copy and paste this code in there for you.
You probably could. 2 a.m. Slap.
Go past the. So, if you're trying to follow along, we define people, we define edges. Dude, and my voice is giving out on me. This is a lot.
Take a sip. Take a sip.
I need a hot water.
Did you eat it? Do you want to get full after this?
Yeah, dude. Let's.
You don't like that faux spot that I say though, night owl?
Let me message these guys.
Somehow you're a picky kid, man. I don't know if you've always been a picky kid.
No, I'm not a picky kid. And then, dude, Keith,
Oh,
Keith I want
man.
to say what's up to you after, like, they're at their house.
Okay, who's he?
They're just chilling, so. So we can pull up there.
Okay, yeah. To my house?
Yeah. Or are you gonna sleep here?
Yeah, I was planning to sleep here.
Doesn't matter. I'll tell them to come here. Okay. No, are you following along? So
Man,
now we're gonna
I'm
get.
definitely like at the bare minimum. I'm definitely getting.
Yeah, edges are the connections. Edges are the connections. So we're given the edges in a linear data structure, and we construct the nonlinear tree data structure using the edges. So now let's do this simple thing. Who is under the CTO? It should be all these people, right? Right? Yeah, that's crazy. Yeah, it's wild. So what's it called? Let's do this. So John, I'm doing a very simple thing called get employees under a specific person. Pretend I want to get all the employees under the CTO. So what I'm gonna do is I'm gonna find the CTO node and push into a stack the direct reports of the CTO.
Give me a lead code question, man. An
So what I'm
easy
gonna-
array question.
So what I'm gonna
Easy
do
one.
to
Easy
do a,
one.
to do a depth first search, you usually
Don't embarrass me.
you usually use a stack. So what I'm gonna do is I'm gonna find the CTO, and I can find that easily using because we have a hash map, and I'm gonna put all the children of the CTO into the stack. So I'm gonna put eng manager. Eng manager. Then I'm gonna put the staff eng. Right. So these are the elements of my stack, and then I'm gonna like move on. Right. And then the stack is last in first out. So now I'm gonna look at the staff engineer, and I'm gonna put into this. I'm gonna pop it out, and I'm gonna add into the stack all of the children of the staff engineer. So I'm gonna pop out the staff engineer and pop in all the people that report to the staff engineer, like the intern, right? Then I'm gonna pop out the intern and add in who reports to intern. That's nobody. And then finally I'll pop out the engine manager, and then that's how I traverse all the people under, and I just need to maintain who I followed. Make sense? Yeah, seems like you get it.
Bro, I'm cooked, man.
I just did that, bro. Oh, you want to? Oh yeah, I guess you want to do that. You want him to do it. Okay.
Oh no.
I see because we already. I see what you mean because we already kind of like, did the concept. So you want him to kind of understand it. So let's start with the person. So we usually start.
Did you already do that question though?
Yeah.
Do a question that I didn't see yet. So.
Yeah.
Cause I might just like be able to do it because, you know, like memory and whatever. But I'm kind of cooked, so I probably don't remember how to do it.
So the people who work under this person are, we're gonna have like a result here. Or what
Actually, yeah, maybe I should do that, so I just
We're gonna do-
retain it.
we're gonna have a stack, and what we're gonna do is for self dot person or child for child in self or we're gonna start the stack. We're gonna start the stack with
Holy, I'm so fried. What is going on here?
So we're gonna start the stack with the person.
I think my limit's like 4 hours.
Self.node's a person. So we're gonna
Like,
start.
why is there so much code, bro?
While the length of stack is greater than 0. Candidate equals stack
Musa Panda's data
dot
frames.
pop. So we're just doing a simple depth first search. I mean, it's not simple, but
Yeah, what? Bruh.
if candidate dot title equals not equal to person, we print f. We'll say candidate dot title
It's a charger.
works under this person. So we're looping.
I'll be right back.
So we have a stack and we store the first person, and while the stack has elements, we're gonna pop out the first candidate. If the candidate dot title is not equal to person, we're gonna say we saw a person that's not like the current person that we're trying to do. The smallest. We did that question null also. Dude, I'm gonna have to drink some full after this. So what we're gonna do is we're gonna say we're gonna say our children. Where's our children? For appreciate it. So for child in candidate dot children, what we're gonna do is like if, or we're gonna do stack dot append the child. I think that just works just like that. Let's run this. Let's say is under or dot get employees under the CFA. So analyst works under the CFA, and don't worry about doing a binary search. We don't need to do a binary search. Just find any good lead code question. So who's that? Finally, who works under the CEO? Everybody, CTO. And I'll bring this up. So see everyone, we implemented the thing properly. Dude, John,
Yo.
take this. So we can like
Holy, smells like coffee and work ethic in here. Oh man.
dude, that tangent that you went on was crazy earlier. That's good. So now, okay, who reports under the CEO? The CTO, staff eng, intern, eng manager, CFA, and analyst.
What the
Right.
heck happened here? What the heck
who-
happened here?
Who reports under the CTO? Who reports under the CTO? Staff eng, intern, and the eng manager. Who reports under the CFA? Just the analyst. Who reports under the analyst? Nobody. So yeah, that's how you implement a tree from scratch. And that's all the theory. We literally went through all the theory too. So my brother's cook, so if you want to give him a one very simple lead code question,
Holy.
let's do.
Dude, we did like 5 lead code questions. Went through theory. Bruh. Put it on this side so they can take a look at what the blind 75 is. Hit this, so just in case. There aren't any easy binary search questions. Oh, god dang.
Is the guy who had to reverse a linked list still here?
Contain.
Yeah, you're seeing it.
No, I finally realized why you need a class. Because you need to have the attributes. And now I know why you would need a method.
Yeah, we can get into that too.
Top 50 interview questions? Dang. These seem hard as hell.
Length of last word. Wait, let's do one that I haven't done so we can get my numbers up. Difficulty. Okay, we'll give him like a decent.
How long does it take to get good at this? Coding in general.
I have no idea.
Because like my use case is really just like data, like automating financial analysis.
Like,
how
by
long?
frequency.
Oh man. What's your stats?
Stats on what? This? There's a stats section here. So I have top like 0.7.
Damn. No, make the bubble bigger so they know what kind of questions you were doing.
Okay, wait, let's go.
Link lead code profile.
Yeah, let me do that after. One sec. I'm just trying to find my brother a good question. Number of citizens. Let's look at this.
Oh my god. Do they know what advent of code is? We should do advent of code tomorrow.
Cooked right now. Yeah.
Should we do advent of code?
Those ones are
tomorrow?
hitting, but we need to diversify. So you were given a. Okay, this is a good one.
Could I
Okay.
even answer this?
Yeah, you can answer it. Okay, my brother's gonna solve this one. Number of senior citizens.
Are we switching?
Yeah.
Okay, I was about to be like, yo, why are you dipping? I need some assist. Yeah. Link lead code profile. What is that? Bro, I'm not even sure where I'm at. I'm like disorientated. You are given.
Take a deep breath.
You're given a zero indexed array of strings. Each element of details provides information about a given passenger compressed into a string of length 15. Information about a given passenger compressed into a string of length 15. The system is such that the first 10 characters consist of the phone numbers of the passengers. Okay. The next character denotes the gender of the person. So this is the person's phone number. This person's a male. And the following two characters are used to indicate the age of the person. And the last two characters determine the seat allotted of that person. Return the number of passengers who are strictly more than 60 years old. Okay, can't I do that? Let me see here. I'm just gonna try to print the last two letters of that. Are they always like that? Like this person's 40. What happens if a person's 2 years old? But it always says the following two. None of the passengers are older than 60. So what I'm going to try to do to answer this question, damn tic-tac? What's a tic-tac? Damn tic-tac. What is that? Bro, You guys are watching a monkey, man. Finance monkey. That's like a derogatory term, for finance people. Okay. So I'm gonna be for element in details. Print. That just means TikTok LMAO. Oh, okay. Print element. I'm just gonna take a slice. Element. So I know my brother hates it when I use negative what's it called? Indices. But I'm gonna use negative indices. -5. And then -5. Is that -5? No, I'm gonna use -4 to -2. Then run. Let's see what that is. Okay, speaking UK. Tic-tac. But yeah, so now I got 75, 92. There's a 92-year-old on this plane. Is that right? And 40. So now I've got those elements. Okay, I know the first thing that I did wrong on this lead code question is I went straight to writing code. Straight to writing code. But yeah, I don't know. I'm not that good with the Excalidraw, to be honest.
Wait, think about it. Okay, what's the question asking again? Like, wrap me up on
return the number of passengers who are strictly more than 60.
Okay, what's the input?
Like these strings, and then I have to extract the string.
So how do you extract it?
I use
what
a
are
slice.
the different portions?
I use a slice. So the first 10 digits.
Yeah.
The first 10 digits. Wait. Let me put the Santa hat on. Nice for aesthetics. Oh, I like the little tiny thing up here.
Woo! This is crazy.
Yo, why is this tweaking though? Why is my hat not looking right?
It's all good. It's all good.
Why is this hat tweaking, man? Oh, that's better. Is it?
Nah, it's all good. Just leave it.
Okay, yeah.
Let it tweak.
Yeah, okay. But yeah, so the first 10 digits are the person's phone number. After the next one is the gender of the individual, so male or female. And then the next 2 digits are the age. And then the next 2 digits are their seat number. Okay. So what I did right now is for element in details, I just said, I just printed the elements to get I used a slice to get the ages, right?
Okay.
So for example, now I've got 75, 92, and 40.
Yeah. Or lift yourself up a bit. This is fine. Or like you probably have to move up the chair. The
But
chair?
then you're not in the thing.
No, like the chair, just move it. Alright.
Okay, yeah. Yeah, get in the
He's
shot.
tweaking.
You're half cut. Wait, let me just take this off.
There you
Okay,
go.
it's better. Oh man, can't wear the Santa hat. Wait, I'm too low now.
Okay.
I'm not
Reach
that
yourself.
tall. This guy's taller than me. Oh, okay, but yeah, do you know what I'm?
Yeah.
Do you hate that I did this though? I had to do
not
it.
really.
Cause like, look how long it is.
You don't want to count? Yeah, from the
Yeah,
front.
no, I'm not. I'm good off that. I'm gonna start from the right. But yeah, do you see what I'm getting now? So I'm getting this. Like, then now the thing that I'm gonna do is like, I'm gonna initiate a, self details list. I just need to return over 60. So I'm just gonna initiate a list called a variable called over 60. I'm gonna call it 0. And then, let me just do this. Let's make it Pythonic.
Yeah. Using numbers doesn't really.
Yeah, make
We
it
don't like that.
Pythonic, right? So for element in details, print this. But now what I'm gonna do is I'm gonna make this an int. You know what I'm saying?
Smart.
Right? And then if this is int, if 60 strictly more than 60. So if this is greater than 60, if 60 is less than the element as an integer, what? Do over 60 plus equal to 1, else continue. Then probably, I wonder if this is gonna break. Return over 60. See if it runs. Is it gonna run?
It's good to me, man.
Dang.
Bro's getting good.
Dang. Was that too easy?
Want to do another one?
I'm fried, but that was light work. Holy
Submit
crap.
all the test cases.
Submit all the test cases?
You only run it on that.
Okay, watch it be off though. Accepted though. But why is it so slow? And what's the complexity of this?
Someone give him another one.
Yeah, what's the complexity of this? Is this n complexity?
Reason about it.
This doesn't do anything. Or no, this adds some memory a little bit.
Constant memory, right?
Yeah. For element in details. For element in details, if less than 60, I just add a plus equals.
So how does it scale as the list of details gets bigger?
And
So you're out, yeah. So you're
yeah,
out.
it's just n complexity.
This guy's getting good, man.
Was that that was a little too easy. Did you do this question already?
No, I hope not.
Let's see your submissions.
Where?
Hit the submissions. Okay, yeah.
All right, everyone. Thanks
Nah,
for
nah,
tuning.
shoot,
Do
nah.
you want
Do one more. Do one more. Contains duplicate 217.
No, you did that one so many times.
What was that? Oh yeah, it's already answered. Find the winner in a tic-tac-toe game. Oh god. This is a 2D array.
The acceptance rate is way too low.
Employees earning more than their manager.
A sequel.
Oh, should I run a sequel question? Let's see. Let's see it. I want to see it. Quick times. Write a solution who earn more than their manager. Is that light?
You can also do it in pandas?
How? Dang. No, I can't even do that for sure.
You can practice your pandas, bro. Yo, you
Shit.
can actually practice.
Dang, I can do that? Select name from what's the column name? What's the table name? Employee. Select name from employee where no, I can't even answer this one. Select name from employee where James, what type of dev are you?
I do full stack. Full stack.
Okay, should I give up on this?
Oh, let me write this.
No, I want to see it in pandas.
Wait.
though.
Let me write it quick. Let me write it
In
quick.
SQL?
Yeah.
Wait, where was it? MySQL?
Yeah.
Where? Oh no! I think I could get it. Where? Huh? Select.
SBM full stack dev. Dude, that's already bad.
That's already bad. Oh god.
Left join employee. Where?
But how is there two?
Huh?
What?
So left join. Okay, select name from employee.
Are there two tables? There's only one table.
Wait. Where's the manager? Wait, let's see.
Full stack is the best.
Yeah. Yeah, I do full stack. Oh yeah, you're right. So you want to create another key?
Yeah.
Okay.
Okay. Was I doing it right initially?
But you can left join on a table you create.
What? But why can't I just put a select in here?
Yeah, you can do that.
Where? Select.
Yeah. Full stack is cool. Like you get to work on the front end, you get to work on the back end, you get to work on the infrastructure, you get to work on anything really. Especially it's nice, especially when you're just starting your career, to not pigeonhole yourself into something very specific. So I would suggest, if you're gonna start, it's a good start doing full stack. But honestly, I'm not labeled a full stack. I'm just
Just a
I know
senior
Figma.
software
I'm just I'm just literally called a senior software engineer. That's it. Like there's no other, like they don't. I just have to do whatever they tell me. Doesn't matter if it's front end, back end.
Select name from employee where select salary from employee where. Nah, I don't know this, man. Let's do it on pandas.
You want to do it on pandas?
Yeah.
Because I think we need to create a temp table. Where create Postgres. Where's create SQL create.
But why can't you select the salary of the dude's manager? And then input that in there.
Yeah. Wait, can we left join? Can you left join a table onto itself? Okay, yeah, you can do that.
Okay, I can run that then. Left join on ID.
From employees E1 left join
What is Figma?
employee. Yeah, I know Figma.
What
We
is
use
that?
it a lot in the industry. It's just for prototyping. E1 dot.
Damn, I'm getting hungry. What did I eat today? A wrap.
Left join on. So we need to write a suit who earn more and left join.
Damn,
select
you know SQL too? That's
Yeah.
crazy.
U1 dot salary greater than U2. What do we get here?
Output Joe.
Oh, we need to boot expected employee.
God dang.
Get it.
Golly, bro. How did you start?
How did I start coding?
Damn, I have to work on my SQL. That was horrible. What the heck was that?
I haven't done SQL in like a year.
Oh my gosh. But yeah, how'd you start?
How'd I
Who's this
start?
guy?
Like, how'd I start what? Like, I took a regular college degree, finished degrees, did internships. My route is very traditional. Like, went to school, did internships. After I graduated college, I applied for new grad positions. And since I did internships, it helped me land a position. After I landed my position, and that's how my first job was at a Series B startup in the Bay Area. Dude, what should we eat, man? Like, we're thinking of like a
What
pho
are you guys gonna
or like
eat,
a
pho?
shawarma.
No, not shawarma, man. I'm sick of shawarma palace. I eat that way too often. What am I doing here? Did you answer this question before?
Probably.
No, you didn't.
Maybe not in this session.
What? Should I run it?
Do you get it? Oh no, this
No,
question's
I
kind of
didn't.
dumb.
I didn't even read it. Given an integer x, return true if x is a palindrome and false otherwise. I swear somebody was asking me to do this question. Do I have to answer it in a certain end time? Could you solve it without converting the integer into a string?
Just convert it to a string.
Oh my god. Okay. For x string equals string x. Hear that stomach, bruh. We're
Some
both
freaking-
starving.
Yeah.
Oh, what? Command Z.
We're gonna eat pho.
What
We
are
need to
what are
rest
the
it
other
down.
goofs saying?
Yeah, let me.
We
rest
might
it.
as well try to do as much as possible.
I'll give him a call. We're back. Have this thing solved.
Is the Waymo guy out here?
Nah, but I want him to come.
Yeah, there's a couple. Man, the friend group has a bunch of tech goofs in SF. But yeah, okay. So now I have it as a string. Now I'm going to make this string in an array. For x string array equals. Guys, am I doing this right? Like, am I using too much memory? Element for element in x string. Print x string array. Run. Okay, now I've got that. Okay, how do I reverse this palindrome though? How do I reverse it now? For guys, I'm using so much memory on this. It's okay though. I'll put array print inside the loop. What does that mean? What? Bruh. No, man, you're talking to a guy with the null brain cells right now. Print inside the loop for element in x string array. Then I'm gonna do a count. I'm just gonna do a pointer. I've been doing a lot of pointers. Pointer equals -1. Wow, pointer. Is there an absolute function? I'm just making stuff up right now. Pointer is less than the length of x. What's it called? Output dot array dot append x string array. What's it called? Pointer minus equal to 1. Return x string array is equal to output array. What? Why is that not right? Why is this not right? Oh, equals double equal sign. Holy moly! Did this run? Frick. While abs pointer is less than length x. Why is this not running? Object of type int has no length. Length of x? Oh, length of x string array, I guess. Guys, I am not thinking. I'm just writing code and praying for the best. Oh no.
Spray and pray.
Yeah, I'm spraying and praying. Why is this not running though? The heck? This one was expected to be true.
Print them out. Let's see.
I don't even know how to print them out though. I don't know Python for real.
Damn, I was showing you all this complicated tree stuff in some language you didn't know.
Do you know how to write Java?
Yeah, I had to do it before. It's not my favorite.
Print what? What am I doing here?
Okay, no. At line under line 11 before you return, just print them out.
Print x string array.
Or before the return, like return, you won't get there.
Oh, I see. Yo, Caesar, what do you think about my coding skills, man? I want to know. I've been working at it, to be honest. No, let me write output array.
Do both.
String array. And is that? Can I even do that? Is that the thing?
Yeah, you can do it. Yo, SB and null. I'm gonna do a marathon.
Oh, what the heck?
What's missing one?
Greater than or equal to this? No. How come these are right though?
Well,
Am I
because
just
those are
missing-
false. Those are already false.
Oh, I see.
Yo, SB and null. I'm gonna do a blind 75 marathon.
There we go.
Where
Bang,
I'm
bang.
gonna do all the blind
Bang,
75
bang.
questions in one go. And I'm gonna have some special guests in there, but we're gonna spam all the questions.
Beats 5.2%? Why is my algorithm so whack? You got the job done. Should we do one more?
No. Actually, wait, listen.
Yeah. Let's cut when they tell us to start driving.
Okay, I'm gonna make some food then. I'll
No,
make some
let's
noodles.
cut. No, let's eat for real. When? Well, I know some of it. When? Oh man, give me another lead code question. Easy array
Bro,
question.
you didn't even. This one is still like you could do this more optimally.
Nah. I just want to get some. I just
Okay.
want to get your numbers up.
Yeah, okay.
Blind yourself first and then do blind 75.
Google
Yo, it's Google
guy.
guy.
What's
Google
up,
guy. Let's
John,
go, baby.
The best way, you can do this also with 2 pointers. You just compare these ones, and if they're the same, you move it forward.
Oh, I see.
Until they meet. If they don't, that's how you do it with no extra space. If they differ at any point, then they're not. It's not a palindrome. Yeah. That's just like FYI.
Okay. Oh
For
man,
next
that's
time.
it. Okay, let's run another one. Google guy just showed up. Blind
Google
yourself
guy.
first and then do blind 75.
Google guys in the building.
Holy, yo,
Okay.
Google guy, give me something like, what do you call it?
Some easy lead
Yo,
code questions.
is this guy lead code hard?
No, lead code hard is not here.
Lead code hard is lead code hard, eh? There's a couple legends in the chat. They change their name pretty frequently. Waymo is part of Google, eh? Teach him binary search.
Well, I just
He
did.
did.
Dude,
He
I
did
I
teach
did
me
like
binary
a whole hour
search. He
doing
did.
that.
Yeah, bro. We went through binary search. We went through.
We did like
Man,
every
give me a lead code question that I can actually practice on. You know
We did
what I'm
like every
saying?
variation of binary search.
Man, I'm fried. How long has this stream been? 5:45? Yo, Caesar, man, respond to that. We're gonna be applying for the same job soon, so you better be cooking something up. Nah, I'm just playing. I always try to beat Caesar. The last time I beat him at the club, he didn't like it very much. I thought he was gonna throw me out the window. Do first and last index or -1 of an element in an array? What the heck is that?
Okay, look it up.
Are you hungry? Yo,
No,
call
I'm
these
not really
goofs
hungry.
up, man. I'm trying to eat. First. What? Is that a lead code question? First and last. Find the index of the first and last index or -1 of an element in
Okay,
an
do this
array.
one. First unique character in a string. Do this optimally.
Ask James. Oh no. Wait, did you already answer this question though? Don't let me do a question that you already submitted.
No.
What was
Okay.
that code then?
Maybe I like started a bit.
Okay. Given a string S, find the first non-repeating character in it and return its index. I think I'm gonna do a stack, bro. Oh no, do I have to do a dictionary? Yeah, it's there. Oh man.
Can you give the
Given-
number?
Is this it?
No, let's keep going. Yo, Google guy, what time is it there? I'm pretty sure
Given a
he's based in India.
string, find the first non-repeating character in it and return its index.
Dude,
If it does-
your head is just showing up. Looks funny.
Just my head is showing up.
Yeah.
Bro, I'm not that tall, man. I'm like 5'4".
Off the cap. There you go.
Is that good?
Yeah, that's good.
All right.
Cause it's
Do you know Nick?
Nick Nurse?
No,
Nick Codes? Nick Code?
No, Nick Nurse. Isn't that the Toronto Raptors coach? Given a string, find the first non-repeating character in it and return its index. If it does not exist, return -1. The character L at index 0 is the first character. It does not occur at any other index. Find the first non-repeating character in it and return its index. What the heck does that even mean exactly? What? Do you know what it's saying? Do Q34. Okay, we'll do Q34.
Look it up on Google. Alright.
What? How do you do that?
Wait, just go problems.
I don't even know my way around this.
Let's look up
thingy.
34.
34 like that?
Yeah.
Bro, it's a medium? Given an array of integers sorted in non-decreasing order, what the hell does that even mean? Yo, Kanye East!
Yo, what's good?
All the big hitters. I think we might have to stay. We might have to like
Okay,
take
let
the
me make
L
a
on
tea.
this.
Let me make a tea. I'm
Let
just
me
gonna
make a
quick
tea. What's a tea?
Or I'll order for here. I don't know. Should I just order?
Given an array of integers num, bruh, I don't think why would we stop? It's hot.
no
It's
point
getting
stop,
hotter.
no point stop.
Given an array of integers sorted in non-decreasing order, so does that mean in increasing order? Like, why don't you just say increasing order? Find the starting and ending position of a given target value. If target is not found in the array, return -1. You must write an algorithm in O log n runtime complexity. Bruh.
Yeah,
Yo, didn't I tell you I was a beginner, man?
No, this is a binary
Golly.
search question. I can do this question.
Okay, nah, just guide me through it.
Dude, my voice is messed. I have to like write some code right now. I'm gonna make a tea. Dude, give him an easy question.
Nah.
I'll solve that after.
Nah, yo, Google guy, coach me through it. Give me some tips.
Dude, do that other.
Do the other one? Nah, I want to do whatever they tell me to do.
Okay.
Do it only if you know binary search. Only ask but he seems like a genuine guy. I freaking hate this guy.
I can help you do it. Look, we were just working. We were
But
just
yeah,
working
no, it's a
with
sorted
binary
array. So like I'm gonna do a binary search. So like the first way to start a binary
Here,
search
implement binary search regular first, and then we'll work our way up.
I could just run it in there and try it.
Try this. Just try this.
You already
question.
did this question though.
Doesn't matter.
Let me look away from that guy.
Go. Now do this. If you can do this, then we can do that next
Pointer
question.
L. So, okay, I'm gonna do this question, and then he's gonna make a T, and then hopefully this preps me for warms me up for that medium question. Why'd you give me a medium question? I literally did like I have like 10 lead code answers under my belt, bro. I literally have less than 10, man. Give an array of integers, which is sorted in ascending order, and an integer target. Write a function to search target in nums. If target exists, then return this index. Otherwise, return -1. Yo, SB and null, are you still in here? Holy. Do I remember how to do this? Pointer L. Pointer right equals pointer R. Yo, do you guys remember this? Oh man, this guy, pointer R, L and pointer R is 0, and then range or length of nums. This guy's telling me I have to do this again. I don't even remember this though. I just know that the way the binary search works is like you take an array, you split it in the middle, and then like you try to identify where you want to look. So you either want to look on the left or the right, and then you slice it there. Yeah, you have to shift the pointer. Yeah, exactly. Let me hell yeah if you'd like. For sure, man. I definitely need help with this one. Pointer R. Yo, Google guy, have you ever seen me do a lead code question? Bruh. I literally started to code like literally a month ago, man. 2 months ago? 2 months ago, maybe. While pointer L is less than pointer R, golly. Middle equals, what the heck is that? VN, oh man, what the heck is that function? Is that JavaScript? I only know Python, my guy. Middle, I only know Python, bro. Middle equals, so I have to do like pointer L plus pointer, that's C++. Bruh, you're cooking me right now. Pointer R minus pointer L divided by 2. Yo, does this function even make sense? Yo, I can't believe my brother ditched me, man. You said he was a genuine guy? That's crazy. Oh. Okay, so middle pointer. So now that I have a middle pointer, use this instead. Left plus right divided by 2. Why do I use left plus? What is left plus right divided by 2? Pointer R plus pointer L. Why is that? To prevent integer overflow. Bro, what is integer overflow? Nah. Yo, you guys are using some big words, man. You guys are using some big words in the chat. Like, I do not understand what's going on here. What's the target? If middle greater than target. There's competitive lead code? Must be memory related. Man, what is going on? No, nah, I'm a beginner. If middle is greater than target, or if middle is less than target. If middle is less than target. Okay, so let's go into this one, right? So if the middle is less than the target, I want to move the left and right pointer. I want to move the left pointer to does this have to be an equal sign? Competitive programs like OD crack lead code. What? What are you goofs talking about in the chat? Competitive programming is like OD crack lead code. Middle equals pointer L plus, okay. If middle is less than target, I'm gonna make the pointer L equal to, bruh, I'm just writing code, man. I'm just writing code. Pointer L is equal to pointer L is equal to middle plus 1 else. Yo, am I even doing this right? Pointer.
Yeah. But you're capturing the middle index, but you need to actually access the array. You should say num's middle is less than target.
Oh, I see. What is comparative is like OD crack lead code. Holy, I can't eat this too much.
Yeah, I'm making a kimchi.
No, I'm gonna eat real food.
We might go on this for like 8 more hours, bro.
Okay. I'm down. Look at it. Popping off. Pointer L equals middle plus 1, else pointer R equals middle minus 1, right? And then what? Okay, yo, now I'm lost. Somebody help me in the chat, please, God.
Okay, explain your code. What's happening?
Okay, so I initialized 2 pointers, one at the very far left of the array and a second pointer on the far right of the array. And then I say while the pointer L is less than the pointer right, so they're not equal yet, I make like a middle pointer if case needs to be inclusive. What? Why is this linting?
Yeah, he's right.
What does that mean? So I have to hit this like that? If case needs to be inclusive. If num's middle is less than or equal to. Why does it need to be inclusive though? Else pointer R equals -1. How do you do it in CPP? Oh no, do you know C++? Can you write this code in C++?
Probably.
Golly. This guy's like a multilinguist, man. Okay, yeah. What am I doing here exactly? So pointer L and pointer R is equal to 0 length of nums, while pointer less than is strict. Okay, yeah. Okay, what am I even returning now? Like, I'm so confused here. Like, now I moved the pointer. And then, if, see my logic in above message. Where's the above message? If case needs to be inclusive. Wow. Yo, could you write that in Python? We gave you the answers. Bro, y'all tripping. I can't even read that. I can't even read the answers. Oh, this is embarrassing, man. Yo, y'all give me the hardest question. Give me like layups. We gave you the answer. Y'all gave me the hardest questions though. See my logic in the above message. You use this instead to, bro, I don't know what overflow. Y'all gotta do monkey talk. You guys talking in literal code right now. Use this instead. L plus R divided by 2. While this and not equal to this divided by 2. So I have to return -1 at some point, right? That's what you're saying? Turn -1. If you split it, I'll help you, man, until the end. If you split the array in half and the target is in the middle, you need to return the middle. I see. If num's middle is equal to target, I need, yo, I'm not even reading the question, I'm just mindlessly writing code. Return middle, else pointer, yeah, return middle, otherwise else what the heck. The CFA mean needs to, nah, it's a chartered financial analyst. I'll show you what a CFA is. You're done. You just need to organize your logic. I'm done? This is basically what a CFA is. Stop. What bullshit is on line 5? Fix that. Oh, awesome guy. Yo, dude, awesome guy. What bullshit is that? Yo, awesome guy. I actually, before you came, I answered 2 questions with no assistance. I don't know if you saw the other time, like when I was doing 2-sum. What is that BS on line 5? Isn't that making a pointer? I need some assistance. Oh, God. Don't get distracted. Go back to lead coding. Bro, I do not know what's going on here. A lot of negative signals going on here. Else. Pointer R. Middle -1. Pointer L. Yo, what's going on here? What? Where'd you get that?
Downstairs. I can order the pho here.
Nah, it's alright. Bro.
Yo, awesome guy's in the building. Yo, awesome guy, get some questions ready for me. I'm ready to solve that other question.
Yo, I can't even solve this one. And you literally did this earlier. I think the question were not from my side. That's why maybe low. Oh, I see.
Google guy and awesome guy.
Oh man,
Two
I'm
legends
not
on
getting
the
this,
chat.
bro.
Two
I'm not
legends
getting
in the
this,
building.
man.
Dude. Dude, you're so close.
Am I?
What's this?
I don't even know where I'm at. What? How the heck? How did I get there? Return middle, else return. What? How did I get this far? Don't worry, man. At least you practice every day. Took NE months before I jumped to this question. Yeah, bro. Honestly, you just have to be consistent. Dude, I'm starving, but it's okay. Let's keep at it. James, encourage your little brother. Yo,
This
dude,
guy's older.
You know, this guy's the little
Yo.
bro.
Your code was working. I just had to fix one small thing.
What was it? How was it working? Little bro. This guy's calling me little bro right now. Oh man, my feelings are hurt.
They already told you.
Wait,
this.
what was
Boom.
how is this writing right?
You're
What did I do wrong?
Okay, I'll fix that for you in a sec. Somebody load up another
Okay,
lead code
load
question.
up another lead code question. Easy array question. Don't do anything crazy, awesome guy. Was awesome guy that gave me the last
No,
possible
Google guy
one?
did.
Okay, Google guy. Line 5 logic is wrong.
Awesome guy gave you that one like.
Why is the logic in here wrong? Wait, it's binary search.
Your if statement, like you can reduce the nesting there. You can put if the middle equals target instead of nesting it like that, like this.
How did I get it right though? Do richest customer wealth. Interesting.
Like
Yeah,
this.
do richest customer wealth. Why did mine work though?
Yours worked. I don't know because you nested it in here. It's still the same. Like yours is like this. I just moved it out because it matches here anyways.
Oh, I
And
see.
it just matches again here, so I just moved it out. So it's a little bit cleaner.
Oh, okay.
Another thing is you're doing wrong is you're initializing the pointer r on length nums, not length nums -1. But it needs to be
Oh, I did
minus
that?
one. Yeah, it needs to be -1 because it needs to be pointing at this last index.
Oh man.
And then after that, it just worked.
Oh man.
And then the last thing you weren't doing is while pointer L is less than equal, because it could be at the same. Like you want to run, it could be at the same index. So I just have to add this
Oh
equal.
man, awesome guy. I'm not getting the gig, bro.
Okay,
yeah,
let me
let's
solve this one question for this guy real quick.
Richest customer wealth.
Oh yeah, put it in and then I'll solve this one after. Because they asked for this one.
What's richest customer wealth? How do you even navigate lead code? Where the heck is that?
I'll buy you food.
Nah. Let's eat with the guys.
Nah, they're lacking right now.
Nah. Give them a chance.
Dude, you're gonna starve to death.
I'm
So, you
good.
know,
I'm good. I'm on a cut.
You want me to give you, you want Pancit Canton?
Nah. I'm on a cut. I'm good. Maybe I'll just drink. Do you have water in that LinkedIn cup?
Dude, I'll give you some of this, a little bit of it. So you
No,
just
I'm good. Look at this. LinkedIn. Sponsored. Trying to get that sponsorship.
Look up richest customer wealth. There you go.
Oh man, this is gonna be embarrassing if I can't solve this one. You are given an MXN M times N integer grid accounts where accounts IJ is the amount of money the ith customer has in the jth bank. Return the wealth that the richest customer has. The customer's wealth is the amount of money they have in their bank accounts. The richest customer is the customer that has the maximum wealth. What? First customer has wealth 1 plus 2 plus 3 equals 6. How the heck? Second customer has 3 plus 2 plus 1. Both customers are considered the richest with a wealth of 6, so return 6. Okay. For element, I see. Oh, golly. Define, nah, I love my brother too, man.
You are our brother, man.
Lead code 287, god damn. Okay, let me see this.
Yeah, do that one first.
Yo, this guy didn't say he loves me back. This kid.
Love you too, bro.
Okay, let me see this. Wait, what am I doing here? So I have to... Should I just define a function called sum? Sum of element. Array element. For element in element array. Haha. Guys, you grant lead code for like coding interviews. You start writing code immediately? That's crap. Yo, awesome guy. I know. It's a bad habit that I'll fix on the next question. Nah, maybe you're right. Maybe I should fix it right now. Yeah, break it down first. Excalidraw. I don't even know how to use Excalidraw though. Okay, these guys. Yo, how do you open the Excalidraw? Bruh.
We had a thing open earlier.
Yo, not specifically interviews, but for fun? Y'all tripping, bro. These are the sickest brain teasers.
You psycho.
Wait, how do you erase?
Oh, you're on the way?
Who's that?
Even Cedric? Even Cedric? Okay, what are you up to?
Yo, what am I doing here again? For element in element array? I'm just why can't I just code right away, my guy?
This shit went too long.
Chill with that. For element in element array?
Yeah.
What am I doing here? For element in element array?
Just come over and then we'll drive from there.
For element in element array. Golly. For element in element array, I'm just gonna do some calc. Sum array equals 0.
What's up?
Summary. Sum array plus equal to element. Return summary. Does this make sense what I'm doing though? Like I'm just making a function within the function quick time so I could like call upon it. Just for fun, Google guy with which comment habit. Okay, all right. So
there is
now,
a sum function already, though.
For real?
You just call sum.
Oh golly.
Just passing an array.
Okay, what should I do then?
Just do what you did because you already defined it.
Okay. Is it gonna break though? Because I already have like 2 sum functions.
No, you're good.
Okay. So for list, I'm gonna be like max equals 0. For element for account. for what's it called? Customer in accounts. Some customer net worth, customer wealth equal to some customer.
Dude, yeah, I need to get the Discord ready, bro. I swear, in the next couple days, I'll get it ready and I'll post it.
Yeah. God has his silly ways. Oh golly, no. Max wealth, customer wealth is. Oh man, customer wealth equals sum of customer, and then if customer wealth greater than max wealth equal to customer wealth, return
What's up?
max wealth.
Juan's a new name.
Run that. That was janky, bro. Jank.
Okay, let me.
That was jank.
Give him another one.
How did I do this well?
Yeah, you're good.
Beats 100%.
Let's go.
Let's go. Yeah. What do you think about that method, Google guy? Yeah, we will get a Discord open soon.
Yeah, we're
man.
gonna get a Discord ASAP. I need to. My friend is near, and he's gonna set it up for us.
Who's near? Who's friend?
Isaac.
Isaac's here? In Calgary?
Yeah.
Oh man, I miss Isaac. I'm so happy. Isaac was my first roommate? Nah, use it.
Yeah, probably.
I don't even know. I don't even remember. Asian boss, that's my Discord.
287. Okay, we got you.
Are these easy?
Everyone drop their Discords in this thing, and then we'll have it. Look up 287.
287.
Yeah, and we'll start a Discord.
Lead code. Yo, we might actually get to 8 hours. My energy is up.
What the heck is this?
Yo, why is this one hard? Is this one for me or is this one for James? Cause it's a medium.
Was you? I already solved this.
Oh, you solved it like 6 months ago. Nah, like 9 months ago. Given an array of integers containing for both, bruh. Can I solve this? Do you think I'm capable? There is only one repeated number in nums. Return this repeated number. Do I just make a dictionary?
Let's see.
I can just build a hash map. Even if it's a medium, don't just care. Yeah, I'm gonna build a hash map.
Sure.
Yo, awesome guy. I don't know how to use Excalidraw, man. I just go straight to the code.
They're complaining about it
shoot
too?
me, shoot me. You can also do concatenation of an array. You can also do concatenation.
No, let me
of
handle
an
this
array.
first and last pointer one.
Okay.
I'm gonna quickly solve this question.
There's no food in this house? Move over a bit.
One sec.
Yo, I can't believe I answered that last question though. That was such a janky solution though.
Oh.
You don't need to use that tool always. I should be though. I should be definitely not writing code right away. I got a couple comments about that. Given an array num sorted in non-decreasing order, find the starting. Why don't I just do a 2-pointer solution on this one? Right? Because like 5577, find the starting and ending.
Do it, and then but that's a O-Venn algorithm, but just do that first, and then I'll optimize it.
Yeah, target int. So, what? Nums target is 8. So I need to find where 8 is. Okay. For I in range nums length of nums. For I in range length of nums, if nums I is equal to target, return I. Does that even make sense? Let's see. Let's see if this even runs. Target 8. What's my output? 3. Return I. I plus 1. Return it as an array. I got case 1 at least.
Case 1?
Yeah, I got case 1. For this question, Mr. CFA, I would suggest to you to write the exact same solution as you did for binary search problem, and then just make the necessary changes. I don't think I could even read my own solution, my guy. I literally, oh golly. I really can't read my own solutions, and that's a skill that I lack, honestly. If target not in nums.
I haven't built a Discord yet, but I'm gonna build one. I'm gonna post it. I'll post a subscriber post to join the Discord. I'll post it on my channel.
Golly. Submit. Wrong. What's that? Why is that?
What are you doing for her?
How is that even possible? Okay, so my output was 0, nums is 1.
Yo, Juan Pablo's talking about CFA.
What? Hi, John. I love your content. I want to know more about the things that the CFA wants you to do with Python. If you help with that for preparing me, any advice would be nice. Are you studying for the CFA? I think really there's gonna be CFA really teaches you the concepts, but you actually need to write code to implement the concepts, if that makes any sense. In finance, usually the way it works is you would have a portfolio manager at the top. That's
talk to him while I implement this.
Finance. Wait, let me do this.
Okay,
I think I got it. In most banks, the way it works is the top person is pretty much like a CFA charter holder, and under them would be a technical person, and then the CFA would be basically just tell the technical person, like a coder, to write up, automate the trading strategy. I don't know if that even makes sense. But yeah, I would say the CFA doesn't want you to learn Python specifically, but you need to have Excel skills as well as Python skills to efficiently execute your knowledge. Turn
If the wait, how does this even work? If
I don't know, bro. I'm running this though. Oh god. Turn nums. Target is 0. But somehow.
here, let's
returned
whiteboard this.
something.
Let's whiteboard this. Here. Watch out for that.
But yeah, are you trying to be a CFA charter holder? You could get away with not learning Python if you're in finance, but honestly, you're gonna get automated. That's just a hot take. That I don't know.
Okay, let's work through this question. Who's messaging? Okay. Pretty much this
Okay,
question.
let me check my phone too. Let me run and get my phone quick.
Pretty much this question is pretty much just telling us find the first and last position of an element in the sorted array. So pretend this was our sorted array and we had 0, 1, 2, 3, 4, 5, 6, 7, 8. Right? Since we know that this is a sorted array, we could do binary search and we could look for largest, smaller. So the largest, smaller one than 8 would be this. And then we can look for smallest, larger. So we just get the index of the largest, smaller, and the smallest, larger. And then from there, we just return like +1 of that index and then also -1 of this index. And that will give us this range. So for this, it would be 3 and 7. That would be the expected output. So let's do so this should be 3 and 7. Output here should be 3 and 7. Okay, so let's just implement that. How do we do def smallest or largest? John, the way we do it, we could just do a binary search, right?
Oh no.
We can binary search for the largest, smaller element than us. That'll give us this. So we can binary search for the largest, smaller element than us. And we could also binary search for the smallest, larger element than us. And then we just return the indices of like +1, the largest, smaller. And then the other end is like -1, the smallest, larger.
Bro, I'm fried.
Does that make sense? Everyone in the chat, what do you think about my approach? Screw it, I'm gonna implement
Wait,
it.
why didn't it work? Why didn't mine work? Oh no, find first and last position of element in a sorted array.
Because what are you doing? Yeah, you're trying to find. Yeah.
Because it could be multiple 8s.
Yeah, exactly. So here it should be 3 and 7.
Let me fix my code quick. I know how to fix it.
Awesome guy. What? Wait on what?
I know how to fix mine. Did you
How
already
you gonna fix
remove
it? How you
mine?
gonna fix it?
Nah, don't be scared about all that.
You just scared him.
Yeah, why would you, bruh?
But you just told him
honestly,
it would be
here's the
automated.
thing, man. How do I say it? Like if you do the CFA, you will be able to. You need to automate. Like you can't beat the market without automation though. And you can't, like, CFA is table stakes. You need to be able to use you need to have like the base knowledge, which is basically what you learn in the CFA, plus experience, so you learn like how to so you know how to just overcome behavioral biases, plus you need automation to execute your trades faster. So it's kind of like as finance evolves as an industry, you just need more and more skills. Like nowadays, I feel like
Okay,
if you just have CFA...
Keep saying it while I implement.
No.
Okay.
I got this.
Oh no, but tell him he needs to know this information.
Yeah.
Tell him.
Okay, yeah,
Keep going on your tangent. That's important stuff.
Yeah, like you need it all, to be honest. And CFA like is just table stakes. That's all I have to say about it. That weird? Like, to be honest, yeah, you need it. That's a bare minimum. Stop free advice, lol. If numbers is equal to the target, return I plus 1. If I plus 1, am I gonna make a pointer? I plus 1 is equal to target and less than length of nums. This is just like I don't go out of bounds. Return if I plus 1 I plus equal to 1, else return this.
I plus 1.
Equal to target. And why is this not working? And length of nums, why is this not working?
Hover over it.
How? Oh. Return the number size in a container.
You're saying and less than.
Oh. Whoops. Is that right? I less than return. Otherwise plus. Sheesh. I think this is wrong now. I plus 1. Do I initiate a second pointer? Do you get what I'm trying to do?
No. Initialize a second pointer and then do a while loop to move up the pointer.
Yeah.
Right? That's what you're thinking of doing?
Yeah, basically.
Yeah, then write that. This I...
equals nums I. Pointer 2 equals nums I. Then nums
Okay,
I plus
Mohammed
equal to
wants to know what the question is asking. Here, let me just handle this one. It's a medium. It's going to be harder to say.
But do you know where I'm trying to get to? You know what I'm trying to get to?
Yeah, I know what you're trying to do. What my brother's trying to do. Okay, what they're asking is like, we're given an array in a non-decreasing order. We need to find the starting and the ending position of a target value. So for example, the target here is equal to 8. So here the target is equal to 8. Sorry, here. Mohammed, okay, check this out. Since the target is equal to 8 here, what we need to do is we need to find the first...
Who's that?
No. So it's not the first and last position of the element 0 and n. Yeah, so it's like, pretend the target is 8, right? We need to find the first position of 8, which is 3. And then we need to find the last position of 8, which is 7. And then we need to return back 3 and 7 as the result. Right? Does that make sense? Let's go through one more example. What about here? 5, 7. This is kind of similar. But pretend our target here. Yeah. Pretend our target here was actually 7. So the result should be let me increase it. Yeah, okay, sounds good.
Yeah.
I'll just do it just cuz.
Does it make sense what my solution is though?
So what you're trying to do is you're trying to find the first index.
Yeah,
and then
at
after
that
just like scan all the way till you find the last 7.
That's right, yeah.
And then return those indices.
That's right.
Yeah. I can like modify.
Could you just do that and
Yeah.
see what happens?
So I'll do for I in range nums, if the nums equals to target, and This is the initial approach, but I'll make sure it runs log n in a second.
Oh, you must write it in log n time complexity.
So if the num's equal to target, we'll start pointer
I
right
deleted my code.
equals I. And we'll say
Yo,
Wow.
awesome guy. I didn't get the job, bro.
while pointer right while
The interviewer had to take over.
while num's pointer right
Is that a thing in interviews?
No,
Like they
not
just
really.
take over?
while pointer right is less than while pointer right is less than the length of nums and nums pointer right equals target, what we're gonna do is pointer plus equals 1. Finally we'll return I and the
I
minimum.
know, I'm pissed.
And we'll take the I and we'll either
pointer
take
right.
Pointer right, but if it reaches the end, then we want to take the minimum of like the length of the nums minus 1 and the pointer right. What happened
Light
here?
attracts bugs. Yeah, light attracts bugs. Is there such thing as a dark mode in lead code? Is there such thing as a dark mode in lead code?
What is this?
Oh, dude, just do that
Oh, okay.
function that I was doing. God.
Okay, that solved it, but let's do a binary search solution because this is O of n time. Because essentially, it's O of n because pretend it was all 8s.
Yo, make it dark mode.
Okay.
How do you go about doing that?
Yo,
Settings?
get me a different question. I already did so many binary search questions today.
Oh, that looks way better, man. That looks way better.
Give me another LeetCode question because I've done so much. So my solution is I'm gonna find the what's it called? The largest
Is Awesome
smaller
Guy bringing
element.
food? Or,
Yo, awesome guy, give me a different one than binary search. I've done so many binary search questions today. Or Google guy. I'm gonna just come up with some questions because
what? Where's Izzy? Yo. Show them your what's it called? Show them your current project with
Dude.
the
we're on the craziest stream
Thingamabobs.
ever, bro.
You're still on?
show them your project with the AI.
Oh, I gotta
teachers
do that
helper.
live with
Okay,
Izzy.
I see.
Counselors.
Hello, everybody. Hello.
What's up? What's up? What is this?
That smell. Smells
Dude.
crazy in here.
All this coffee,
Sounds
bro.
like your place.
Oh, it definitely probably smells bad, bro. We've
We
been here
took
for
a
7.5
shower before this.
We've been here for 7.5 hours.
You guys are tweaking.
So given
Yo,
a list of
You could
accounts,
grab a chair right there, cause you're like
15.
tweaking in the back.
Can you see me?
Yeah, a little bit.
are you just waiting for Ayana to finish too? Or are you gonna chill with her or not?
Yeah, later.
She can have dinner with us if she wants.
You guys wanna go eat?
I thought that's what you were saying,
Yeah, let's go.
but I kind of want to stay on stream though.
Given an integer array nums, return an integer array counts where counts I is the number of smaller elements to the right. So to the right of 5, there are
Whoa.
2 smaller elements. To the right of 2, there is only 1 smaller element. To the right of 6. Okay, just strictly. So oh, this is interesting. Let me think. Not really. We just worked this in with our regular 9 to 5.
Yo, I missed the flight yesterday. Oh man.
Okay, let me solve this one question first for everyone, so they
man.
know how to do this with binary search. So what we're gonna do is we're gonna find the very left portion using largest smaller.
315 cooked you, eh?
Yeah, that's a hard question, but essentially we do large. We find the largest smaller, and then we move one index to the right, and we find the smallest larger, and then we move one index there, and then we just return the result there. So let's implement that quick. We'll do largest smaller of nums target, and we'll do smallest larger nums target. So we're gonna get the largest smaller. So essentially what we're gonna do here is like largest smaller index, smallest larger.
Does this run better than mine?
Yeah, because it runs in log n time. So we get the largest the index of the largest smaller, and then we get the index. We'll do this index of largest smaller. Then we'll get the index
These variable names though.
of smaller larger. So to get the largest smaller value, we're going to do a binary search we'll start with left and right. We'll do length of nums -1. And then we'll do while left is less than right. We're going to get the mid pointer, which is left plus right minus left divided by 2.
They said this was a wrong formula for mid though.
No,
They were
that's good.
talking about some overflow.
Oh, this avoids the overflow because we do right minus left divided by 2.
Isn't that what I had earlier? I swear I
No,
had
what you
that
can
in
do
my
is
code.
like you can do some other one that I forget what it was because I'd never used it, but it's I forget how you do it to make it integer overflow. But now we get the middle. Pretend we'll start here, largest smaller, then we'll do this one after.
What are the bugs?
Left and right. So what we're gonna do is we're gonna take 8 minus 0 divided by 4 divided by 2 equals 4, and then we get the middle pointer right here. Right? Is 8, so we want to get the largest element less than 8. So if it's equal to 8, what we can do...
Damn, this guy plays the same games we do, eh? I think I never played Clash of Clans. I know you played Clash of Clans.
Maybe when
though.
I was younger. Counts merge, copy list. Where's this? Where are we at? So
Mid.
So since we want to get the largest smaller, if it's equal to 8, if the nums at mid is, so if the target is 8, if it's equal to 8, if it's greater than and equal to 8, because we want to look for the one that's less than, if the nums greater.
Damn, it's been a while since I played that game.
Since the nums at mid is greater than equal to 8, or sorry, target, don't hard code that. What we're going to do is we're going to take our right and we're going to make it mid -1. Else, we're going to take our else, pretend if it's less than, what we're going to do is move up our left pointer. Left equals just to our mid, right? So since we're moving up the left pointer, imagine we're at a list like this. 8, 8.
Damn, import pandas SPD, bro.
8, 8, 8. I'm just trying to figure out which middle we need to take. So pretend we have like multiple middles. 8.
You know the other crazy thing that you could do too is enumerate.
Enumerate what?
You enumerate the entire thing and then find 8 and then find the max of the second integer and the max of the I'll do my enumerate solution after.
Okay, wait. I'm already getting cooked from doing this so long. So if the nums mid is greater than equal to target, if the nums 8 is greater than equal to target, this is greater than equal,
He's at.
you move it. If it's less than, we move it to mid. And pretend we're just at 8. If we're just at 8, 8 here, what are we gonna do? If we're gonna go 8, 8 here, what are we gonna take? We're probably gonna take 8, 8. Okay, and then we just keep the left pointer. What we're gonna do? 7. Pretend they're both under. Pretend they're both under 7 and 7. We take this one. We want to move the left pointer up. Oh no, but we want to move the left pointer. Oh, so we want to take. We want to take. We want to take the higher middle. So left divided by 2. Left plus right divided by 2 plus 1. So that will get us the. Then we'll do if. Yeah, that'll get us the largest smaller value. And I just need to test that. So we're taking the larger mid. Yeah. So what we're going to do is if nums at left is less than the target, we return left. Else we just return -1. This is how we get the largest smaller element. And let me just test that.
I'm gonna spam enumerate. Okay, let me run enumerate on this after, okay?
Okay. What is it doing? Largest, smaller of nums. Nums, target. Print here.
Was my solution O log n complexity?
No, it's ovan.
Oh, okay. So it's basically telling you have to do it as a.
If left is less. If left is greater than equal to 0, and because we're shrinking, and left is less than the length of nums, and what is this? Output is 2. Yeah, that's correct. Right there. We got 2. So let's look for another one. Let's look for what's the smallest larger than 10. If we do we do 10 here. 0, 1, 2, 3, 4, 5, 6, 7. Okay, we're actually grabbing the correct value that we want there. So, okay, target is 6. 0, 1, 2, 3, 4. Wait. So if the target is 6, why are we getting 4 here? The target is 6. And we want to get the largest smaller of 6. This guy's hungry.
Oh, big. Nah. I'll survive. Don't worry. I've been through worse. Like missing my flight. Golly.
Oh, sorry. This is target.
I'm never doing a budget airline ever again, man. That's the last time.
Okay, yeah, we're getting this. What time is her Christmas dinner done, Keith?
I think soon.
Bro, I'll survive. Is,
No, we can go with other though.
is Isaac coming right
Whenever
now?
you're ready.
Is Isaac coming right now?
No. He's
No.
busy. He's
What?
gaming.
He's gaming?
Dude, we got like
Sick of that
13, 13 people on this right now. Okay, wait. Larger, smaller.
Do you guys work as software engineers? He does.
This guy works in finance, I work in software. Left and right, mid. So if the mid is smallest, larger, if the mid is less than and equal to the target, we go left goes. This is just muscle memory at this point. So now we're doing smallest, larger. Index of smallest, larger. So if it's less than, then yeah. Dot smallest. Okay, cool. Now we kind of just return this. This will solve a bunch of the ones, and then we just need to handle edge cases. What does this return? Smallest, larger. So we get the mid. If the num mid is less than equal to the target, we take. Okay. If the num's mid is less than equal to the target, because we want to get the smallest larger. If the else the num's mid is greater than. Okay, then we move the right mid there. That makes sense. Print. Okay, what did we get here? We got 3, which is good. But why did we get -2 here? Oh, greater. That works on that case. What about what's happening on this case?
So if it's not, just
Basically, we can just do a regular binary search.
damn, this solution's way harder than the one I did.
Wait. We're gonna return the left and we're gonna turn the right. Keith will dip after this one.
Keep it.
We'll call it night after. Pretty much largest, smaller, we're taking left. That will return us like the very left element. Let's just always return left here. And here we'll return the right. Okay, perfect. So 1 0. If index of smaller is greater than index -1, -1. That solves that case. What about this case? What's happening here? So, we don't even return 6. I'm just gonna implement a simple binary search. Def.
Bro, how many functions in this?
I know I could like probably do that simpler, but I'm cooked right now.
Hard code that.
While left and go right. Return. False. If nums mid equals to target, return true. Elif if the like that do mid -1. So if the middle is less than the target, we move that up. So we'll do if self dot binary search for the specific in nums specific target. If you want to start learning from what do you know so far about coding? Did you go to school or anything, or just learning from scratch? Yo, join my giveaway, and actually I can help coach you. Let me bring that up. Dude. Okay. Join my giveaway. I'm gonna send this to you. I have so much code right here. John, give advice because you're just learning from coding from the start.
Any guide if you want to start learning from basics? I did Codecademy. Codecademy is giving me some pretty good knowledge, eh?
Yeah, but you're mixing like projects, theory, everything. You're going crazy.
I don't even know. I think just get started. Focus on just honestly, don't learn, then build, and you'll learn from that. If that makes any sense. Like I would say don't do it like kind of do the tutorial, but like think about a project that you really want to do and then just start learning code to complete that project, if that makes sense. That's what keeps me motivated. But yeah, like really what I did was I bought this course on Codecademy and then I'm using that to learn. But do you want like a free approach or like a less expensive approach? Like I use also ChatGPT to learn how to code. I'll show them after.
Oh, you're in high school, damn. That's crazy.
Yo, you're in high school trying to
Trying to learn
and
how to
watching
code,
this
that's
stuff?
crazy.
That's crazy. That was like me with finance.
Yeah, teach him how to code because you just learn how to code.
Yeah. I'll show you how I learned how to code from the start without using like a course. Could you buy a course or nah? You kind of have to like brute force it by yourself. Mechatronics engineering, though?
This guy's going crazy.
What the heck is mechatronics engineering? That sounds complicated. Yo, tell them we're going back online tomorrow again.
Yeah, sure.
Yeah, tell them right away. What's your budget? Because I have a free method of learning how to code, which I started with, but then
The runtime.
why is it taking so long to judge? Golly. Okay. Yeah, I'll show you how to code. I'll send the what's it called? So I use like a ChatGPT prompt. I use a ChatGPT prompt to make myself a course using ChatGPT. That one's free. That's like a free method of learning how to code.
Dude, I hard code the crap out
Holy
of this.
crap. Wrong answer though.
Wait.
What's a DS and algo class? Oh, data science and algo. Holy. This is dope coming from somebody who doesn't know coding at all, man.
Yeah, bro. I'm just cooked. That's the part. That's the one part.
Yeah, look at how long this stream
This
is.
this stream has already been 7 hours of us just straight doing leak code questions, bro.
7 hours? Holy.
But we're gonna come back on soon, tomorrow, maybe even tonight, and
Solve this. Let me run
Wait, I'm close,
enumerate
I'm
on
close.
this. Let me run enumerate on this after.
So I'm doing a binary search to get the largest smaller.
What do you do
and
in
then
finance? Asset management. Data structures. Shop Peralta CFAs. Stop, bro. Stop. Yeah, I'll show you my method of
Okay, I'm doing a okay.
data structures.
the-
Oh, okay, it's not data science.
If the nums.
See, I'm a big donkey, man.
Index.
Like I don't know what stuff is. Okay, chill. I'm taken by a couple different people. So you gotta get in line, no cap.
Index of.
I need to remember what DS is. Data science.
Who gave me this question?
Yeah, who gave you this question?
Let's go.
Holy.
Let's go. Who gave me this question?
Beats 100%.
Who gave me this question?
I think Google guy gave you this question, right?
Well, I have to cook up like 3 binary
Or was it-
searches.
Or was it awesome guy? Yo, let's run
Dude.
through this code. What the heck?
Google guy cooked me. What's the real answer? No, they probably just do it all in.
Okay, tell me what this complexity is. Yo, Caesar, I think you're gonna like my solution.
2 binary searches. I did 3. But overall, runtime complexity is still log n.
Okay, let me
Alright,
let me
we gotta
run.
go eat.
No. Let me run. Okay. Okay, Caesar. You know,
Yeah.
the other day, remember I learned enumerate? I'm gonna do enumerate to solve this question, but it's not gonna be log n. Where was that? Enumerate? Of course. Do you know what enumerate is? Wait, which question was that? Which question was that? Self join? Do you guys remember what that was? Find first and last, right? This was the question, right? Of course I'm gonna use can't forget your enumerate, of course, man. How do you comment? Watch this. Wait. I commented out the function, yo. Okay. Self nums target. For nums enum equals let's go nums and index for index nums in enumerate nums. Let's see if this worked. Print nums enum run. What solution? What is that? Why isn't this working now? Yo, why isn't my code working? Why can't I print? What's going on here? Do you guys know what's going on? Why can't... Why is this busted? Oh no, because I have to use the reset. Let me reset this. Let me copy this though. That's my favorite function. Command C, right? Command V. Index. Whoa, where's my? Aw, man. Nums enum equals nums, like, let's just go element index or index element in. Yo, what's up? But LG, no need to reset. No need to reset. Ah, it's gone, bro. I didn't even write that much code though. Min int into max equals 0. Print. Let me see if this even works. Invalid syntax. In. This is what happens when you don't know how to code, but you're just running with it. Why is this not right? Is that not something that, how do you call infinity? Let's just make a big number here. Right? No. How do you call negative infinity? Yeah, we'll fix the lag chat. I'm not at my, like, if we did this at my house, okay, my bad. But yeah, on the next one, we're gonna try to, what do you call it? Capital L. Like that? Negative infinity. Max is equal to 0 and min is negative infinity. Like, can't I just call 0 on this? What am I doing, bro? I don't need to do anything fancy. Print nums enum. Why is this not running? Okay, perfect. So all I have to do is return the index of 8 for element in nums enum. If element 0 is equal to target, if the thing is equal to the target, then put another if statement. If element is less than no, I might have to run a pointer on this one. You initiate a pointer. Pointer equals 0. Yo, what is this janky approach? What do you think about this janky approach? I didn't hit the Excalibur. I'm spamming what I know. If what do you call it? What am I doing here? If element is equal to this, if pointer is equal to, if pointer is less than min, pointer is less than min, then min if pointer is less than min, pointer min equals pointer. Yo, even if you somehow mention your way to solution, the code wouldn't even accept your solution because the question says code should be in log n time complexity. I
Yo,
know.
Give a new question. Give a
Oh, dude, should I do a new question?
Yeah, give him
instead?
an easier question. He's still new.
Yeah.
Man, let me know what you want to eat.
Bruh.
I'll drive to grab you food.
What?
I'm gonna drive to grab you some food. Give him an easier question. I already just solved this question, Google guy. Did you see my solution?
Yeah, I just wanted to spam enum. I don't know why. I'm itching to use it.
Google guy, what do you think about my solution?
Do you? No, why'd you retract? Why'd you retract? Why? What?
Okay, we'll just get you some.
Yo, is this even working?
No, stop doing this question.
Why?
Do some questions.
Majority element. Okay, fine. We'll do a different question.
It needs to be
Aw,
easy
man,
questions,
golly.
bro. Give him easy. Do majority element. I want to pick you up some food, bro. Keep it running.
Majority element? Is that even a thing? He already did this question though.
No. Did you do it too?
How do I I don't want to see the answer. I did it in 2 binary searches.
What a beast.
Holy moly. Yo, this chat is going off. Given
Dude,
an array
Is 3 searches negative signal?
is 3 searches a negative signal? Is using enumerate on every question a negative signal? Cause like it's minimum n space complexity. Majority element. Given an array.
Hold it down. I'm gonna go hang with you for a bit.
Return. Given an array of nums of size n, return the majority element. The majority element is the element that appears more than n over 2 times. You assume that the majority element always exists in the array. Weak higher for sure. Oh golly. What do you mean by negative signal? Negative signal is basically like how what's a negative signal? Explain it.
Like, I don't know. Like when you're
Good.
doing it, negative signal is just like when they do
Could I have
something,
some
but
of that
it's
lotion,
more
too?
of a negative than a positive. Like, if they don't drop the constants when calculating the big O complexity, or they don't take the largest term, I take that as a negative signal.
Yeah, like a positive signal is they know how to like
Positive signal is they don't.
they have a good demeanor as a positive signal.
Yeah, for example, negative signal would be like they just jump straight into coding without talking through the solution.
Yo, this isn't I'm not trying to get a job though. I'm doing this for fun, so leave me alone. I can do it however I want. Given a ring.
Yeah, kind of red flags, but that's more like red flag is a bit more extreme. Red flag is like, oh,
He's really mean.
I suggested some approach, and then they got pissed. That's more of like a red flag. Negative signal is just like maybe they just did something that was less favorable.
Hey, James, get me a Big Mac.
Alright.
That might be what I want.
You want a Big Mac?
Something cheap.
Just text me.
Or not cheap, like I just want a sandwich, like cheap in calories.
It's easier.
Yo.
Just come over, bro.
Yo, James, send this in your chat GPT. I'm on a cut right now. Don't starve. I'll show you guys what I was trying to do in 2024. James, could you send this to the could you message this in chat GPT?
What?
Wait. Health. Yo, I'm cutting so hard in 2024, man. Nah, get something healthy? Like what?
What's healthy these days?
Okay, yo, go on your chat GPT and then just like do this. Just like go on your chat GPT and then like do a plus and then attach photos.
Why?
For reference, so I could show them my weight progress. Just
Reference
do this.
where? Oh,
Like for reference, and then I can open your chat GPT and it'll be there.
let's see. Do sure.
You know what I'm saying? Yeah, I just sent it to your text. Yeah, do it. But yeah, get a salad, John. I'll show you guys what I've been doing in 2024. So in 2022, what was my goal in 2023? Was surpass the FA. 2024, January 1st, I went on a big cut. Big cut. And then 2025, I don't know what my mission is in 2025. PNM, if you know Drake, that's my mission. I'm just kidding. But I'll show you my progress, man.
Kids there.
I don't know if I want to try to get buff in 2024. I kind of don't care about that.
Okay.
But I'll show you my weight. So at the start of the year, can you guys see that? No, you can't even zoom in on the pic. But the top of this line is 180 pounds. Right now I'm like 152 pounds. So I lost like 28 pounds this year. That's why I have like I don't know, I'm just a little cut. That's why I'm used to like not eating, bro. Get him that salad. Okay, which question was I supposed to be doing? Give me McCrispy. Is that bad? Should I just ask like a 6-inch, what do you call it? Ham sub from Subway. All the veggies except spicy. Spicy. And what's your guys's majority element? Where was that? Wasn't I doing it? Majority element? Given an array of nums size n, return the majority element. The majority element is an element that appears more than n divided by 2 times. You may assume that the majority element always exists in the array. Minority element. What? Majority element. So there's only 2. Like how? What are the cases? Okay. How do I do this one? Majority element. So can there only be more than one function? Did you get my order? It was just a 6-inch sub. That means the
Subway?
4 of n divided by 2. You may assume that the majority element always exists in the array. Okay. Counts. I'm just gonna do a dictionary for, or is this a set? Can I initiate a set first? Set. I'm gonna do a very janky solution, man, for element in nums. In nums, counts dot append element. Let's return. Let's see. Does that even make sense? Maybe I make this a dictionary. Print counts. But yeah, I'm doing the jankiest solutions because I'm like a big donkey. What's the approach?
See, this guy just went straight into coding.
What's the approach? Okay, I'll tell you what the approach is. Yo, how do you do a snipping tool? Is Santa real? There's no such thing as a free lunch. If you're getting free toys,
What is this?
it's not. It wasn't free. There's no such thing as a free lunch, man. That's all I have to say. Santa's giving. There's no such thing as a free lunch, man. That. What's the approach?
Just draw here. Commands you. Learn how to use this.
How do you make a text box?
Where's my wallet?
How do you make a text
You don't
box?
need to know to do checks. Or click E.
Okay, can I exit some of these? Because I'm getting
Yeah.
cooked with these. Majority element. Okay. Weight
It's on my
tracking.
wallet.
Okay, I want to keep that though. Oh God. Okay, what is the approach? Well, what I'm doing is Command C. Then, do you guys know how to make a text box? AI? Yo, how do you make a text box? Add comment. Oh man, I'm gonna have to do this. Let's say 3, 2, 3, right? 3, 2, and 3. Right? So basically, what I'm gonna do is I'm going to firstly gather, like for every element, I'm gonna make a set. That way, I can make some keys for a dictionary. Does that make sense, Caesar? Does that make sense at all? Wish me Mr. Luck. I have a big exam tomorrow for electronics. Hell yeah, run that. Of course, man. I wish you the best. Yo, Caesar, does that make sense? You're not right track. You're not on the... I'm not on the right track? I'm gonna be on the right track. You'll see. But then what I'm gonna do is I'm going to, like, once I get the set, I'll make it into a dictionary. So then I'll take this set, make it into a dictionary. Set. And then, what do you call it? Once I have the dictionary set, I'll just like iterate through the dictionary and then I'll just pull like the index of the max. You know what I'm saying now? Yeah, that's right. That's what I know how to do. Counts.append element. Set has no this is a set, isn't it? Right? Print counts run. Runtime error. Dict has no counts dot append. Why is this so confusing? Let's just make it an array. Oh man, if element not in counts dot append element, else continue. Yo, I don't know any way that I don't know any other way. Continue. This should make a what's it called though? Like this should make a set in, I think. If element not in counts. This should make a set. So now I kind of have a set without making a set. Right? For but yeah, now that I have a set, I could just be like for element in counts. For element in counts, and then I'm gonna make like counts with what do you call it? Counts with yeah, just store the unique elements in a hash map and just print the element with the highest frequency. I don't even know how to make a hash map though. I'm gonna make an array of arrays. Unfortunately, I don't know how to build a hash map. That's crazy, right? But I'm gonna tackle this lead code question with my limited knowledge. Counts with frequency. Just return. Counts with frequency. Am I doing that though? So like this? Is that what you mean? Is this how I make a dictionary? Let's try it. Counts with frequency. I hope this is how you make a dictionary. For element in counts, if for element in counts, if element is equal to the target. Wait, why can't I just do this easily? Oh no, I need to get the max. For element in counts, if element not in counts with frequency, I'm just gonna initialize a number, right? Counts. Whoa, what the heck did I do? Command Z. Did I do anything? Command Z. What did I do there? If elements not in counts. Element not in counts. Then run this. Counts with frequency. If element not in counts with frequency, counts with frequency element is equal to 0. Otherwise, counts with frequency element one plus equals 1. Return counts with frequency. Is that how I run this code? What? Not a valid integer. Yo, where am I going wrong here? 032 is not a valid value for the expected return integer. So somehow I'm screwing up. Line 48 in driver. Do I even have 48 lines? Nope. Is this it? Element plus equals to 1. Run. Do you guys have any hints for why this is going wrong? Dict must be a string. What? Counts with frequency. Element plus equal to 1. Why am I going wrong here? Counts with frequency. If the element is in here, not in here, counts with frequency is equal to 0, right? Element plus equals to 1. Why can't I do that? Maybe I'm returning something wrong here. Print counts with frequency. Run. There we go. Okay, so now I have. Why didn't this print though? If element not in this counts with frequency. Yo, Natu, you're on speaker though.
Okay.
Yeah, why am I doing this? What's going on here?
It's because you, wait, bro, put that thing down. I can see it.
My bad.
It's because, pretty much you're saying if element not in counts with frequency,
If element not in counts with frequency, for element
Yeah,
in,
like so like let's say you go through it the first time,
yeah,
then you have like the number one. So like if you're looking at like the number one, it's gonna hit the else condition, and then you're gonna say else one, like you're gonna initialize it, but you're saying plus equals one. It's like the plus equals side of it doesn't exist. You can't say plus equals one because you haven't initialized it to be zero. So you just have to flip it.
I have to flip it
Yeah,
like this.
okay, go. Okay, here. Add a print statement in your thing.
Add a print
In
statement
your
in here. Okay, 1 second. Oh man, the reinforcements called me instead of calling reinforcements. Holy, you know you're a real one though.
Your
Print
lifeline, your lifeline.
print counts with frequency. That even makes sense.
Or like,
Print element.
you could just see it. Like, it's easier when you see it.
Should I print? What am I printing? Print counts with element.
Go on like, or my thing's not live, so it's kind of hard to tell what you're doing. But if you go, it's like a 2-second box. But if you go to, yeah, you can print count. Just print count or print element, essentially above your conditionals. Just print the element first. Print the element and then print your hash map. So
Print the element.
comma, yeah, print element, comma, hash map on line, in between line 11 and 12.
Print element, comma, the counts with frequency.
Yeah. But put that on line like
13
in
now.
between line 11 and 12.
Okay, yeah, counts with frequency. Oh man, this is getting tough.
No, you're pretty close. You'll see it once you print the stuff. But put it in the for loop.
Put it in the for loop. What?
Yeah, like your thing is not in the for loop right now. It's above it.
Like this. Whoa. Does that make sense now? Run. What? What am I printing here? Why am I printing so many random things?
No, just so you can see it for yourself. Like,
Yeah.
pretty much there's a bug, right? So you just want to look at it and remove the print on line 15 so it doesn't confuse you.
Yeah, I deleted
Okay,
all
I
those.
see.
Okay. So now what?
Okay, now, like, look at that print and then start working on the problem.
Look at that print and start looking at the problem. Oh no. Why is the 3 outside of the counts with frequency though?
What do you mean? Because that's the element. You put element, comma, counts with frequency.
Oh, okay. Am I just not putting in
Yeah.
I'm just not initializing the element though.
No, now it looks good. Now I'll let you work on the problem. Like, I'll let
What?
you just work through it.
Oh man, okay. I don't know if it
You
looks
had an error
good.
earlier.
Yeah, it's working now, right?
Yeah.
But why is it okay, peace.
Don't worry. I won't give you the whole answer. I'll let you.
Yeah. Okay, peace. Calling the lifeline. Oh man, I'm a literal donkey with this stuff though. Okay, for counts with frequency for element in counts. So now I'm good, right? Let's see what the counts with frequency looks like though. Print counts with frequency. Run. Okay, now I have like the individual numbers. But why isn't it adding to the frequency? Else counts element plus equals 2. Like why am I not adding to the what's it called? Yeah, why am I not adding? Why am I not adding to the two? Okay, anyways. It looks like it's working. If element, step through your code and you'll see. What the heck? I don't even know how to step through the code. That's the problem. Step through your code and you'll see. Oh, this is freaking embarrassing. For element in counts, if element not in counts with frequency. So I know this one is doing it right. But if the element elif, do I make this a elif statement? Chill with the sliding, brother. Brother. Like step through an example by hand. I see. Okay, let me slide a little bit up. Okay. For element in counts, if element not in counts. Oh no. Lifeline number 2. Yo.
Yo, lifeline.
Yeah.
Yo, what I mean when I say yo, stop sliding the thing though too. It's hard for like people to see the code if you keep blocking it.
Oh, okay, my bad.
But I was saying like if you step through an example, like if you look to the side, example 1 has 3, 2, 3, right?
Yeah.
Like you should be able to like iterate through 3, 2, 3. Like okay, first you have 3. You're going for elements and counts. You have a 3, and then you can see like oh you put the 3 in the hash map. Okay, let's add 1, and then you're like okay we're on the next iteration. Now we have a 2.
Yeah, this should be a 1 though. This should actually
No,
be.
I'm saying like you have to like step through it like that, and then you'll be able to really see. That makes sense.
Nah.
Okay,
I'm not sure what I'm doing wrong. Like I initiate the counts with frequency dictionary, right? But I'm not able to add to that key.
You're not able to add to that key.
Yeah, do you see like in the std out? I have all the numbers, so I have the keys,
Yeah.
but I can't add another one after.
Yeah, because you're iterating through counts, not nums, right?
I'm iterating through counts, not nums.
Yeah, like you're on line 11.
Yeah.
You're going through counts, right?
Okay. So I just have to make another one after that. I see what you're doing. Yeah. I'm gonna just make another dictionary, or I'm gonna just do it again here. So like for counts in counts with frequency, if counts with frequency counts.
You could do it in 1 though, to be honest.
Oh, can I?
Yeah, like if you just go to the top of the top of the code.
Yeah.
Hold up, I need to wait for my stream to catch up.
Oh man, okay, we're gonna fix that. Take a deep breath.
Yeah.
Yo, why is this not doing it right? For counts and counts with frequency, if counts with frequency is equal to
Wait, once my stream
counts?
catches up, I'll show you at the top. If you scroll to the top. Your food is on the way. Is that James Peralta?
Oh yeah, maybe.
Oh no, that guy just knows that the food's on the way. My bad.
Plus equal to 1.
Have you scrolled up to the top of the code though? Scroll up to line 1.
this even making sense?
Wait, John Peralta CFA.
Oh God.
Bro, scroll up to line 1. Scroll up to
This
line
is
1.
line 1.
Okay, there, now I can see. So look. At line 3, you
Yeah.
have like a count array.
Yeah.
Why don't you just... Okay, this code is getting crazy. This code's getting crazy.
Does this make sense though? So I have the counts here.
Wait, what are you trying to do is the question.
Right now what I have is, see in the std out, I have like a key value pair.
Mm-hmm.
Now every time that I want to iterate through counts, if I see counts again, I want to add a +1.
Yeah, but you have to print your counts array.
I have to print my counts
Like,
array.
if you... Like, print your counts array on line 9, and then you'll see why your standard out looks like that.
Print counts. Run. Oh man, lots of negative signals in here. My std out is 3 and 2.
Yeah, is that what you're expecting?
Yeah?
Oh, okay. Yeah, you're going with like a different approach.
Yeah, right? So I have like 2 and 1. Now when I print counts with frequency, so if I go to print counts with frequency, counts with frequency.
Are you trying to get the frequency in a hash map?
Yeah, basically, right? Because now I have this hash map. So see the std out? I have like a hash map for every single figure in nums, but I can't seem to add a +1.
Why don't you... Okay.
Right? So if element
But you...
elif, maybe if I do a elif function, elif
But to simplify the code, John, you could just like...
frequency.
You can just iterate through nums and then start counting with your hash map. That'll only take like 1 loop.
No, I don't know. I don't even know how to do that though.
No, look, like if you just delete everything except for line number 10.
Okay.
Except for line number 10, just do it. Delete everything except for line number 10.
Oh god. Command Z. Okay. Oh
And
man.
that counts with frequency.
Yeah.
Wait, let my stream catch up for a sec.
Counts with frequency.
Yeah. And then you can start like just keeping track of a count by iterating through nums, you know?
For nums. For num in nums.
Yeah, exactly.
In nums.
Does that make sense?
I don't even know. For num in nums. What? Why is this broken now? The heck? Okay, interesting. Counts with frequency. If num counts with frequency. Man, I'm struggling with this.
No, you're like on the right track.
For num and nums, if is not if. I just don't know how to add to a hash map. That's the only thing.
You just say plus equals 1, like you did earlier.
Counts with frequency. Why is that linting like that though? Print counts with frequency. Run. Invalid syntax for num in nums. Invalid syntax. Just like is this one of those reserved functions?
Invalid syntax. Yeah, you have two in. You're saying in twice.
No. If counts.
But yeah, your first problem should just be like, how can I have the frequency of the elements in an array? That should just be like step number one. If you can do that first, then proceed with like.
But didn't I already do that initially on my code? It worked. Like I made a hash map.
No, yeah, but your hash map all said one. Like the count of your, it should be like a 3 appears twice. You know, like 3 semicolon 2, and then the 2 should be semicolon 1. If that makes sense.
Right.
Yours was just all 1 1 1. So like you were close, but some of the logic was off. So just get the frequency of the elements in the array first, and then do the rest of the problem after you do that.
Yeah.
Okay, let's find out.
Nah, bro. If element.
What?
Why is this not running?
Okay, look.
Two.
You're saying, because like, look, you're indexing the hash map, but on the first iteration, the hash map doesn't exist. That's why I recommend like always just printing like in each iteration so you can see what your hash map looks like and what element you're on.
Okay. Counts with frequency.
Does that make sense?
What?
Like John, on line, in between line 10 and 12, just print your element and print your counts with frequency. Then you can at least see like what each iteration looks like.
On line 12? So I print
Before line 12.
line 12.
No, above that, outside of the if statement.
Outside of the if statement? Okay. Print element.
Comma, counts with frequency. So stop blocking the code.
Counts with frequency.
Yeah.
Man, everybody dipped. This is way too annoying.
Way too complex.
Let's see, run.
Ooh, yeah, where you at?
Print. Expected it to block.
Count with frequency. Yeah, I'll let you do your thing. I'm moving the viewers, man.
Huh? What?
Yeah.
What?
Now removed. Who, me?
What? I'm not getting this question.
For the indentations, incorrect. So just click tab. Yeah, just remove that. You can just say like continue under
Oh.
or something. Just put something there. So
Everybody had to bounce. Continue, run. Oh, it's not actually adding to it? Element.
yeah, like that's my point. Like you can now on each iteration you can see like, oh, you did the 3, that's your number, and then you have the counts with frequency, and then like you can check what should happen, you know, where depending on where you put your prints.
Bruh.
Does that make sense?
Yeah, a little bit. So if element not in counts with frequency, then somehow I have to do like counts with frequency. Put an element.
Yeah, exactly.
And then equal to plus equal to 1.
If it's not in though, it's not in. That means like it's never been in there. So you can't say plus equals. You have to say just equals 1. Does that make sense?
Yeah. And then if it is then there, and if it is in there, then I do the plus equals too.
Hell yeah. Oh, my fault. No cussing. Heck yeah.
Command C. Command
D?
B. Wait, why? Like my code was. That's what I had my code as initially, though. I'm so confused.
Nah, you were like iterating through the wrong thing. You were iterating through counts and stuff like that. Now you can even get rid of the thing above. Like you don't need lines 8 through 3. Like you can just delete that, and this is just all you need.
Print counts. Now it's counts with frequency. Counts with frequency. Counts with frequency. Run. Oh, okay. Interesting. So somehow not. Yeah. Now I somehow did it though. Okay.
What do you mean you saw I did it? You coded it.
Yeah.
Can you print counts with frequency? Yeah. If you remove 8 through like the beginning of your stuff, like you already did that now. If that makes sense.
So I hit run on this. That guy on the phone is good. Nice. Now my output is null, but I printed 3, 2, 1.
No, like you're not returning anything, so that's why.
Yeah.
Your print is good. Okay, I'll let you do the rest of the question.
Oh man, I can't even get the max key. All right. Okay, yeah.
Okay.
Peace.
Use this knowledge. Okay, peace.
Yeah, peace.
Good work.
Oh man, I could not answer this. My brain is cooked, to be honest. So now what I'm gonna do is I'm gonna initiate a maximum, max equals 0, for I in range length of nums. For I in range length of nums, if nums for I in range of length of counts with frequency, Oh, this is so scuffed. For I in range, length of counts with nums, if counts with frequency I is greater than or equal to greater than max, max equals counts with frequency I. Oh, what the heck? Counts with frequency I. Then I'm gonna do return max. Run. If counts with frequency I is greater than max, why is that not working? Line 13 in majority element. Maybe if I do this, maximum val, return maximum val, run. Yeah. STD out. Like, why is this not working now? Oh, why isn't this working? Max equals counts with frequency I. What is wrong with line code if counts? What? Maximum value line 13 in majority element solution dot pi. Oh, is it supposed to be an int? Should I put an int here? Maybe that works. Oh, I see. Maximum val run. So do that later, but your way is good too. Why isn't this? Oh God, I did the thing. Oh God, what? Oh my God, the code disappeared. Now I fixed it. What? Maximum val run. If counts with frequency I is greater than, why is this not working? If counts with frequency I, return solution. Why is that not a thing? Counts with frequency I. Oh, I. For element, add some prints. What is it going on here? Oh man, I actually got lost in the sauce. If counts if counts with frequency I is greater than the maximum val, like that other guy was saying. Oh, you know why? Because this is a number. For element in for key in counts with frequency. Key turn int run expected to, but expected to, no, I just have to return. Oh, okay, now I somehow got 2. So now I have to so now if for element in counts with, so now that I have maximum val, I can just be for element in counts with frequency. No, I could just make a pointer, right? For I in range length of, now I'm just spamming everything I know. For I in range of counts with frequency. Maximum val is wrong. Print. Bruh. What? Number 13, line 13 is wrong. Yo, James, pull up. After this, I'm done, bro. Oh, man. like what I was gonna do is maximum val if for element in counts with frequency, if counts with frequency element is equal to maximum val, return
You ready?
return element.
You cooked.
Yeah, I'm definitely cooked, man. Run. Accepted. Submit. Nah. I'm a hang.
Go.
Holy.
All right, everyone. We're gonna
Yo, I
catch
actually
y'all.
solved it somehow. I don't know what went on there, but it worked. Yeah, what the heck is going on
Not
there?
caught up yet. My thing's not caught up yet. Okay, nice.
Why was this so confusing?
Yo, Natu, when do you get here again?
Oh my god.
Oh my.
Doxing.
I get to December 20, buddy.
Oh my, that's so far.
Okay.
All right,
Yeah, yo.
stream. We'll catch y'all.
Sorry everybody for that scuff. That's
That's
a big
crazy.
L.
8-hour stream.
But yeah.
Right on the dot. We'll be back for another 8-hour stream soon.
Marathon.
Huh?
I'll be there for the marathon.
Yeah, we'll do
Yeah.
that. Okay. I'll
Okay,
catch you.
peace out. Peace out everybody. Thanks for tuning
Thanks for joining in. Follow John Peralta CFA.
Oh, okay.